Hello everybody and welcome back, and in this lecture we will start by coding our advanced packet sniffer. Now by packet sniffer I mean some tool that will perform the network analysis for us on our own machine. So this is not something that you can actually use in order to hack something or brute force something or do something like that, but I found this program because I actually had it for a long time right now. I don't even remember from where I got it. It's been sitting on my laptop for a few years, and it is a really good program in order to get in order to understand the packets on a more detailed and on a more advanced level. So this is for sure not a program that we will code for the beginners. So if you're not so if you are a beginner, make sure to actually get everything else done, then you can come back to this. Also, you will need to do some actual learning on the side here and there. I already have the program right here on my laptop. We will code it together for the best practice, and I will explain everything as we go. What this program will do is it will actually run an analyzer of all the packets that we receive. It will split them in fields, but you might be asking right now, aren't we doing that all the time in the previous section with the actual Scapy library? Well, the thing is right now we will not be using the Scapy library. We will be doing everything manually and trying to get the packets and fields and all the necessary things printed out by ourselves. We will not use some library that will help us do that. All we will use is the socket library, which is low-level networking or low-level network programming. So let us start off by actually calling this program. We will call it, for example, packet sniffer. So let me just go out of my local networks, and let's make a directory packet sniffer, since this will most likely be the biggest program that we will actually code from now on. And let us call it, so go to the packet sniffer, change the directory to the packet sniffer, and right now, since we call the directory the packet sniffer, we can call this sniff packets.py. We will make user bin Python. Now this is not really a sniffer that you can sniff the usernames and passwords. As I said before, this will give you an in-depth knowledge of actual protocols, the protocol fields, the Ethernet headers, IP headers, TCP, UDP packets, and so on and so on. So first thing we want to do is first of all import the necessary libraries, and as I'm seeing right here, we will need 4 of them. So one of them is the socket library. We can import it with the import socket. We can we'll need 5 libraries. So also we will import 2 libraries that we didn't use before, I believe, which one of them is OS and one of them is the sys library. The next thing we need to import is the struct library, which will allow us to actually separate the fields of a packet that we receive. As you remember, previously we saw the struct library table, which allows us to actually specify the number of bytes we want to take in a certain variable or something like that. We will be using that right now extensively. And also we want to use the bin ASCII library, which you specify with the actual .I. So first of all, before we do any of that, let us check out if we have all of those libraries in our Python 2. Import bin ASCII, it is there. Import struct, import OS, sys, and import socket. So these are all standard libraries, so you will actually probably all have them. In case you don't, you can just run a standard pip install and then the name of the library, but you will not need to for this program. Now I must admit I don't really remember what this bin ASCII library is for, but once we get to the actual function from the bin ASCII library, I'll make sure to tell you. So first of all, what we do in this program, we will create the main function which will perform the entire process, and it will call some other sub-functions which will actually analyze different types of actual packets. So for example, we will have a function that will analyze ether header, we will have a function that will analyze the IP header, the TCP and UDP also header. So first of all, we want to create the global socket object, which we will use since we will use it in every other function as well. We need to set it to be a global variable, so call it global sock underscore created. And you also want to create another actual socket, which will be global sniffer socket. So it will be a global variable as well. So make sure to specify global before giving it any value. And what we want to do is actually, first of all, make our sniffer socket to be a socket object, and we can do that with if sock underscore created equals to, for example, false. Now you might be asking, why are we setting it to be equal to actually false? Well, before we actually call this function, what we want to do is before the main function, we want to specify that the sock created, so sock underscore created, will be equal to false, and the sock, or pardon me, sniffer socket, we called it like that, will be equal to 0. So we said the sniffer socket will be equal to 0, which it means we didn't actually set the socket object yet to this variable, and the sock created will be equal to false, so we can perform this part right here. So if sock created equals to false, it will perform something in the if loop. Since it is equal to false, we will code the part that will perform for sure. So let me just tab this till the end. And what we want to do is actually make our sniffer socket to be a socket object. We will use socket.socket, and in there we will use socket.pf underscore packet. We will use socket.sock_raw, so we can use actually the entire raw packet, and we will also specify an option socket.htons, and in there 0x003 or 0003, pardon me, I always forget 10. So what you want to do right now, what this means is what we want to do is take the entire packet and we want to do what we want with it. Basically the 0x003 will be the Ethernet packet which we will then analyze in more depth for the IP headers and other headers as well. Now what you don't want to do with this actual socket is you don't want to perform the bind function, since this is an actual raw packet or raw socket, however you want to call it, and it should not be bind to any specific port. So we are not going to perform the bind function. All we want to do right now is actually set the sock underscore created to be equal to true. So we successfully set our sniffer socket to be equal to this socket object right here. We set 3 different functions to it, and after that we set the socket created to be equal to true. All we want to do right now is receive any data from our ports, which we can do with data underscore receive, which will be a variable that will store the data, and we will run a function receive for that variable. So sniffer underscore socket, which is the socket object. Oops, not another equal. We want to specify dot receive, and in the brackets right here, since I don't think we actually use this function receive, or we might actually use it in the port scanning section, but what this function actually takes as an input is the number of bytes that we want to receive from our actual server or from our ports in this case. So 2048 bytes, that is the number that we want to receive. And after that, all we want to do is actually clear our screen, which we can use the OS function, or OS library, pardon me, which we import, I believe, for the first time. This library right here has a function called system, so os.system, which allows us to execute system commands. Between the brackets, all we need to specify is clear, since this is the actual command that we use to clear our screens. And after that, we want to use our data receive in order to analyze further on our Ethernet header. So what we will do is, first of all, we will tab data underscore receive and IP underscore bool will be equal to the analyze. Let me just check this out. Analyze ether underscore header from the data underscore receive. Now, basically, this analyze ether header is a function that we will code right now. This is not a function that actually exists. We need to make it before we actually do anything else, and it will store the data, the returning value to the data receive and to the IP bool, which the IP bool will actually take the value of true or false. So all we want to do right now is actually code the function the analyze Ethernet header, which we will do right here. So def analyze underscore ether underscore header. It takes an input of data underscore receive. So, whoops, I can't type. So it takes that value, and first thing we want to set right here is the IP underscore bool to be equal to false. Now if the function performs correctly, we will set at the end the IP bool to be actually equal to true, and then we will proceed with our main function further on. So first thing we want to do is something that we did in the previous videos, which is actually extracting the Ethernet header. We will use the same command, which is the struct, which is the actual function that we will use from the struct library, which will allow us to actually take the first 14 bytes, which is the amount of bytes that the Ethernet header can store. So we will use a variable called eth underscore header, and then we will use the function from the struct library, so struct.unpack. And if you remember, this function actually takes two inputs. One of them is the actual pattern for specifying the amount of data, and the other one is the actual data from which you want to take the value from. So first of all, between the double quotes, we will specify the same thing as in the previous videos, which is 6s6sh, stands for actually specifying from the struct tables the amount of data we want to actually extract. Then in the comma, after that we need to specify from where we want to extract it. We want to extract it from the data underscore receive. We want to take the first 14 bytes, which we specify with this right here. These two dots, if you remember, means take everything from the beginning, which is from the first or from the 0 element to the 14th element. So once again, this basically unpacks what we got from our sniffer. Since this is the first 6s represents the MAC destination, the second 6s represents the source destination, and these 2 bytes basically represent the protocol attached to the Ethernet header, which we most likely are going to get the IP protocol, which we actually want to get and analyze further on. So this is just us extracting the Ethernet header from the packet. Now what we want to do is actually extract the destination MAC address and the source MAC address and also the protocol itself. So how we can do that? We can just use a variable called dest underscore MAC equals to, and here we will use first time the bin ASCII library. We will use a function called hexlify, which will actually take our destination MAC address and it will turn it into hexadecimal. What this will allow us to do is actually print the MAC address in a different manner than in the previous videos where we actually use the %x in order to print different values of MAC address. Now, if you have no idea what I'm talking about, don't worry, I will show you just in a second. But first of all, let's define this variable right here with the bin ASCII.hexlify. And in the hexlify, we need to specify, since the destination MAC address will be the first 6 bytes from this 14 bytes Ethernet header, we need to specify it to be Ethernet underscore header. And we need to specify the first element. As we said, that will be the first 6 bytes. We need to do the same for the actual source MAC address, which we can just store in the actual variable called source underscore MAC. It will be equal to the bin ASCII.hexlify. And this hexlify will take an input from the second element, which will be the source MAC address, so Ethernet underscore header, and the second element, which will be represented under number 1, and we close the brackets. This is the actual source MAC address from our Ethernet header. All we want to do right now is also select the protocol, so proto will be equal to Ethernet header, and then we need to specify the number 2, since this is the third element, and basically we will specify it to be in a number 8. Now I must admit I'm not really sure why right here we are using number 8. Okay, so basically the 8 will be the IPv4, since we want to actually get the IPv4 protocol later on, since we are analyzing the IP header after that, so make sure to specify it the same as I did with these 2 arrows pointing to the actual 8. And after that, let me just show you right here, we need to take the data to be equal from the remaining data of our packet. So we use the entire packet, we stripped the first 14 bytes, we actually took the different fields from our Ethernet header. As you can see, 3 different fields, each one of them taking the different amount of bytes except this destination and source MAC address. And what we want to do is strip the remaining data to be equal to the data underscore receive, and then from the 14 byte and then further on. Now what we want to do is actually in the next video, what we will do is we will print the statements where we will actually say that this is destination MAC address, this is source MAC address, and this is protocol. Then what we will do afterwards is we will actually set or check if the protocol is equal to the 8, and if it is equal to the 8, that means that it is an IPv4 protocol. We will select the IP bool value to be equal to true. Then we will return the data, which will be set to be from the 14 byte, and we will return the IP bool, which will be set to true, to our main function. And then afterwards, we will check if bool equals true. If it is equal true, that means we got the IP header next, and then we will analyze the IP header. So that will be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye. Hello everybody, and welcome back, and let us continue from where we stopped in the previous video. So let us first of all check out what we did for now on. What we did is basically we sought the destination MAC address, the source MAC address, and the protocol, which we got from our Ethernet header. Now, we also set the data to be the remaining data with the stripped Ethernet header further on. And what we want to do right now is print all the stuff that we actually got. So first of all, we will print something like this. So first few lines, Ethernet header, then remaining lines. So this is just so it can be a little bit prettier. After that, we want to print first the destination MAC address, which will be the strings from the dest MAC variable, and then the source MAC address. So print, and in the print statement, we want to select destination MAC, 2 dots, %s, and then basically 2 dots, %s. We just find where the percent is, and then repeat this for the 3 times since we typed it twice. So let me just copy this and paste it 2 more times. Also add the 2 dots between these 2 s's where it is missing. And here we have the actual pattern for the MAC address. So destination MAC, and now we need to add the values to these %s's, which we can do with the % and then open brackets, dest underscore MAC. We take the first 2 elements, so until the second element, or pardon me, third element, then the dest underscore MAC from the second to the fourth, dest underscore MAC from the fourth to the actual sixth, dest underscore MAC from the sixth to the eighth. And further on, let me just copy this so I don't really type it 2 more times. I will just switch the numbers. So copy, paste, and paste once again. Then I will add the comma first of all so we can separate them. So add comma right here. Also add comma right here and switch the numbers to be from 8 to 10. And from actual 10 to 12. So also close the normal bracket at the end. And if I'm not mistaken, this should be good. So we will be able to actually print the actual Ethernet header or the destination MAC address for now on. What we want to do is copy this entire line, and we will just switch the things that we need for the source MAC address. So copy it, go right here. Let me just go right here, enter and paste. And first thing we want to change is the dest to be to the source. So each dest change to be source, since that is the name of our source MAC address variable. So source, right here also, source, and right here, source. And also right here in the string itself, we want to print not the destination, we want to print source MAC. So everything is good for now on. All we need to specify once again is the actual protocol, which we will use the %HU for actually printing out the protocol itself, which will be a hexadecimal number, which will represent the next protocol attached to the Ethernet header. And then afterwards, if we will check if it is 8, if it is, that means it is an IPv4 protocol, and then we will go to the IP header. So first of all, we need to print it first before checking it. So print protocol, and then two dots, we can specify the %HU, and then afterwards we need to specify the percent and then the variable which we want to specify instead of this, which is the proto variable. So specify proto, and right now afterwards we can actually perform a check function to check if the proto is equal to the hexadecimal. Proto is equal to the hexadecimal of 8. So first of all, not 2, we want to perform 18. If it is, however, that means it is an IPv4 and we want to actually print IP bool, or not print, we want to set the IP bool to be equal to true. So this is a variable that we set at the beginning of function to be equal to false. And right now, since this is the protocol, we want to set it to be equal to true. Since any other protocols we do not really care about, for example, if we get the ARP protocol, we will not analyze it since that would take too much of our time. This program by itself is already big enough for us to actually code it in multiple lectures. So all we need to do is check if the protocol is this hexadecimal value or this byte basically. And if it is, it will set the IP bool to be true. And right now, all we can do is return from this function, but not return nothing. We need to return the remaining data, since we stripped the Ethernet header right now. So we are returning only the remaining data. And we also want to return the IP bool value, which will be true. If it is equal to false, we will just drop the packet. So let me go down here to where we finished the actual, okay, so here it is. We call the function right here. And all we want to do right now is check if the IP bool value, so go down here, if IP underscore bool, that means it will check if it is true. If it is true, we want to analyze the IP header. So data underscore receive, and then the TCP underscore UDP. Now make sure to do not confuse this data underscore receive with this data underscore receive. Let me just find it. Where did we mention it first time? So this part and this part is not the same anymore. This function right here that we performed is storing the new data value, which will be the data value with the stripped Ethernet header, to this variable right here. So right now what we are pasting to this function right here that we will code in just a second is just the remaining of the packet without the Ethernet header. So first of all, we will check the data underscore receive and the TCP UDP, which is a variable that we will call in order to check out whether the program will be whether the packet will contain a TCP or UDP fields. And we will use the function that we will code. So analyze underscore IP underscore header. And we paste to that function the data underscore receive. We close the brackets, and all we need to do right now is actually code the else statement before we call the function. So if IP bool is equal to false, we just want to return, and we don't care about the packet anymore. Since, as I said, all we want is the IP header to be found in our Ethernet header. So right now, all we need to do is code the actual IP header function, or the function that will actually analyze IP header. So let us call it the same, def analyze underscore IP underscore header, and we paste to that function data underscore receive. So first of all, in order to check the available actual fields in the IP header, we can use KP library. Just for a brief overview of the IP header, so you can see there are much more fields in this header than in the Ethernet header. Basically, in the Ethernet header, all we had was the source MAC address, the destination MAC address, and the protocol. And right here, what we have is a bunch of other fields that we also need to cover. So what we need to actually realize is how much of the bytes we need to give to every single field. So let me just close this right here and go to my Python programs and packet sniffer, and nano my sniff packets.py. Right here under the analyze IP header, we need to split the IP header into different fields. So right here, first of all, we need to unpack it. So struct.unpack. And in there, if you remember, we need to specify the actual amount of bytes that we want to actually get from this IP header. And also we want to specify the data receive to be equal to the first 20 bytes. So first of all, we need to specify data underscore receive to be equal the first 20 bytes from the actual data stripped from the Ethernet header. And right here, in order to select that, we need to specify exclamation mark 6H, 4S, and then 4S. So basically what this will do is, if you are concerned about this path part right here, as well as this part right here, also you can just go to the struct tables and check out these values of the code itself. So these are just a bunch of the different interpretation for different values for the actual data that we are parsing to this function. So the next thing we want to do is actually split the IP header into all different fields, but we will do that in the next tutorial, since that will take a little bit more time, so we don't make it too long. And then we will print each of the fields into the IP header statement, as well as checking out for the next protocol that is running, whether it is TCP or whether it is a UDP protocol. In case it is none of them, we'll just select it to be other, and then we will return the data, or the remaining data, that we will actually strip from the IP header after we actually print everything out, and we will also return the TCP UDP as a value for the next function. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our packet sniffer. So basically what we are going to do now is continue analyzing our IP header. So let me open up our terminal, and in the previous video we started off by actually importing the first line of the function. So let us navigate to Python programs and to the network, or how did we call it? Let me just check it out. Packet sniffer. Yeah, very creative. And let us nano our sniff packets.py. Let me enlarge this so everything is good to see. And you can see right here that what we did for now on is, first of all, it's not HRD, it should be HDR for header. And what we did for now on is use the struct unpack on the 20 bytes, which is the actual amount of bytes that the IP header has. So basically we saw the available fields in our Scapia library once again, and all we have to do right now is unpack those fields. Now some of you actually asked a question, now what does this mean right here? So we used it both in this program right here, and we also used it when we actually extracted the source MAC address and the destination MAC address from the previous section. Now basically this is just us splitting these 20 bytes into different parts with our struct library in order to actually be able to more easily split different fields in the IP header. For example, once we used here 6S, this first 6S corresponded to the destination MAC address, so we split it, and we used that 6S in this function right here. The second 6S was actually another 6 bytes, which basically corresponded to the source MAC address, and this capital H corresponds to the remaining 2 bytes, which was the actual protocol that we printed out right here. Or basically we printed out all of these 3 fields right here. So basically what we did, we split the ether header into 3 fields, and we actually corresponded it to this pattern right here. So same we will do right here, but if you notice that let me just open our IP header, has a lot more actual fields than the actual Ethernet header. What we need to do is actually use some of those fields. So let me just lsip. You can see it has a bunch of these fields such as version, IHL, TOS, which is basically the type of service, which is not really that important, but you can see that this, for example, version right here has 4 bits, and basically what we can do is just put these 3 into one actual field and then split it up by the bytes, or pardon me, by the bits. So we can try to do something like that. You can see it has a lot more than the previous actual Ethernet header. So we also have the source and destination IP address, which we know from the previous videos, it should be in the IP header, time to live, some different flags, and the length, ID, and so on. So we will have to actually add all of those fields. So let us nano sniff packets.py, and let us continue with the first field, which is the version field. So in order to actually represent the version field, we can just type ver or ver equals IP underscore header, and we use the first part that we split with the struct unpack command, which will be the first H, which will correspond to the first 2 bytes, I believe. And then what we need to do is correspondence is the version, since first 3 fields of the IP header we will actually place in the one variable, or not in the one variable, but we will actually split it as if it was a one variable. And first, and the version we want to actually arrow to the 12, which represents the 12 bits. Now it will remove the other fields from the version variable, and it will shift this version variable 12 bits in order for us to actually get just the version itself and not other fields as well. We are doing this because some of these fields are a lot smaller than the others. For example, in the Ethernet header, we didn't have to do that since actual destination and source MAC address corresponded to the entire 6S part right here. So we didn't have to actually add it to anywhere, and here we actually do have to do that. The next field that we actually want to print out would be the IHL, which will also be the part of the first split part of the IP header. And we can also add it like this, so IP underscore header 0, which responds to the first element of our list that we created with this command right here. Now what we want to do is arrow it to the 8, but not only arrow it to the 8, we want to use a logical expression with this sign right here, which basically ends, and we want to add a byte 0x0f. Now the reason why we are doing this, but first of all let me just put this in the actual bracket, since we need to have the brackets while ending this. Why we are doing this is basically it will take the data from our IP header variable without the version. So we know that the version is actual first field in the IP header, and the IHL is the second field in the IP header. So basically, if we were to shift everything, we would take the both first fields in that actual variable. But since we already have the version, we do not want to have it once again attached to this variable right here. We will end it in order to lose both the field before and the field after the IHL field. So the next one that will be the last part of the first element will be the actual TOS, or if you want to, type of service. Now, as we said before, first 3 fields belong to the first stage, so this will be the last one. Let me just add it right here, equals IP header, so IP underscore header, the actual first element, which we specify with this 0 in the brackets, and all we have to do is end it with the amount of bytes or bits that we actually have. Oops, not this. I don't want the brackets, we want 0x00ff, which is basically, since this is the last element of our first element in the IP header variable or list, or however you want to call it, we don't really need to do this type of thing right here, since this was the element in the middle, so we actually had to perform some additional logic expressions. Now, if you don't really understand this, basically you can just search logical expressions in Python. It is just some bit and byte manipulation, so nothing really too hard, but for you it might be new. But as I said in the previous videos, this will be one of the more harder programs, if not the hardest programs in this course that we are actually coding. Now, for those of you wondering where did I get this program for, I actually searched it up, and it is actually on the Cybery IT. So there is the example of this program also coded and tested, so you can actually check it out there if you want to. It might actually give even a better and more detailed explanation for those of you who are actually wondering how this is all made. So the next thing we want to actually put right here is the total length of the actual packet, so we will just put that in the entire second element. We're just specifying the 1 in the square brackets, since this will correspond to the entire H right here. So tot length once again stands for total length, and the next one will be the IP ID. We can call it like this. This is the ID field in the IP packet, or IP header, and it will correspond to the entire actual third, or representing the 2 in the square brackets element. Then after that, we have something called flags and flag or frag offset, however you want to call it. Let me just check it out in Scapy. If I said the name correctly, I believe I did, but it's always good to double check everything you're not sure of, since we as hackers don't really need to know everything about coding. Basically, that's what I said in the beginning of the course. We are not coders. We do not care about the actual code being well written. All we want to do is for our code to be actually good and able to run. So you can see I was right. The flags and the frag are the next two fields. We can see the bit field 13 bits and the bit and the flags field 3 bits. So what we will do is we will actually use this to our advantage, and since we can see that flags only get 3 bits, we will have to shift it 13 to the right. Let me just double check everything here. Okay, we can exit the Scapy. So we are approximately halfway to our IP packet. Oops, not sniff jokes, sniff packets, but nano sniff packets. And let us add the actual flags variable. Okay, so we will call it just flags equals IP underscore header. The third or fourth element in our list shifted 13 bits. So the next thing that will also correspond to the fourth element will be the frag offset. So frag underscore offset equals IP underscore header. Third element, and we want to add it to the amount of bits needed. So let me just find the actual. Okay, so here it is, 0x1FFF. Now, I'm not really sure if this would actually work with the binary, but don't try it. I didn't really try it. If you would specify binary, I don't think it will actually work, since there is not really a library that will run the binary itself or that will read the binary itself. I might be wrong, but if you want to, you can actually try the binary instead. So just specifying the hexadecimal values into bits, or into basically zeros and ones. So next thing we want to specify right here would be the time to live. So IP underscore TTL, which stands for time to live, would be the IP underscore header. Fourth or fifth element, however you want to call it, this is the fifth element in the IP header list, and we want to move it 8 bits. Now, since that is not the only actual field that we will use in the fifth element, we also have the IP protocol. Did I just type 8? Okay, so here it is. IP underscore proto will be equal to the actual IP underscore header, and then the fourth or fifth element once again, and we use the same sign for the logical expression 0x00ff. Now, for those of you wondering where I am getting this information from, well, basically, if you want to check out the headers themselves, you can just go onto your Firefox and just type the IP header and see what are the available fields and how many amount of space or memory they actually take. So basically, we know that the entire IP header takes 20, but different fields actually take different amounts, so you need to check that out. IP header structure, maybe we can try something like that, so we can check out the structure of the IP header. We could have done the same with the Ethernet header, but Ethernet header was rather simple, or simpler than the actual IP header. So here it is. As you can see, here is the picture that actually might explain a little bit better for you, or you might be able to understand it in greater detail. So if only it actually opened the picture, IP header format. That is too small to see. Let me just find if they have a little bit of bigger picture. Maybe this is something useful. Not really. Let me go and find maybe this one. Okay, so you should be able to see something right here. As you can see, if I open up the actual program, so you can see the first field, for example, you can see that we actually use the version IH or IHL and TOS as a first actual field that we split with this command. And we can see the version, the header length, and the service type are actually the first three fields, which we actually counted as one while splitting. Then we actually had to do some byte or bit manipulation, logical expressions, in order to get them to in order to get these variables right here to only contain the information from that specific field. Then, for example, the total length was entire one field that we split, so we didn't have to actually do anything with it. We just set that to be equal to the second element in the IP header variable. And afterwards, we continued with all other things as well. So we are currently right now, let me just see, we finished time to live. Here is the protocol and the header checksum. You can actually you can realize that it will actually be the same amount of memory or the same amount of size as the total length. So what we will be doing is we will only use the element from this list, the entire element, to represent the header checksum. So we don't need to do any byte manipulation, or pardon me, bit manipulation. We can call this checksum equals IP underscore header and the sixth element. So this is actually everything we have to do for the checksum. Now, the next thing which we need to specify is the source IP address and the actual destination IP address. So you can see that it actually takes double the size of the actual, for example, header checksum. And what we represent with this destination and source IP address in this command right here is this 4S and 4S. So 1 4S will be the actual source, since that is the first one. So source address will be equal to the socket.inet underscore TOA. Now this function will allow us to actually parse the IP address so we can actually print it later on. So all we have to specify in the brackets of this function. Now, before I do any of that, let me just show you, for example, once you encounter some function that you don't know, all you have to do is actually just type socket.inet underscore TOA in the Google search bar. We're finding that site. Okay, so not www, we just want to search the actual function. Let us actually go to Google, and then from Google we will search, since, for example, since this is actually not working, not really sure why. So socket.inet. Oh yeah, so I didn't really actually want to search since it had dot. It actually thought it was a website. So you can see it is low-level networking interface, and that function, if you just scroll down, let me just find the name of the function itself. These are a bunch of the functions that are used for the socket programming. So anything you don't really understand or need more detailed explanation, of course, not even I, or basically I don't think anyone normal would know all of these functions, since there's too much of them. Now you can know, for example, what some of them represent, but there is really no point in learning all of this. So here it is, inet TOA. It says convert a 32-bit packed IPv4 address to its standard dotted quad string representation. So since this is an actual representation of the IP address that we usually see, we want to be able to print this as a string, so that's why we convert it. So in the brackets, it takes an input of the actual IP address, which we can specify if we look right here. If we look right here as the sixth element, or pardon me, seventh element, but in the brackets we will specify the number 6, and that's all we need to do for the source address. The same we can specify for the destination MAC, or pardon me, IP address, so equals socket.inet underscore TOA, IP underscore header, and we specify number 7 in the square brackets. Oops, 7, and close the brackets here. Now, the last two, which is the options and padding, we will not cover, so basically we will skip those. All we want to do from this part right here is actually extract the data from the IP header. So let me just enlarge this right now, since we don't really need that picture at the moment. You can see we specified 20 to be the size of the IP header, as well as 14 to be size of the Ethernet header. But once we actually printed all the information, or basically extracted all the information from the Ethernet header, you can see we actually stripped the data from the Ethernet header. So then it processed the data to the IP header without the Ethernet header. Now, once we actually parse all the fields we need from the IP header, we can actually extract the IP header from the data in order to continue analyzing the packet further on. So in order to do that, we will just perform the same we did in the Ethernet header. So from ._receive, we want to strip from the 20th byte further on, and that we will store in the data. So we don't need to specify 34 since the first 14 have already been stripped from the data in the previous function. So everything should be good to go. All we have to do right now is actually print all of the stuff that our IP header has. So let us see what we can do if we go down here and we print same thing we printed right here. So let us actually keep the size to be the same, which really will not work, but it doesn't matter. We can just add it like this and change the Ethernet header to be equal to the IP header. So we print that, so we know that these next fields will be from the IP header, and we will use the version 2 dots, the same %HU as in the Ethernet header that we used, I believe. Okay, so we did use it to print these statements. So let me just add the actual space right here and %var, which is our version variable. Now we need to do the same for each actual variable. So IHL, we just type all of this in, so you should type it as well. Make sure to specify the correct name of all the variables so our program doesn't really crash. We need to specify this right here. Oops. Where is the %? Okay, so here it is. HU from the DOS variable. Then we print the length from the total length variable, I believe. So, okay, we did call it like that. Print the next field, which is the ID field. Now this will take a little bit of time, so I will just skip until I write all of these fields. Okay, so here it is, everything is printed out. But before I continue, make sure to double check everything and make sure that the destination and the source IP address don't have the %HU, that they have the %S. So we can actually print the string. Now the reason for that is because of this function right here. As I showed you before, what this function does is it will turn the IP address into the printable string of the IP address separated by these dots. As you know, the IP address format is something like this. So this is the IP address, and this function will basically make this a string. So we are printing, so what we are printing is an actual string. That's why we have the %S. All we have to do right now is, since at the beginning, or not at the beginning, what we want to do is actually check, since down here we specified the actual function to retrieve the data receive and the TCP UDP. And if you check in our function, we really don't have anywhere anything named TCP_UDP. So we actually have to check whether this IP header has a TCP or UDP header attached to it, or if it even has some other header. But what we are mostly interested in would be a TCP or UDP header, which we will extract further on. So in order to check what the header is attached to this IP header, we can actually use this variable right here, which is IPProto, which will contain the value of the next protocol that will be in actual packet. So in order to check what the TCP and what the UDP header numbers are, you can just go to here and go somewhere right here, and TCP protocol number. You can just type that in the Google search bar, for example. You can see that the actual transmission control protocol, or the TCP, is actually number 6. So you can just go down here. You can go list or not port numbers. We're not interested in the port numbers. That doesn't even matter. We saw that it is an actual 6. list of IP protocol numbers. This is actually more useful to us. I don't know why I clicked on this. So list of IP protocol numbers, and you can see TCP is under the number 6. If you go down here, you will find UDP under the number 17. So those are two numbers that we actually have to watch, and we need to specify them in our function. So if the IP proto variable contains number 6, that means that the TCP header is attached to the IP protocol header. To the IP header. And if 17 is in actual IP proto variable, that means we have a UDP header. So if IP underscore proto equals to 6, TCP underscore UDP variable will be equal to the string of TCP. Else if IP underscore proto equals to 17, what we want to do is that TCP underscore UDP variable to be equal to UDP. And else, for any other case, since those are not the only two protocols available to be specified in the IP header, we need to type the TCP UDP to be equal to other. Now this other will specify any other packet that this might actually contain, and all we want to do is return the data, which is data stripped from the IP header, and the TCP underscore UDP variable. And that would be about it basically for this IP header. We extracted everything, we printed everything, we checked for the actual TCP and UDP protocol, whether they are specified in the IP underscore proto variable, and then we return the data and the TCP underscore UDP. And then right here, what we will do in the next video, we will actually check whether we got the TCP or UDP, and then we will continue as we need. For example, if we got a TCP, we will extract it to the analyze TCP header. If we got a UDP, we will extract it to the analyze UDP header function. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our packet sniffer. And in the previous video, we performed the analyzing of our IP header. And what we want to do right now is check for our TCP underscore UDP variable, whether it contains TCP or whether it contains UDP. So what we did right here, as you can see from the actual previous videos, we actually changed the IP bool or checked the IP bool. If IP bool was true, we actually went to the analyze IP header function. And right now, we are not actually checking the IP bool anymore. What we are checking is the TCP underscore UDP variable. So down here, since we returned the TCP UDP into this variable, we can check what we got. So if TCP underscore UDP equals to the string of TCP. Now why we are specifying the string of TCP is because we returned right here we set the TCP UDP variable to be equal to TCP if IP protocol was equal to 6, which is the number for the TCP header. And right here, all we want to do is check whether it is TCP. If it is, we want to process or proceed to returning the data underscore receive to be equal to the function analyze underscore TCP underscore header from that data, so from data underscore receive. Else if TCP underscore UDP will be equal to actual UDP, we want to proceed with the data receive to be equal to analyze underscore UDP underscore header from the same data receive. Now we know that this data receive actually returned the data stripped from the IP header, so all we will be left to have is the TCP or the UDP header in our case. In any other case, we will just return from our function, and then we can down here call our program to be while true main. Now the reason we are using while true is basically because we want to run this for infinite amount of time, or not infinite, until we actually stop the program, so we can sniff for the packets for as long as we want. So let me just double check everything. Okay, everything should be good to go. Let us actually check our program if it is running right now. Let us put everything under the hash. Let's see if we can run the program, if our main function is good. So we will perform this, then we will go right back. And let us see if we can run the program right now. I'm not really sure, but we can give it a try just to see what we will get. So we run the sniff packets. We can see there is invalid syntax. Okay. Let us see where the invalid syntax is. Okay, so we are missing the 2 dots at the main function, so make sure to specify that right here. Save it once again. And we can see that we get printed the Ethernet header and the IP header. We can see everything is printed in the good format. We get the destination MAC address, the source MAC address, the protocol number, the version, the source IP, destination IP. We get everything. And once a new packet arrives right here, we should be printing the new packet as well. But I can't seem to actually see a new packet arriving. Let us try to refresh this page, for example, and we can see we are getting a bunch of new packets right here. So everything is good to go. We can see everything is changing. Our program works really well for now on. Now what we now want to continue is what we started, which is the TCP UDP header, so nano sniff packets.py. Now let's make a first function which it can be the actual, for example, TCP function. So we can code the TCP header first, since that will be a bigger header. It has more fields than the UDP. So let's do it first. Def analyze underscore TCP underscore header. And in that function, we paste the argument data underscore receive. We don't forget to add the 2 dots. And right now what we can do is actually perform the same task as the IP and Ethernet header. So we want to strip from all the fields and we want to first unpack the actual header. So TCP underscore header equals struct.unpack. And what the pattern for this will be is something like this. So 2H, 2I for H. I will show you why in just a second. So what we will do is we will actually try to find the same picture for the TCP header that we actually had for the IP header in order to see how many size or what size do certain fields take and how many of them are there. Now what we want to strip from is actually strip from the data underscore receive, the 20 size, so the same as in the IP header. And you can see that the first new thing that we have right here is the I variable, or not variable, the I letter right here, which basically stands for the actual full length. So let us put this as a smaller window. Let us enlarge it like this. And we are not really interested in the list of protocols. We don't want the TCP header structure. What we want, or pardon me, the IP, what we want is TCP header structure. And we can open the any actual picture that we might get. So here is one of them. We can see the actual available fields for the TCP header format. So the first of all, we will have the TCP, the source port and destination port, which if you are familiar with the previous header, you will know that both of these will take actual 2 spots, or basically an entire element in our TCP header list, since the first 2 letters that are specified are the 2H, and 1H will each represent one field right here. So the first H will represent the source port, and the second H will represent the destination port. Now this I variable right here, as you can see, there is 2I. They represent the full length, as I said, so you can see that the sequence number and the acknowledgement number are actually the full length. So we will store both of them in the I, or we will extract them by the I, and we will store them in some variable that we will name later on. And then further on we have the 4H, so what we will have to do is these 3 parts right here, we will have to split into 1H. The window will take an entire first H, the checksum will take an entire third H, and the urge pointer will take an entire 4th H. And these options right here we are not actually concerned about. So that is how we split the TCP header. So let us actually continue with, first of all, the source port and the actual destination port. So we unpacked our TCP header, source underscore port takes an entire actual element, so TCP underscore header, and then the first element, the same we want to do for the destination port, equals TCP underscore header. Second element, the sequence number takes the same, so we specify double I, which is the full length, so we can specify them as the entire element, so seq underscore num equals TCP underscore header third element, and same for the ACK number equals TCP underscore header and the fourth element. Now you will see that the next thing we have is another H. So these are the three fields that we need to split into that H. These are just some flags, and these are basically the actual offset and the reserved. So what we will do is we will actually perform the same logical expressions as before in order to split them up. First of all is the actual data underscore offset equals TCP underscore header. The fifth element, whoops, header, fifth, not P. Why do I continue typing P? Okay, so 4. And then what we want to do is actually move that or shift that with the 12 bits. The next one is the reserved. Let me see if it really is reserved. It should be, I believe. Reserved. Okay, so it is reserved. We will just call it just like that. Equals, and since that one is the middle, we need to perform actual multiple logical expressions or shifting parts. The header, the fifth element, we need to shift it 6 bits. And then what we need to do is end it to the actual, where is the okay, so here it is, 0x03ff. So after that, we are left with one more, which will be the flags, which we will need to actually split all of them one by one. But for now, let us just add the flags variable to be equal. So flags equal TCP header. And since that is the last element, all we have to do is end it with the 0x003f. After that, everything is good to go. And we only need to separate these fields into each element one by one. So we have 3 left, so let us finish them. Window is the next. Equals TCP underscore header, 7th element. Or pardon me, we are not there yet, so 5th element or 6th element. And then the checksum, which we also had in the IP header, will be equal to TCP underscore header, 7th element right now. And we are left with the urge underscore pointer. Or let me just check it out. Okay, so urgent pointer equals TCP underscore header, and then the last one, which is the 8th element. And we extract the data. Data equals data underscore receive from the 20 to the end. Okay, so everything is good to go. And now you might notice that actually this header right here has some weird spot right here, as you can see. And basically what these are basically flags. There are different types of flags, such as urge, ACK, SYN, FIN, and you can see a bunch of these others, or not bunch, just the REST and PCH. What we need to do is actually split them, and we will split them by their actual value. So in order to perform that, or in order to actually add the flag to its variable, we will need to make 6 different variables, each variable for each flag, and we will have to perform the boolean and logical expression with the specified bits from these flags in order to check which flag we have in our packet. So in order to do that, just go down here. First one is the urge equals bool flags, and where is the sign? Can't seem to find it. And 0x0020. Oops, what am I typing? 0x0020. Close the brackets. The next one will be ACK flag, so the same thing we need to perform. We are using the flags variable because the flags variable is storing that value right here, and we need to use it in each of these flags. Once again, I can't seem to actually type. Close the brackets. PCH is the next one. Let me just check it out. Okay, so PCH really is the next one. So flags 0x0008. 3 more left. And then we are good to go and we can print everything and continue to the UDP packet in the next lecture. The next one is the same one, equals bool flags 0x0002. And after we finish actually all of this, including the UDP header, we will be having a full packet sniffer, which will split each field of the packet that we receive. So this is not really something useful for hacking, as I said before, but it is good to actually test your knowledge, not test your knowledge, but to learn new things and to learn more in depth about packets and their headers. As we can see now, we know that the packet can contain Ethernet header, which can have attached the IP header to it, and then further on, which can have attached the TCP or UDP header. And then we also split all of those headers into different fields, so we know what fields does which header have. It is something useful to know. You never know when you might need something like that. And all we want to do is in the next video, we want to actually print all of this that we typed right here, and we want to do some actual expressions in order to finish the analyzing the UDP header, which will be smaller than the TCP header, so don't worry. After that, we will test our program to see if it will work, and if it does work, we can continue to the next section where we will code our reverse shell, which will be multifunctioning reverse shell. And then we will code after that the threaded server, which will accept multiple connections. Right after we code the actual server, which will accept only one connection. And then we can actually see how we can make our own command and control center, which can take the input or the connection from multiple PCs, and we can interact with all of those PCs as we like. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to the last part of our packet sniffer. And right now what we are left to do is print the TCP fields and is also to actually analyze the UDP header. So we made everything right here. Just before we actually continue, make sure to add the exclamation mark right here, since if you don't, it will not really work. I forgot to do that in the previous video, so make sure to add it right now. And right now we can actually print everything as we like. Let me just take this right here. We'll also have to print each flag one by one, so this will be a lot of printing, but it is something that we should do in order to make our program look better. So TCP, and then we print everything one by one. So first of all is the source. Just add 2 dots right here. Source underscore port, print. Oops, I just noticed right here I have double open quotes, so not really sure why I typed that. Destination, then after that we need to specify the test underscore port, print. We can call this sec. %u, make sure to specify the %u, and for the flags you will also specify the %d as an integer, since that is the value that we are retrieving from the actual flags variables. So this part right here that we coded. So let me just sequence number, so sequence underscore num, print ac %u, then ac underscore num. Then what we want to do is print, since we are starting the flags, as we can see, we want to print flags and then 2 dots, open, and then in the next line we will print urge flag, since that is the urge flag, then %d for the integer, and then % the variable name, which is just urge. Now what we can do is actually copy this and paste it 6 times. Of course, we will rename it into appropriate flags, but let's not type the unnecessary things. So the last flag will be the actual, let me just check, fin flag. Let's call it here fin. The one before that is the sin flag. So sin, and right here also sin. Here is the rest flag, RST, the ECH flag, same here as well, and the ACK flag, which is the second flag, and right here. Let me just delete the spaces and add a space right here. So we printed the flags. All we need to print more is the win size and the checksum. So we have this right here, which is the window, and the checksum. We do not really need the version pointer. So let me just print right here win size. Close these double quotes and then percent window. I believe that is the name of our variable. Let me just check. Okay, so window, and the last one is the actual checksum. So print checksum, and we printed everything from the actual TCP header. So everything should be good to go. All we are left to do right now is make our actual UDP header analyze function. So let me just check out in the main function, did I call it like that? I believe I did. So it should be analyze UDP, analyze underscore UDP underscore header. And let us also remove all of these hashes from the previous test, since right now the next text will include this part of code right here. And let us analyze our UDP header as the last header we want. Now, if you want to, for example, in order to test your knowledge, you can actually add more headers and try to analyze them as well. Just check out on the internet what certain fields they have, how big are those fields, and unpack them as needed for that special header. So, for example, the def analyze underscore UDP underscore header, data underscore receive. We parse that part right here. We save this. Let me just, from the previous video, now find the UDP header structure. Let me just find it. We don't want this. We want the actual picture. And you can see UDP is actually rather small. So it has these 4 fields, which we can actually, if you followed everything really well, you know that this H can represent one of those fields. So all we have to do is specify H 4 times. Now you can just type 4 H's, or you can just type number 4 and then the capital H afterwards, which is what we will do. So UDP underscore header struct dot unpack. Then in the double quotes or single quotes, however you want, exclamation mark for H for these 4 fields right here. And you can see we will not be needing to do any logical expressions. We can just extract them and add those values to certain variables that we will make right now. So what we want to unpack is the data underscore receive, and the size is 8. So specify in the brackets, in the square brackets 8, and close the normal brackets. And all we want to do is extract the field, so source underscore port equals UDP underscore header, and then the first element. The destination port, which is dest underscore port, will be equal to the UDP second element. The length is equal, let me just, to the UDP and then the third element. And the last, which is the checksum, is equal to the UDP fourth element. So checksum equals UDP underscore header and 3 in the square brackets. And all we want to do is actually return the data, which will be data underscore receive stripped from the UDP header size. So all we have to do right now is print all of that and return the actual data. Now, before I do that, let me just check if I return the data from my TCP header. So what I want to do is to actually return the data since we stripped it, even though we don't really need it, since we are not analyzing further on. So return data just in case. Let us go up here. Let me enlarge this, since only thing I need to do right now is print these 4 fields. So what we want to do is copy the first part right here. So print this, copy, go up here and print that the same for the actual UDP header, just we will change the TCP to UDP. Okay, for some reason it is getting laggy, not really sure why, but it doesn't matter, we can manage. Let me just tab this one step back. Oops. And add the bracket that I actually deleted by accident, so here it is. And let us print these statements finally. So here it is. Print. And what we want to print is the source first. So source 2 dots. Then percent the source underscore port. Print destination. Percent. And then test underscore port. The third thing is the length. So let us print that as well. Length. And then percent underscore, or not underscore, just length. On here we are missing the percent sign, so make sure to add it if you didn't type it as well. And the last thing we need to print is the checksum. So checksum. And then add it to the checksum, or not add it, get it from the checksum variable. And we need to return the actual data. And I believe that we are actually good to go right now. Let me just scroll to the main function in order to see if we are missing anything. We, I believe, are not, so we return from this function afterwards. The data received will contain the remaining size of the packet, if there is any. And there probably will be, such as TCP payload, for example, which will contain an HTTP protocol or something like that. It doesn't even matter. We are not concerned at the moment by that. Let us save this and let's actually test it in order to see how it works. So we run this. We have the invalid syntax. So right here, what we are missing is the percent sign. Let me just see where that is. I believe TCP packet. Yep, right here we are missing the percent sign for the destination port. So make sure to add it and save this once again and sniff these packets. So everything is working right now. Let us refresh some page in order to get the packets flowing. We can see Ethernet header, IP header. We cannot seem to see any TCP or UDP. So we got an error. Let us see, analyze UDP header is not defined. So I believe we misnamed something, and we can see we actually did. So analyze, we're missing Z right here. Let us save this, clear the screen and run it once again. And we can see here are the packets. You can see they are flowing really fast. Unpack requires a string argument of length 8. So let us see what exactly are we having an error on. Okay, so this line right here has for some reason number 9 in the bracket, specifying the actual size of the UDP header, which I'm not really sure why I typed here 9. It should be 8. As you can see, I stripped the 8 as a size in the data. Shouldn't be 9 right here. I was sure I actually typed 8, but it doesn't really matter. Let us run the program once again. So here it is, TCP header, packets flowing around. We can see they are coming, different destination MAC addresses, different source MAC addresses. IP header is split into different sections as well. We are getting a bunch of packets from this IP address right here. We can see packets are flowing really fast. In the TCP header, we can see the source port, the destination port, the sequence and acknowledgement number from the TCP header, you can see different flags which are set for the TCP header. And let us just get some UDP packets, which we probably really want, but it doesn't matter for now on. We know that our program works really well. We split it into all fields we need, and this is your packet sniffer. So that would be actually about it for this section. Now, in this section, what you should have got from is the actual more detailed knowledge about different protocols, about different headers, their fields, and how they actually go with one another. So what we are printing right here is the entire packet, or not the entire, it probably has some different payload in the TCP header, but we didn't really print it. So that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next lecture where we will continue coding. Hope I see you there, and take care. Bye. Hello everybody, and welcome to the multifunctioning reverse shell section. Now what we are going to do in this section is basically coding our own reverse shell, which will be based on the TCP server and TCP client. So we will actually code two programs. One of them will be our server, where we will listen for the incoming connection, and the other one will be the reverse shell, or the payload, or however you want to call it, which we will deliver to the target in order to hope that they will actually run the program and connect their PC back to us, which will then allow us to execute multiple functions that we will also code, such as screenshotting target's PC, running keyloggers, getting administrator privileges, opening files, downloading files, uploading files, downloading other scripts from the internet, and so on and so on. So it will all be based on this part right here, which is the code that we need to make in order to be able to connect one PC to another. Now, those of you who are coming from my ethical hacking course have already some idea what we are going to code. It will most likely be all the same. We will change some of the different things at the end, such as actually making our reverse shell to be a song, for example, an MP3 file, which will run a song in the background, or an image, or a PDF file. We will also see how we can add multiple different icons to our file. And those of you that are coming from the ethical hacking course know that we didn't really code the reverse shell to be able to, or not the reverse shell, the server to be able to accept multiple connections. So that is something that we will do in this course. So we will code the reverse shell, or pardon me, the server to be able to accept the connections from different PCs at the same time. So you can actually connect multiple targets in order to execute commands on all of them. We will be able to switch from the first session, for example, to the second session, and so on. It will be something similar to the Meterpreter shell and the exploit multi-handler. We will just try to copy all of that, as well as some of the functions, and then we will see how it will all go. That is the base of the actual command and control center, which will be able to create the botnet for your own needs. Now, most likely botnets are always used for DDoS attacks, which you really shouldn't do without permission, but you will be able to create something like that. Nothing really too advanced, since this is also a course for beginners, but I assure you it will have some of the different things and some of the more advanced things that the reverse shell should have. So let us see what we need to code in order to get this to work. This will be the basic principle behind all of this, which will contain the server and the client. The client, in our case, is our reverse shell, and the server is a program that we're going to run on our Kali Linux machine. So as we can see, we will need to create the socket object, which we did before, so nothing really new for us. We know what socket object is. We used socket library before, so all we have to do is create the socket object and bind certain IP address from our Kali Linux machine to the port that we want to listen on. In our case, we can use any port we like. We can use port, for example, 54321 if you want to. You will basically use any port you want, which is not in use on your system. What we need to do afterwards is listen for the incoming connections, and then after we listen for the incoming connections, the target can actually connect back to us. What the target will run is, in the target code, we will also make the socket object, and then we will perform the connect function from the socket library in order to connect to the IP address and the port that we specify in the server code to listen on. Then our server code will, as it says right here, establish connection with the three-way handshake over TCP, and it will accept the connection, and then we will be able to send the data or messages or commands or however you want to call it back and forth between our PC and the target PC. So afterwards, with the receive and send function, what we are going to do is send different commands such as, for example, ls or dir in order to print the files in the working directory, change directory, upload files, download files, and so on and so on. And at the end, when we don't really want to connect back to the target, we can just press a certain command such as exit or just type exit or something like that, which we will code in our program to be equal to actually closing the socket or closing the connection, and that will terminate our session with the target PC. So all of this we will be actually coding, so this will be a longer section, so prepare everything you need. This is one of the more useful things you will actually need, since this is the actual Python program that we will convert to the exe, and it will be able to run on any Windows PC. So you can make any Windows PC your target as soon as you find a method to deliver this to the target. And we will see also the method as well. We will see how we can send fake emails, how you can also deliver this if you want to over USB drive. So if you're physically close to the target, you can just take your reverse shell exe file and then plug it into the target PC and run it when nobody's watching. Now, the actual bypassing of antiviruses will be, this program will actually be able to bypass most of the antiviruses, but not all of them. We will try to make sure to add some functions that will do literally nothing, just to be able to bypass some of the antiviruses. Such, for example, if you add a function that just does normal things such as adding numbers, extracting numbers, and so on, it might trick some antiviruses into thinking that this actually isn't any virus at all. So we will be taking a look at all of that in the next video. What we will also need to install, which we will start actually with, is the Wine installation. Now, the Wine installation allows us to actually be able to convert the Python file on our Kali Linux machine into the exe file, which will allow us to run that code in the Windows PC environment without the Python interpreter. So that is something really useful. We will use the PyInstaller library from it, and we will compile it into one single file. And the reason why we will not be able to bypass all of the antiviruses is basically because of the PyInstaller, since PyInstaller library for Python by default gets actually detected by some antiviruses as an actual virus. So even if you coded a simple program which just prints hello world and converted it to exe with PyInstaller, it will still trigger some of the antiviruses out there. So that is something that we cannot really change, but we will be doing the most we can in order to bypass most of them. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we will start installing our Wine installer and we will start coding our program. So hope you enjoyed it, and I hope I see you in the next tutorial. Bye. Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we are going to install our Wine in order to be able to compile our reverse shell later on. So all you have to do is run just a few commands, which might actually take some time in order to install, but after you do that, you can safely compile all of your programs that you want to run on your Windows environment as an exe file. So let us zoom our terminal in so you can see every command good enough. And let us run our first command, which would be the dpkg, dpkg, and then dash add dash architecture. So just type this, and after you type this, you just want to type i386. Now basically we are running this command in order to add our architecture for our 32-bit Wine, which we're going to install soon enough. And basically I already did all of this process, or the entire process, so I will not be actually running the commands right now. I will just show you which commands you need to run. The reason behind this is because the apt-get install Wine32 takes a little bit of time, so I ran it before, so we don't have to wait through this video in order for that to finish. The next command, what you want to do is just apt-get update your repositories in order to be able to download the newest version of Wine32. So just update your repositories. This shouldn't take too long, since I didn't really add any additional repository to my sources.list file in Kali Linux. And after that, all you want to do is just install Wine32. Now, what Wine32 allows us to do is actually run Windows programs in Linux. What it will do, it will create a virtual C drive, the same C drive that you use on Windows, and it will allow us with a certain command to actually be able to run all the .exe files in Windows environment. So, the reason why this is failing is because I'm not really connected to the internet at the moment. For you, it should work. And right after that, you want to type apt-get install and then Wine32. What this will do, it will install the Wine32 for you. It might take a little bit of time, around 10 to 15 minutes, in order to install all the files you need for this. And after you do that, all you want to do is actually navigate to our root directory. And there, if you type ls, you will not notice anything different. But if you type ls-la right after installing Wine, you will see a folder or a hidden directory which is named .wine. Now, this directory is basically where your C drive will be. So if you change your directory to .wine and type ls once again, you can see our drive C right here. Change directory to drive C as well. And there you will have these program files x86, the usual files that you see in your C drive on Windows. But what we want to do right now is install this Python 27. So what you won't have is this Python 27, and right now I will show you how you can install it. So just close down your terminal and open up your Firefox. We will download a Python 2 version, which we will use then to compile our programs with the PyInstaller library. So let me enlarge this and just type the link, or the same link that I'm typing, so www.python.org/ and then downloads/release, and now we want to specify which release we actually want, and we want the release Python-2714, and then add a slash at the end, and you will get redirected to this page right here. Now here, as you can see under the Python 2.7.14, we have different versions available, and the one that we are interested in is the Windows x86 MSA installer. So just click on that. This will start the process of downloading it for you. It will first prompt you to save the file, so click Save. Then under this icon right here, you will see that the file will be downloaded in the Downloads folder on our Kali Linux machine. So after you do that, we can actually close the Firefox right now and go back to our terminal. And if I navigate to my downloads folder, which is under /roots/downloads, there, if you type ls, you should have a file named something like this. Now, the reason why I have two files is because, as I said, I already downloaded it before, so I will just delete one. No such file or directory. Okay. Let me try to delete the one that I downloaded before so you don't get confused. Basically, what you will have is the other one. Okay, never mind. We will just delete the new downloaded one. So you will have file named something like this. And what you want to do is run a command which goes like this. So wine and then ms-i-execute, or just i-exec. And then after that /i and then the name of your download. What this will do, so you just specify enter, it will actually run the Python for Windows in your Kali Linux environment. It will prompt you to install, so you just go next on every actual step you have in the Python 2.7.14 setup, and after that just click finish and you will have Python installed. So I will just cancel this since I actually don't want to install it twice, and that would be about it. Right after you install the actual Python, you can see that you will have Python under the root/wine or /.wine under drive C. If you type ls, you will have Python 27 right here. But we don't only want Python, we actually want a certain library that comes in Python, which will allow us to compile our Python programs in Linux into .exe files. So in order to do that, what you need to type is this command. The name of the library that we're going to install is PyInstaller, so here I will show you how you can do this. So wine, and then you need to specify the path to the python.exe. And the python.exe file or program that we just downloaded is located in Python 27 directory. So you need to specify the full directory, so root /.wine/drive/c/python27 and then /python.exe. This is the full path to your Python exe program, and then after that you need to specify -m to install the library and then pip install and then the name of the library itself, which in our case is PyInstaller, and then just press enter right here. Now this is the actual same command that you will use to actually install any additional library that you might need, since sometimes in compiling of the program you will get a fail to execute error. The reason behind that is usually because you're missing a certain library in your Python exe program. So that will be about it for this tutorial. We successfully installed Python for Windows and we successfully installed PyInstaller in our Kali Linux environment. So hope you enjoyed this tutorial, and we will continue with coding our server in the next lecture. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And this is the first tutorial where we'll actually start to code our reverse shell and our server that will accept all of the connections to our Kali Linux machine. So first of all, let us start off with the server, since the socket code for the server is a little bit bigger and more complicated than the actual socket code for the reverse shell. In server there are multiple functions that we need to execute in order to perform the entire connection, while in the reverse shell we will only need to perform the connect function after creating the socket object. So let us navigate to our Python programs, so root Python programs. We can call this mkdir, we can call it reverse_shell. That will be the name of our actual directory where we will save our reverse shell and server and any additional actual programs that we need for this section. So let us first of all nano server.py, just a simple name. We don't need anything to specify else. So just right here add the additional line user bin Python, and we know that we are going to use the socket library as the first library in order to create the connection. So first of all, let us just try to create the connecting of these two programs from two different machines. Now, for those of you who are coming from my previous ethical hacking course already know how we are going to do this. So if you already watched this in my ethical hacking course, feel free to skip to the end of this section where we will actually change some different things and compile the program in a different way in order to see what our available options are for running this attack. But for those of you that are watching this for the first time, let us continue. So what we want to do first is to create the socket object. So we will store it in a variable that we will call simply just s. In order to create socket object we are already familiar with, we need to run the socket.socket function. And in these brackets right here, we need to specify what type of socket object we want to create. So we will paste two arguments right here. One of them is socket.af_inet, which will allow us to create a socket object for the IPv4 address, since we are going to perform the connection function onto the IPv4 address on a certain port. Also, we want to specify whether we want our server to be running over UDP or TCP. We want to actually run a full TCP three-way handshake connection with the TCP protocol. So in order to specify that, we need to just type socket.sock_stream, and we successfully created our socket object. So once again, this stands for IPv4 connection and this stands for TCP connection. So in the next line, we will set some of the options for our socket object. In order to do that, we will use a function called setSockOpt, and in the actual brackets, just specify socket.sol_socket, comma, socket.so_reuse addr. After that, comma 1, and that is all we need to do for our socket object in the entire program. We set some of the options, we also created the socket, and right now we are going to run our next function, which is actually the function that we saw in the previous theory video where we actually explained what we need to run in order to perform the connection, and that function is actually called bind. So if you just type s.bind, what this function does, what this function does is it will bind your IP address, your local IP address, to the actual port that you specify in between these brackets. So what you need to specify right here is the IP address of your Kali Linux machine, and also to specify the port that you want to bind to that IP address. Now make sure before you specify anything that you make sure that that port is not used by anything else, otherwise this won't work. That's why I always like to use some high port, for example 54321, because I know that most likely non-programs will be running on that port. Also, the bind function takes the arguments between the double open and close brackets, so make sure to specify double open and double close brackets. And in between there, first of all, you specify between the double quotes the IP address. So in order to specify our IP address, we first of all need to check it. Run ifconfig. We can copy our local IP address, nano back to our server, and paste it between the double quotes. Right after that, we need to separate comma and add the port that we want to bind to, in my case 54321. So after that, we need to listen for the incoming connection. So now that we created the socket object and that we binded our port to our IP address, we need to listen for the incoming connections. In order to do that, we need to specify the listen function, and in between to how many connections we want to listen for. For example, specify 5. You can even use 1 for this actual test, but 5 will do the same job as well. After that, we can actually print a few statements which will allow us to know whether we completed these statements right here correctly, or whether we ran into some error. So let us print the successful execution in in green, and the failed attempts in red. So from term color, import colored. So what we are going to do is right here we can print colored, and then so we need to specify plus, since this means that it worked, listening for incoming connections. So make sure to close two brackets, and then after that, since we know that we are now listening for the connections, we need to specify two variables where we will store the actual connection. So one of them will be the target, and one of them will be the IP address, which we will use as a string in a later program. So what this means, the socket object we are going to store in the target, which will store it somewhere in the memory, and the IP address or the IP variable will store the IP address and the port from where the connection is coming from, which then we will use this IP variable in order to print from where we got the connection. So we can just type here s.accept, since we are accepting to our socket object, and we can see print, and we can print colored connection established from, and then we can use %s since we are going to specify a string, and we can just close the double quotes and here use %string from IP. Make sure to close 1, 2, 3, and or just 3 actual brackets. So I hope, let me just count. So we got 1, 2, 3 open and 3 closed. Okay, so everything is good enough. And basically this is the entire program for actually creating the server side of the connection. So for what we're going to do in the next video is we are going to code the reverse shell part, which will only consist of the connect function, and then we will test if our program can actually connect to our server. So let us just save this, and we will continue in the next lecture with our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do, we are going to call the reverse shell side of the code. So we can see right here, we successfully coded the server side, and right now let us exit this and nano reverse shell.py. So we will call it nano reverse _ shell.py. We add the standard user bin Python line, and we will import the socket library as we are going to need it to actually specify our socket object. So we can call it socket or just sock, so we don't actually confuse it with the socket library. So all we want to do right now is specify the same thing as in the previous video. So sock equals socket.socket. We want to use the socket.af_inet, and we want to use the socket.sock_stream. Or I believe it is stream. Let me just double check. I will just cat my server in order to see. Okay, so it is sock stream. Okay, so we specify the socket object, and what we want to do right now is perform the connect function. So in order to do that, we can just type sock.connect and open double quote, double brackets, double open and double close brackets, same as in the bind function in our server-side code. And between there, you need to specify the IP address to which you want to connect to and the port to which you want to connect to. Now, in our case, both of them will be the same. So we need to specify right here once again between the double quotes the IP address of our Kali Linux, which is in my case 192.168.1.9, and also the same port that we used in the server-side code, so 54321. But be careful, if you are running this attack over the internet, for example, and you use the port forward, what you want to specify in the reverse shell code is actually your public IP address that actually your router has in order to communicate with the internet. Of course, you also need to specify the port forward in your router settings that will actually forward this local IP address to a certain port over the router. But from now on, since we are doing just a local tag at the moment, we can just leave it like this. So what we want to do is just save this and see if we can actually perform the connect function. But before we do that, we need to close the socket in both of our programs, which we can do with just sock.close function. So just write that, exit this program, let us nano our server, write right here as well sock.close, save this as well, and we know that this program will work if we get printed this line right here. So we want to get printed connection established from a certain IP address at a certain port. So let us save this, close this, and in order to run both of these programs, we will need to open two terminals. So just open another terminal. We can enlarge both of them just for better view, even though we don't really need it at the moment, but let's have it just so you can see everything better. And right here, what I want to do is navigate to the same directory, so reverse_shell. And first, we need to run the actual server. So let us chmod server in order to make it executable. And let's run server code. No module named term color. So, okay, we need to run it with Python 3 since I use the term color library. And we can see listening for incoming connections. Now, we can see right at the moment that we have something that isn't specified correctly. So we know that we specified the colors, but we forgot to actually add the color which we want to use. So in order to do that, we need to specify the comma after the string and then the name of the color. So we want to print it in green. Same right here. We want to print this in green, and let us save and try to run once again. So Python 3 server.py, address already in use. That is because we actually closed the program 2 seconds ago in the inappropriate way. So let us actually restart our terminal in order to get this to work. Now remember, every time you get server already in use, all you have to do is actually just restart your terminal and it should all work fine right after that. So let me just go to my Python reverse shell and Python 3 my server. Name green is not defined. Okay. Yeah, green needs to be specified between the single quotes. So make sure to add that as well. And right now, I believe everything should work good. Okay, so listening for incoming connections. And right now, this will listen until somebody connects to our program. In order to perform the connection, we need to run Python 3 reverse shell.py. So we run this, it says connection established from 192.168 at this certain port. So this was the port that was used to perform the connection from the reverse shell. Now we have a small error right here since we used sock.close instead of s.close in our server. So let us just run it once again, and let's run this, and we can see everything executed properly. We got listening for incoming connections. We also got connection established from this IP address, and we closed both of these programs in the appropriate way. So what we want to do in the next video is actually try to send some of the commands or some of the messages between these two programs. For now on, we only made them connect to each other, but we also actually want to be able to send something between them, since these are the programs that will be running on two different machines. Just at the moment, we are testing them in the same machine, just from two different terminals. So we will continue coding in the next lecture. Hope you enjoyed this one, and I hope I see you in the next tutorial. Bye. Hello everybody, and welcome back to this tutorial. And as you can see in the previous video, we successfully ran both our server and our reverse shell.py. Right now what we are going to do is add just a little bit of code to our server and to our reverse shell in order to be able to execute or to send messages between these two programs. So let us start off with the server. I will just zoom this in so you can see everything better. Let me just enlarge the entire terminal and let me open server.py. So what we have here is the actual socket creation part. So what we can do with this is, first of all, delete the s.close and put this entire part into one big function, or it is not even that big, but we can just add it right there. So what we can do is just type here def server, and we can tab this entire code into this function right here. So we tab everything right here, as it should be. And also what we need to do right now is actually create a global variable s, since we are going to use the s in other functions as well. And we actually must have the s variable to be global in order to be able in order for our program to be able to recognize the s variable. So we can do that just by specifying the actual, let me just go right here. In the beginning of the function, we can just specify 3 global variables. Since we are going to use the global variable s for our socket object, we are going to use the global variable IP, since we are going to print it later on. And we are also going to use the global variable target once we actually specify functions which we will use to actually send and receive data between these two programs. So all we have to do down here is actually call this function server, so we can actually execute this part of code. And right after that, we're going to call the function called shell. So what this function shell will do is it will be a function that will perform the actual sending and receiving of the messages. So let us go up here, type def shell. The function will not take any input right now. And what we want to do is basically at the beginning of the function, we want to enter an infinite while loop. So we can do that with while true. Now the reason why we are entering the infinite while loop is because we want to send the commands for as long as we want. But before we actually enter it, let us just try to test the program in order to see if we can actually send messages without the while true loop. So what we can do is just type here a variable called command, which will be our command, or basically we will store the command that we input into this program right here. So what we want to use then is the actual so command equals input. We want to ask for the input of the user, or in this case us, and we want to add something like this. So shell, then just paste everything that I type right here, so hash. Then we can use this sign and then %s, so %s and 2 dots in order to make this look like a terminal shell. So you will see how this will look like. If we just add instead of the %s, we will add a string of the IP. So because of this usage right here of the IP variable, we had to specify it in the server function to be a global variable. So we close the double brackets, and all we want to do is actually just try to send this to the target. So we can just use s.send, and what we want to send is actual command. And after we send this, so right now what we want to do is actually receive some message from the actual target. So we can just do something like this, message equals target.receive. And the amount of bytes we want to receive would be 1024, just for this specific task. Now we will do some of the changings later on, but for now let's just leave it like this. And after that, let us print the actual message right here. So let me just try this right now. So if I save this, save it, then go and add the code to the actual reverse shell as well. So what we will need to do is actually add another shell function right here, which will actually perform the same thing. So let me just call it down here, shell, and let's call the function or code the function right here. So shell, and we enter the, or not enter the while true loop once yet. We want to type here command equals s or sock.receive. We want to receive 1024 bytes. This is the max value of bytes we actually can receive. So we will see how we can fix that. So for example, if we from the server actually send to the target something larger than the 1024 bytes, or the target sends back to us some value that is larger than this, our program will crash. So later on we will see how we can actually fix this, but for now on all we want to do is simply just get back the message from the target. We want to actually send back, so sock.send, and we can specify here to send hello world. So we will send something to the target, and target will respond back to us with the actual hello world string. So first of all, what we need to do is call the shell function before the socket.close, so we don't actually close the connection before actually executing this function right here. And right now, let us see how this will work. So let's lower this, and let us actually run the server first. So Python 3 server, listening for incoming connections, and Python 3 reverse shell.py. So we are prompted for the command. So let us just type here the command hello. A bytes like object is required, not string. Okay, so if you get this error right here, that means you're running this with Python 3, which actually is the case. So in order to actually, oops, I didn't want to open the reverse shell, I want to open the actual server. And in order to actually do this, you need to actually encode this with the UTF in order to be able to send this and print the message back. So sock s.send, and we want to send the encode UTF -8 or -8, however you want to call it. And then close another bracket. And right here, we want to print the message.decode, since we are receiving also with the Python 3 UTF-8. And right now, I believe everything should work fine. I run this server. We specify here hello. Okay, let me just check this right here. Okay, so we need to actually change the code in the reverse shell as well. So let's send this in this way. So we will just type it right here. Message.encode UTF-8. And the message will be hello world. So let's see if it will work now. Hopefully it does. Otherwise, we'll just switch to Python 2, since it is easier to actually specify this. Encode UTF broken pipe. Okay, never mind. What we're going to do is just run it with Python 2. So what you want to do is just delete this print colored. We will add it later on. For now, it is just presenting as the problem. There is really no point in me just finding the correct syntax for that function, just to run it over Python 3. We will just run it over actual Python 2. so we don't waste too much of our time. We don't need this actual encoding anymore since we're going to run it with Python 2. We want to print the message. We want to send the command. So return everything back as it was before. Do that with the actual reverse shell as well. I'm probably missing some library, but it doesn't even matter right now. We're going to run it with Python 2. So let us see. Let me just double check the server as well. Okay, everything should work good right now. And let us run this. No module name term color. Okay, let me just run this in a hash. Listening for incoming connections. And right now, if I run the reverse shell as well, I need to chmod it first. So chmod reverse shell.py. Okay, connection established. Hello. Hello is not defined. Command equals input. Okay, so we need to change this as well. Since in Python 2 we don't have input, we have raw underscore input. Too many errors. I should just start it with the Python 3 instead, but doesn't even matter. So let's see right now. Let me just check what the actual error is, since we still have some weird error, not really sure for which reason. So we send the command. Okay, there is the actual error. So this was the error all the time. We need to specify target.send and not s.send, since s.send means we are sending it back to ourselves. So we need to specify target.send. Not really sure how I didn't notice that error. And right now, for the final time, this should actually work. So we run the reverse shell. Hello. And we get back hello world printed out. So we actually managed to finally run this program and get it to work. We send the message back to the target, and the target sent back the reply, which said hello world. So what we will do in the next lecture is we will run this in while true loop, and we will make a simple chat program, which then later on will turn into actually commands for us sending the commands to target, and target sending us back the output of those commands. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody and welcome back. And as you can see right now, this is our reverse shell code. And what we want to do is actually try to make it to actually be able to send this hello world message in a while true loop. That means for every string we send to the target will send back this hello world string. So in order to do that, we need to place this in a while true loop. So while true. And we need to tab all of these commands so it can execute them infinitely. So first of all, we execute the socket creation, then we call the shell function, then we close the socket after the shell function finishes. Even though this function will actually be in an infinite loop, so that means that we actually need to code something that will make this quit right after we specify some certain command. So let's say, for example, if we send Q to this reverse shell, it will terminate and it will close the connection. So first of all, we need to receive the command. Then if command equals to Q, what we want to do is we want to break out of this program. And then we will perform the sock.close. In any other case, we will just basically set this message to be equal to hello world. And then we will send the sock.send message to the server. So let us save this. Let us also nano the server part of the code. Since here as well we need to specify a while true loop. So while true. Let's tab everything right here. And we also need to specify that in case the command is equal to Q. So if command equals to Q, we want to break out of this program, or basically break out of this loop. In any other case, we will just specify else right here. So in any other case, we want to send the actual command, wait for the reply, which will be a string of hello world, and print the reply. And after we specify Q, we want to actually close the connection. So s.close right after the shell function. And let us see right now how this will work in valid syntax. So let us see. Okay, so we are missing 2 dots right here in order to determine the function. Okay, let us run this right here, listening for incoming connections. Let's open a second terminal. So let's let the server be here and the second terminal right here. Let us enlarge both of them so we can see everything a little bit better. And if I go to my Python and then reverse and run my reverse shell, we get prompted for the actual command. If we type ls, we get printed out hello world, who am I? Once again, hello world. And if we specify q, we get the broken pipe. Now let us see why we actually get the broken pipe. So we nano the reverse shell right here. Let us actually try to remove the actual shell function for now on, so we can see if that is the actual reason why we are getting the broken pipe. So we just step everything one step back and we delete this part right here, which is the shell function. We also need to call the actual socket creation before the while true loop. We will just paste it right here and we will delete it from here. So if we save this program right here and we try to run this once again, since our server-side code worked good, it quitted after the actual q command. So let's see right now, if we specify q, we once again get the broken pipe for some reason. So let us see why is that the case. In our server-side code, we sent the actual command. So let us just see. Okay, so the reason is because we actually have to send the command first. Since we didn't send the actual q command, our target or our reverse shell didn't know that we actually sent the q. So it actually terminated the connection. It just saw that we, as a server, terminated the connection and it didn't know why that happened. So we need to actually send the command first. So target.send command. The server-side code should be good. So now we know that the problem was not in the actual function itself. So what we can do is we can actually copy this. Now we are doing a bunch of changing the code. So let us actually put this in a function as it was. So def shell and paste all of this code. So right now everything should work good. We actually need to call the function after the socket creation. We will actually right now receive the q as a command and we will be able to break out of the loop since our code will know that we got the q back. So let us clear the screen in both of our terminals. Let us run the server once again, run the reverse shell. Okay, so we got an actual error. So while true, let us see what the error is. Okay, so this is not tabbed properly. Make sure to tab it with the tab button, every line right here. That is what the error is about. So I will just delete all of these empty spaces and I will just press tab. Make sure to not actually press the space since you will get the error for your code. So right now, if I save this once again and run the reverse shell, expected and intended block. Oh yeah, since we are in a function, we need to actually tab all of this one step in as well. So just like this. And hopefully after all of this work, we will be able to run the actual reverse shell. So here it works everything good. I specify q and we quit both programs without any error. So we successfully are able to right now send multiple commands. So all we have to do is actually just check out our server. So the next thing we actually want to perform is actually executing the functions or the commands that we send to the target. Since all our program does right now is it receives a hello world string from the actual reverse shell. That is the server part of our code. But the reverse shell part of our code right here in the else statement needs to have some execution of this command that it receives. So for example, if we type ls, it will actually print all of the files in that directory. So in order to actually do that, what we will do is we will import an actual subprocess library which will allow us to execute any code that we actually want to execute in the terminal. So in order to do that, just type here import subprocess, and right here the message, we will delete all of this since we don't need this. We will code everything in the else statement from the beginning. We will call our variable where we will receive the output. We will call it result, and there we will store the actual output of this command that we get from the server. But before we do that, we need to create a process. So in order to do that, we need to type here, so just follow with me, subprocess.popen. So we are opening the process, which is the process that is ran by the command that we receive. So it is stored in this variable right here. We need to specify shell to be equal to true, stdout to be equal to subprocess.pipe, stderror to be equal to as well subprocess.pipe. So this is just the syntax for the subprocess library, and std input to be equal to subprocess.pipe. So once we create the proc variable, all we need to do is just take the proc, and from that variable we need to take the standard output.read. So we want to read from it, and we want to also get proc.standarderror.read. And we will store both of these in the result variable, and once we actually store it in the result variable, we can just send or sock.send the actual result. This will happen in every case. Instead of the case where we specify Q, then it will just break out of this loop and it will close the connection as well as the program. So if I just Control O and save this, also check out the server side of code. And let's rename here as well, so we don't want to have message variable. Let us call it result so it doesn't get confusing. And we want to print the result. So our result variable will store the output of the command executed on the target machine. Then we will print that output. So let us see how that will work. We save this. We run this server in this terminal right here. And in the other terminal, we run the reverse shell. We get prompted the shell. It says connection established from this IP address at this port. If we type ls, we can see that we get listed the available files in that current directory. So we know that everything works well. Let's try other commands as well, such as who am I. It says we are the root, such as ifconfig. We get the output of our ifconfig, so we know everything works perfect. Also, if we specify Q, it will quit both of our programs, and we know that we successfully created the reverse shell that is now able to execute commands in the target system. So, for now on, we did a pretty good job at actually creating the server-side code and the reverse shell side code. Now we want to actually add a bunch of different functions. And to fix some of the functions, there are errors right here, such as, for example, if you wanted to change directory, you would not be able to. As well as if you wanted to receive the amount of data that is larger than the 1024 bytes, I believe. Yeah, 1024 bytes, which we specified right here. Our program would actually crash, since we are trying to receive more data than we specified our result variable to have. So we need to fix that as well. And we will fix that in the next tutorial. So that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back. And in this tutorial, let us see what we can actually do in order to be able to receive and send as much data as we want. So for example, some function, or not some function, some command will actually retrieve a larger amount of bytes than the 1024 bytes. For example, some netstat command could be retrieving like 2000 bytes or something like that. So we want to actually fix it so it can receive any amount that the command output is. So we will add two different functions right here, which we will then need to add in the reverse shell as well. So for now on, we will call the send function reliable underscore send. And what we will paste in that function is the actual data to send to the target. All we need to do right now is import a library which will allow us to finish our process with these two functions. And basically, let me just add another function, which will be reliable underscore receive. This function will be used to receive data. And we will use JSON in order to perform this process of sending and receiving as much bytes as we want. So in order to send the data, we need to create some variable which we can call JSON underscore data. You can call it anything you want, but it needs to perform the dumps function, so JSON.dumps on the actual data that we specified as an argument to this function right here. So after we do that, we can just simply send the actual data with the same sock.send function, or not sock, in our case should be target.send, since we specified the target to be the actual socket object for the target machine. We need to target.send, and what we are sending is the JSON data. So this is the actual entire sending function, and we will be using this reliable send function to send any data from now on. We will not be using target.send anymore in any case. Now we want to code the reliable send. We need to also make a variable which we can just call data and specify the data to be empty. So we specify that just by opening double quotes and closing double quotes right after. Make sure to not have space right here, otherwise this will actually give the empty space to this variable. We need to open the while true loop in order to receive the data for as long as there is something to receive. So what we will try to do is we will try an except rule, which will allow us to actually receive. So if I just type right here, data equals data, which will be empty data, plus target.receive. And we want to receive 1024 bytes. We close the brackets, and we actually want to return JSON.loads function. So that is a function in the JSON library from the data that we received. So in any other case, or if we get any error, we want to actually use the accept value error. Now let me just write this and I will explain what this means. We want to continue the process. So let's explain this function so you can understand it a little bit better. What we did right here is, first of all, we created a simple variable, data, which is empty. Then we entered a while true loop, and in this while true loop, what we will do is we will try to receive the data. We will try to receive 1024 bytes, and we will try to return that data to the actual shell function right here. In case we get any error, or not any error, in our case value error, which means that we actually trying to receive less bytes than the output of that command was. So that means that we actually still have some bytes left to add to this data. What we will do, we will then continue, which will go to the beginning of our true loop, and then it will add those remaining bytes to the data. And it will perform all of this until the entire data has been sent and stored in this data variable. Then we can return the data variable and print the output of that command. So one thing we need to make sure as well is right here, instead of using this target.send right now in our shell function, we need to use reliable underscore send to send the command. And in order to receive the actual output, we need to use reliable underscore receive and make sure to remove the 1024 bytes, since our reliable receive doesn't take any argument in the brackets, so we will not specify anything right here. Everything else can remain the same. So let us save this program and let us copy these two functions, since here we will actually paste same functions in the reverse shell side of code, just we will do minor changes to that part of these, or to the part of those functions where we specify the sending and receiving. So paste these two functions in the reverse shell code and change every target.send and every target.receive into actually sock.send and sock.receive. since the target variable is not actually something we have in the reverse shell program. So make sure to specify right here sock.send JSON data, and right here make sure to specify sock.receive. And also in the shell function, we need to specify that command equals reliable underscore receive. We want to receive data with this function, and we want to actually, let me just see, send the result with the reliable send. So right now, if we coded everything successfully without any error, we should be able to send and retrieve any amount of data that the user or that the target sends back to us. Let us save this. Now let's test our program to see if it works. Let me just put this down here. Run the server. We are listening for incoming connections, then run the reverse shell. Let's execute ls. Global name JSON is not defined. Okay, so in order to fix that, the reason why the global name JSON is not defined is because in our reverse shell code, we forgot to import JSON library. So make sure to have imported JSON library in both server and reverse shell code. Now let us run it once again. Okay, server already, or pardon me, address already in use. We will just restart the terminal as I showed you before. Once you get that, just make sure to restart the terminal. Run the server once again. Run the reverse shell. Execute, for example, ls. It works. ifconfig netstat.-nr works as well. Whoami works. So basically anything that we do now works. We will be able to receive any amount of data, and our program will not crash if the data is bigger than 1024 bytes. Let us specify Q in order to close the connection. We can see it worked perfectly, and our program is now even better than it was in the previous video. We got a fully functioning reverse shell that can only execute commands from now on, but what we will do from now is actually specify some different things that our reverse shell will be able to do, such as, for example, download files, upload files. We will try to perform the connection every certain period of time. We will also try to perform the screenshot function that will actually screenshot the target's PC. We will also check for the user privileges or administrator privileges, and we will see how we can hide our program or our backdoor somewhere where the user will never find it. So hope you enjoyed this tutorial, and I hope I see you in the next one where we will continue coding. Bye! Hello everybody and welcome back, and in this tutorial what we are going to do is we will actually try to perform the first test of our reverse shell. So this is our first test right after we saw how we can execute commands on the target system. Now let's try to actually test this on our Windows 10 machine before we start adding any new functions we might need and any new libraries that we need to import. So let's see how we can compile our reverse shell, since right now if you see, let me just delete the server.save. Okay. Since now you can see that we have the reverse shell.py, which can't really be executed on Windows target system unless the Windows target system has the Python interpreter. But we know that what we can execute on the Windows target system is the actual executable files or .exe files. So let's see how we can make our reverse shell.py to be an actual executable. So let me just delete this socket as well, not really sure what that is. And let us right now use our Wine in order to actually compile this program. So what we want to do is, first of all, go right here and just type this command as the same command as I will. So wine/root/.wine/drive/c/python27/pyinstaller /python27/scripts/pyinstaller. And then after that, once you specify that we want to use the pyinstaller library in order to compile this, we need to specify some of the actual additional options that we want our reverse shell to have, such as we want it to be one file, which you can specify with double dash and then one file right after it, and then double dash no console, which will specify our reverse shell not to prompt the console open once it starts the file, which can be a little bit of actually weird if our target actually gets prompted a console, so we want to make sure to remove it from this program. Then right after you specify all of this, you need to specify the name of the program that you actually want to compile, which in our case is reverseshell.py. Press right here enter. This will take a few seconds to compile, and you will get some directories right after it in this reverse shell directory, from where we will get our executable. So then you can actually use any type of delivery method you want. Let me just show you. If you just type ls right here, you will have this build directory, this directory, and this reverse shell.spec directory. Your actual executable will be in the dist directory, so just type cd dist. And if you type ls once again, you can see there is reverse_shell.exe. That is our actual executable. And let me show you how you can actually transfer it via USB drive. So just plug in your USB drive. And your USB drive will be plugged into your main machine, as you can see right here. What you need to do is, first of all, let me delete the previous reverse shell from here. Actually, I can delete all of this, don't really need it at the moment. In order to actually import the USB drive into your Kali Linux machine, you need to go up here on Devices, USB, and find the name of your USB drive and just click on it. In my case, that is the Kingston Data Traveler. I'll just click on it, and right here, it should be imported into my actual Kali Linux. As we can see, it is imported right here. So in order for me to copy that file or the reverse shell to the actual Kali USB drive, I just need to specify move reverse shell to the media, root, and then Kali Live, which is the name of my USB drive. So this is the path where your USB drive is or will be imported. So /media/root, and then all you have to do is afterwards specify the name of your USB drive. Then if I just click here enter, it will move the reverseshell.exe to my USB drive. And after this finishes, I can just eject my USB drive and paste the actual reverse shell to my Windows desktop environment. So this is taking a few seconds, since this is probably the first time. Okay, so let's wait for this to finish. And afterwards, all we have to do is just run our server on our Kali Linux and run the reverse shell on our target system. Okay, so it has finished. You can see if I just type ls right here, there is no longer reverseshell.exe in my directory. And what you can do right now is delete all of this that you got during the compilation program. So we can delete the build directory with rm-r, we can delete the dist directory with rm-r, and we can delete the reverseshell.spec. All we need to do right now is run the actual server.py, and we can now eject our USB drive, go right here, paste the reverse shell onto my desktop on my Windows 10 machine, and then if I just double click this, you can see nothing really gets prompted to the actual target. It will look like this program didn't run at all and didn't open anything. But if we go to my actual Kali Linux machine, we can see connection established from the IP address of my Windows 10 machine from this port. In order to make sure that this really is my Windows 10 machine, in case you doubt, we can just type ipconfig in my command prompt on my Windows 10, and you can see the IP address of my Windows 10 is 192.168.1.4. So we successfully got the connection from the Windows 10 machine. Let's see if we try to execute some of the commands, such as, for example, ipconfig, the same from our terminal. We can see the results from ipconfig, dir, which will list all the actual files on my desktop. As we can see, the path is to my desktop. These are all the files on my current desktop directory, as you can see right here. So for example, you can just make dir, so I'm not really sure, I believe it is make dir, test1, you just execute that, and we can see right now on my desktop there is a directory called test1. If we wanted to, we can delete the test1, so we just type del test1, but that is a directory. It might actually cause some problem. Okay, yeah, it will cause a problem. Doesn't really matter. You can see right here, it will hang. We will see how we can fix that in the future tutorials. But right now we can see that we successfully compiled our program and we can successfully execute some of the commands on our target system. What we will do in the next video is we will continue fixing our program. We will see how we can actually change the directory from the desktop to some other directory as we like. And we will also see how we can execute some of the commands that present us the problem, such as, for example, this command. Also, if we actually try to specify to delete a file that doesn't even exist by making a typo or just not specifying the correct name of the file, our program will right now crash in case we do that. So we will see how we can actually fix that as well, so we don't actually lose the connection, just like we lost it right here, while trying to perform some task. So hope you enjoyed this tutorial, and I hope I see you in the next lecture where we will continue coding. Bye! Hello everybody, and welcome back to our reverse shell coding. So in the previous video, we saw how we can actually run our commands in a while true loop, and also how we can execute the commands on the Windows 10 host. We tested our shell while after being compiled on our Windows 10 machine, and we saw that actually everything works well except some certain commands that cause our actual shell to crash. So the first thing we need to fix is the inability to actually change the directory once we run our reverse shell. So in order to do that, we need to import a certain library, which is called the OS library, which will allow us to use a function called change directory in order to perform the changing of directory in our reverse shell. So first of all, go up here. Let me enlarge this one so you can see it a little bit zoomed in. And we want to import OS. The OS library is standard library in Python, so we will not need to pip install it in order for this to work. What we want to do right now is perform an else if statement right here in the shell. So what we have for now, if the Q command is specified, this will close the program. In any other case, it will execute the command in the command prompt. But we do not want to execute this in the command prompt, so we will add an else if statement. And in order to specify the actual changing of directory, we need to know how it actually looks like once you change directory in Windows 10 machine. So in order to do that, open up your command prompt, so cmd. It is same for every Windows host, and currently we are in this directory. So for example, let's say I want to go to my desktop directory. I will do that with this command, so cd desktop, and then you can see my directory is now changed to the desktop directory. So right now we know that the command for changing directory starts with these two letters, which is cd, which basically just stands for changing directory. Same if I wanted to change the directory back, I can do this like this with cd two dots. It is rather same in Linux as well, so basically those two commands are the same, or this command is the same for Linux and Windows. So let's see how we can specify that in our program. We know that the command will be received in this variable right here, so we can actually filter it out with this statement. So else if command, and then in the square brackets we will specify the first two letters with like this. So if first two letters, oops, not space right here, are equal to cd, and length of the actual command variable is bigger than 1, then we will use a function called os.changedir. From the command, from third element or from fourth letter in our command to the end. So now you probably, if you're new to this, have no idea what I just typed right here, so let me explain. Once we actually type the command to change the directory, it will look something like this: cd space and then the name of a certain directory. Let's say, for example, cd desktop, as from the example in command prompt. Now we see at this we look at this statement right here. So this statement right here is satisfied. The command, actually the first two letters of the command are indeed the cd. Now this statement right here also needs to be satisfied in order to proceed with changing directory. The length of the command variable has to be bigger than 1. which basically stands for, since we know the counting starts from 0 in Python, the length of the actual command has to be bigger than two actual letters. Now, why is that an actual statement? Well, if you open up your command prompt, and you will see that if you just type cd, it will just print the working directory. So cd and cd desktop don't do the same thing. Just cd only prints the working directory, and the cd desktop changes the directory. So we need to specify right here, once there is actually something else specified after cd, then we want to change the directory. Then we proceed to this statement right here, which basically stands for change the directory to the directory that is specified in the brackets. And in the brackets is specify command from the fourth element to the end. Now we can count right here. The C is first element, the second, third element is the empty space, and the fourth element will be desktop. From the fourth element, it will be desktop. So in the brackets, basically you can just imagine it says right here desktop, or the name of any other directory you want to change. So that's how this changing of directory works. So let me just delete this right now. But just in case, we actually want to run this in a try and except rule. In case, for example, user specifies the directory with a wrong name, we don't want our reverse shell to crash, so we will just try and accept. We will accept, and in any case where the user actually specifies, for example, directory that doesn't exist or any error occurs, we will just continue with the program. So basically this is the entire code we need to specify right here. Let me just check this out. Okay, everything seems to be goodly specified, and all we need to do is right now save this and nano our server code, since there we need to code something as well. So right here we can code, since you will see that if we actually send the cd command, we will then proceed to this statement right here, which will then wait for a certain bytes to be received from the target. And with cd command, we really don't receive anything, since there is no output to that command. We just change the directory. So right here, we need to specify something that will just go back to the beginning of the loop. So we can just use else if the same, so the same as in the reverse shell, so command and first two letters are equal to the cd, and length of the command is greater than 1. Oops, let me just add space right here. All we want to do is just continue with our loop, which will basically just go at the beginning of this loop. So let us save this. Let us compile our program to see whether this will work. So wine, then we need to specify the actual path. So wine, root wine, drive C, Python 27, scripts, and then pyinstaller.exe in order to compile this, -- no console, and -- one file. And then the name of the file that we are compiling, so reverse_shell.py. Make sure to still have the actual USB drive, since we will perform the same task as before. Right now I will just not explain what I'm doing. Basically do the same as before in order to transfer the actual reverse_shell.exe onto the desktop on your Windows 10 machine or any Windows machine you're running. Let's wait for this to compile. It should take just a few seconds. So we go to this directory. There we are going to have our actual exe file. We import our USB drive. ls, okay, there is our exe file. And now I move my exe file to media root Kali live, which is the name of my actual USB drive. Now right here, of course, you will not have this name. You might have a different name for USB drive, so make sure to specify it. As soon as this actually transfers, you can unplug this. Go on to your Windows 10 machine. And I can just transfer it on my desktop. Now before I run the reverse shell, I must run this server. So let me just delete the unnecessary directory that we don't need anymore. Same as in the previous video. And I will run my server. Now after that, I will run the reverse shell.exe. We can see nothing is really opening right here. there is nothing being prompted. But if we go right here, we received the actual connection. So we know that we are in the actual desktop environment or desktop directory. So let's see if we can change the directory. We will create a directory called test. We can see on our desktop right now it is created. And let's try to change the directory to test directory. And if I just tap there once again, there is nothing here because our test directory is empty, but we can see that we are currently in the test directory. If I go one step back and another step back, so that means that I will be in the actual directory, which is one step before the desktop directory. So you can see our actual changing of directory works really well. We can change to any directory we want. So basically our program works fine now. What we will do in the next video is we will see how we can actually download and upload files from the target PC and to the target PC. So hope you enjoyed this video, and I hope I see you in the next one. Bye. Hello everybody and welcome back. And in this tutorial we are going to see how we can code a part of our server and reverse shell in order to be able to download any file that is stored on the target system or upload any file that we want from our Kali Linux machine. So we will need to specify a few different things in order to be able to download any type of files, such as exe files, pictures, mp3 files, VBS files, and so on and so on. So let us see how we can do that. We will start off with our server code. So nanoserver.py. For now on, all actual options we have is the queue option, the change directory option, and the actual executing of command option. So what we want to do is add the upload and download option, and we can do that the similar way as we added the CD option. So what we will do is we will code another else if statement. So else if, we will add the command, and first of all let us add the download command. So let's actually think how we can specify this. Well, we can actually specify the same as CD. So first first 8 letters, since that is how many letters download word has. If the first 8 letters are equal to download, then we will see what we will do. So first of all, let's see how our command will look like. I will just write it right here. So for example, let's say there is a test.txt file on the target desktop. So let us create it. We can just use Notepad. Hello world, exclamation mark. I will just save a file on the actual desktop. So we will call it test.txt. I save it, I close this, and we can see our testing file is right here. So we will try to download this file from target PC. So what we need to do, first of all, the command will look something like this. So download test.txt. We checked if the first 8 letters equal to download. If they do, then what we will do is first of all we will open a file on our Kali Linux machine with the same name as the file on target machine, and we can specify the same name to be as from the command variable and from the 9th element to the end, which will basically stand for, it will cut out the first 8 elements, which will be the download word. Then it will cut out the empty space, and it will basically name the file what is the remaining, which will be test.txt or any other file name that you try to actually specify. So that this is the name of the file. The second argument of opening files is how we want to open them. So we want to actually write to a file on our Kali Linux machine, and we want to write bytes. You specify that with W and B. Basically W stands for write and B stands for bytes. And we close the brackets. So these are the two actual inputs that the file creation in Python takes. Now we need to specify as which file descriptor we want to open it, so we can just call it as file. So simply just call it file, it doesn't even matter. And then once we do that, once we actually open the file, we want to receive the data from the test.txt file on target PC. So we will just make a variable called result, even though we already have it right here, but this is the part of code that will not be run once we actually run this command. So we need to specify another variable right here. We'll call it the same result, and it will be just result underscore receive. Or if you want to, if you're actually getting confused by two same named variables, we can just type here file result or file data, let's call it like that, file data equals result underscore receive. And then what we want to do is write to this file that we opened right here, which is saved on our Kali Linux machine. So file.write, and in file.write, we need to actually write this data that we received. But in any case, in the case of this file actually being a text file, we can just simply specify here file data. But for example, if we try to download a picture, we would need to first of all base64 encode the picture before sending it from the reverse shell, and in our server code, we need to perform the base64 decoding of that picture. Now, we will use the base64 library in order to be able to download and upload any file we want. So we'll just import base64 so our program doesn't crash. And in order to write right here, we will need to perform a decode function, since in the reverse shell later on, we will perform an encode function. So right here, instead of file data, between the brackets, you need to specify base64 dot b64 decode, and in the actual brackets, open and close another brackets, and specify what you want to actually write, and we want to write file underscore data. So this is basically everything we need to specify for the actual download function right here. As we can see, we open the file to write bytes, we received the data in this variable file data, and we wrote the decoded file data, which we will encode later on in the actual reverse shell. So that will be actually about it for the download function. Let us code right now the upload function for our server. So we will start off the same. Let me just delete this download test.txt since I will forget to delete it later. And right now what our command will look like is upload test.txt. Just right now this test.txt will actually be on our Kali Linux machine, and we will upload it to the Windows 10 machine. So else if, whoops, not here, we want to code down here. Else if command, and we count how many letters upload has. It has 6 letters, so first 6 letters of the command are equal to upload. What we want to do is basically, first of all, open a file. So open a file that is already on our Kali Linux machine. So right now, instead of actually opening a file in the download function, we need to open it in as reading. So we want to read from that file. So with open and then a command, we want to name it the same as from the actual command itself. So from the 7th character till the end, which will just leave the test.txt as a name, which is right now important since it will not open a file if we don't specify the correct name. So then make a comma, and how we want to open it? We want to open it to read, and we want to read bytes. So RB between double quotes, close the brackets, and we can call this one fin. It doesn't even matter, you can call it anything you want, as long as you make sure that later on you specify the write and read function the same name. So we open the file, and what we want to do right now is actually send the contents of this file. So we will reliable underscore send. And now, since we are the ones sending the data, we need to encode it before sending it. So we will use base64 dot b64 and now encode, and not make sure to make a difference between the decode and encode. Don't type both of them the same. And right here, once you encode it, we want to send the actual fin dot read, open and close brackets since this is a function, and close another bracket from the actual reliable send function. So we successfully send the file, but make sure to add a try and except rule right here, since we don't want our program to crash if we, for example, specify the name of the file that we want to upload to target PC, the wrong name. We want to run this in a try and except, so try, then tab these two, we will try this, and then we will accept. If any error occurs, we will just basically send to the target a failed variable, which will contain a string which will say failed to upload, which we can then check. If we cat the target, the actual target file, we will see that it says failed to upload, and we will know that something is wrong with the actual upload function, or that we specify the name incorrectly. And all we want to do is reliable send the actual failed string. So we can use base64 once again, since we need to encode it. Base64 encode failed. So this is the entire download and upload function in the actual server. Now what we want to do is basically just code the same thing in the reverse shell. So in order to not type this twice, I will just copy this. I will close the actual program, save everything, save it under that name. Let me just check if I saved everything correctly. Okay, I did. Then I go to my reverse shell. And right here, under the actual change.go directory, I can specify what I copied from the server code. But of course, we need to change a few things right here. We cannot leave it just like this, since the download and upload function will not be the same in our server code, or pardon me, in our actual reverse shell code. So let me just check here. If we get the command to be download, that means that our reverse shell is receiving, or basically it is sending the file. So we first of all need to change this write bytes to read bytes in download in the reverse shell. We can leave it to be named the same. And we are not actually receiving the data, we are sending the data. So let us delete this. Let me just go right here. And what we want to actually do is basically reliable send, or we cannot leave it like this. This is writing to a file, so let us do it like this. Reliable send, open and close brackets to our function, and send base64.b64 encode. Since in our server we decoded the download function, right now we need to encode it in order to send it. We open the brackets and we are sending the file.read. Open and close another brackets and close two other brackets. Since make sure to have 3 brackets open and 3 brackets closed, so you don't run into an error. And all we are left to do before testing our program is to fix the upload function as well. So in the upload function, first of all, we need to fix the actual RB to be write bytes, since in our target PC we are now writing the file that we are receiving, and all we have to do is just receive the actual file. So we need to delete this first of all. We don't need the try and except rule right here, there is no point. So let us delete all of this and then we will write what we need. Also delete the try. And let us see what we need to do in order to make the upload complete on our reverse shell. So what we will do is file data will be equal to reliable_receive. So what we are doing is we are receiving the file data and we want to write, so fin.write the base64.b64 decode, and what we are writing is the file_data. So if I'm not mistaken, everything right here should be good to go. And right now, if we save this and compile the actual program, let me just find the command from the previous video, so I don't type it once again, just actually compile it with the same command as usual. Press enter. We let this compile, takes a few seconds, and right now let us see if we are going to be able to download this test.txt file, as well as upload some file that I will create right now in our Linux environment. So let us just wait for this to compile. We can right now import the USB drive, go to my disk directory where my actual reverse shell.exe is, and move it to my media, root, and Kali Live, which is my USB drive. So we wait for a few seconds. Okay, so it has finished. I unplug the USB drive. Let's paste the actual reverse shell to the desktop. Now make sure once you're actually downloading and uploading the files, you can only specify only the name of the file once you're in the same directory as that file. For example, if this reverse shell was one directory back and not on the desktop, you will need to specify the full path to this test.txt file in order to be able to download it from a different directory. So before we actually run our program, let me go one directory back, delete the dist, delete the build, delete the reverse.spec. And before I run my server, let me create right here in this directory a file which we will call hello.txt. And we will type here hello there. We will save it so we can have it right here, and then we will try to actually upload it to the target PC. So let us run this server, upload test.txt. Okay, so in my server code, what I forgot is to remove this line. And there is also another thing that I think I forgot, which is unfortunate, but we will have to actually fix it. Yeah, I didn't import the base64 library right here, so make sure to import it. Import in reverse-shell.py, and right now I will compile it once again because our program will not work. The one that we actually pasted on our desktop, I will just delete it. It will not work because we didn't compile it with the base64 library. So I will compile it once again, just give me a second. I will plug in my USB drive real quick in order to transport this reverse-shell.exe to the target. Okay, change to dist, move reverse shell to the media root Kali live. Sorry for this, forgot to add the base64. Make sure you add it as well, otherwise your program will not work without that library. And we are good to go right now. So let's run our server. Okay, so we have an actual error. Let me just find it where it is. Except why is there an error right here? Not really sure. Oops, what am I doing? Okay, it could be because we are missing something somewhere. For example, right here, we are missing another bracket in our server code. So make sure to add a third bracket right here. And right now, if we run this, everything works well for now. So let me unplug my USB drive from the Kali Linux machine. Then paste the reverse shell to my desktop once again. And I can run it right now. So hopefully if everything worked well and we coded everything well, our reverse shell should connect back to the Kali Linux as it did. So let us check some usual commands such as who am I, and basically dir for actually listing all the files on the actual desktop environment. And right now, let's first of all try to download this file to our Kali Linux machine. We, for example, saw an interesting file, which is test.txt. So let us type download space test.txt. We press enter. Result underscore receive is not defined. Oops, so we named something not really correct. So let me just try it once again. Let me just remove all the unnecessary directories so we don't actually confuse ourselves with them. So somewhere I specified result.receive instead of reliable.receive or underscore receive. Let me just find it where it is. Okay, so here is the error. It's not result underscore receive, it is reliable underscore receive. Let me just clear the screen, run it once again, run my reverse shell once again. It connected back, there, works, and let's download test.txt. Okay, so it seems like we didn't get any error. If we run another command, we can see we can execute further commands. So we hope that we actually downloaded the file successfully, which we will change as soon as we terminate the connection. But before we terminate the connection, let's try to actually upload to the desktop the hello.txt from our Kali Linux machine. We can see right here there is nowhere hello.txt file. So if we go right here, type upload hello.txt, we press enter, everything seems well. If we go right here, there is now hello.txt file, we open it, and it should say hello there, as it really does say. So our upload function works. Now let's terminate the connection with Q and type ls, And we can see our download function works as well, since we have the test.txt file right here. If we get the test.txt, we can see it says hello world exclamation mark, which indeed it does if we open it right here. So our upload and download function work really well. We managed to code them, and in the next video we will code some different functions useful for our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we will see how we can hide our reverse shell. So in the previous videos we saw once we actually ran the reverse shell, it was rather here on desktop, and the user could simply just delete the file as soon as they run it, right after they close it with Task Manager. So they would be like, why is this file not running? It's not opening anything, I do not need it, and then they would delete the file. But what we can do is as soon as they actually open the file and run it, we can actually make a copy of that file into a different directory where they will never find it. So for that directory, we will use a hidden directory in Windows called the app data directory. We will hide our copy of our reverse shell there, and then we will try to create a persistence which will allow us to actually run our reverse shell right after the target restarts their computer. So basically what we are doing in this video is we are hiding the program and also creating the persistence for our backdoor. So let's see how we can do that. In order to do that, we will need to import a library in order to copy our file. So let us nano the reverse shell first of all, and import a library which is called Shuttle. So import Shuttle right here. And where do we want to actually create the persistence itself? We can actually create it at the beginning of the code. So before it even connects back to us, it will perform the copying of the file, and then it will connect back to us. So what we can do is we can create a variable called location, which will store the location to the new path of the actual place where we want to copy our backdoor. So we will specify that place with os.environ, and in the brackets, in the square brackets between the double quotes, we need to specify app data. What this will do is it will find the app data path on our target PC or on our Windows PC. Now make sure once you run this reverse shell, it is a Windows target because app data folder doesn't exist in the Linux systems. So let me show you where it is. If you open your command prompt and at your path of your user, just there you can just type cd app data and you will be in the hidden directory. There you can just type dir and you will see some different directories as well. Now the path where we are going to actually save our hidden or our copy of our backdoor will be in the roaming folder in our app data path. So this is basically the path of app data, and this function os.environ will return this path right here. All we need to add to this location is the name of the file, so we can add it like this. Plus, since we can concat the strings in actual Python, we specify right here // in order for this to actually work, and we can name the copy of our file anything we want. So let's name it, for example, windows32.exe. Since that looks something, or it basically looks like something that could possibly exist on target PC. So even if the victim or the target actually found this file somewhere, they would probably not worry about it since it pretty much has a normal name. Now you can call it anything you want as long as it has .exe extension, and make sure to close the double quotes right after it. So right now what we are going to perform is checking if this location exists right after we run the program. Now the reason why we are checking if this location exists is basically what happens if we actually run this file twice on the target system. So in the first time it will actually create this path with the file right here. We do not want to create it a second time. We only want to create it once. So in order to do that, we can just type here location, or not location, we can just type if not os.path.exists, and this function will basically check if a certain file at the specified path exists, and our specified path will be location. So if it doesn't exist, we want to create it. In order to create it, we can just use shuttle.copyFile, which is a function that will copy a file. Now we want to copy our executable, which we can specify with the sys.executable. It will specify the actual executable that is running in this program and the comma, and then we need to specify the path where we want to copy it. We want to copy it in location. Now in order to use sys.executable, we need to also import a function called sys, or pardon me, not a function, a library called sys. So once we copy the actual file, we want to create the persistence. Now this is an optional, you don't need to create the persistence if you don't want to. I will show you how you can do it. There is one command which you can run in your command prompt to create persistence, which will basically add a registry key to your Windows 10 machine. So let us do that. So subprocess.call. In the brackets right here, since we are using subprocess.call, what this will do is it will execute the command. We need to specify this command, so just type everything. I type open single quote, reg add HKCU capital / software / Microsoft / Windows, and then / current version, and once again / run. Then space, then not space outside of the bracket, so space, the normal / small v, then the name of the actual registry key that you want to create. So I will just call mine, in this case, backdoor. Doesn't even matter, call it anything you want as long as it is one word. Then the type of the registry key we are creating, it is reg_cz. I will show you later on where you can find all of this. We also need to specify the /d option, then close double quotes, then close single quotes, then add the actual location with the plus, so we can concat a string. So plus location, plus, and then single quote, double quote, single quote. And then comma, shell equals true. Oops, T has to be capital. And this is the entire actual command. So what this will do is it will create a registry key, which will make our file run after every restart. It will create a registry key at this path, so it is a registry key at the current user host key, or pardon me, H key current user. Let me just show you how to get there. You just type in your search bar right here. You can type run, and it will open up this small window where you can type regedit. It will prompt you for the administrator password. You just, since I don't have, I will just type yes, and it will lead you to a page like this where your registry keys are. So we can see we created in the H key current user, since H key CU is the name of our path. Now make sure to not delete anything from here that you don't know what it is, since it can actually crash your PC. So right now we go to the same path that we actually specified right here. We click on HKCU, we want to go software, Microsoft, Windows, current version, and then run. So let us go H key current user, software. Then we need to find Microsoft, which will be under M. So let me just find where M is. Here it is. Then what we are finding is the Windows. Okay, so here it is. Current version, and then run. And right here is the place where we actually want to create a registry key. And basically this run path right here, here are all the files or all the programs that will run once you actually restart your PC and log in to the same account on your Windows 10 host or any Windows host at all. So basically, once we actually run the program right here, we will have something called backdoor, which will be the type of reg_cz, and the data will be the path to our file that we copied. So it will be the path to the app data folder where we have windows32.exe file, which is basically just a copy of our backdoor. So let us just tab this down. Let's see what else we need to type right here. Basically, this is for now on enough. We don't need anything else. Let me just check if this command is good enough. Then we proceed to create the socket object, and then we enter the shell. So let us see if I save this, exit. Now we want to compile the program once again. So wine/root.wine, drive C, Python, and then scripts, PyInstaller, -- no console, and -- one file. Now we don't need to fix anything in the server code, since this is something that will only run in the actual reverse shell. Now here it is prompting me this because I forgot to specify the file that I need to compile, which is reverse_shell.py. Okay, so we will see how this will work. Right now we don't have anything named backdoor right here. And also if we go to our app data roaming folder, so open your command prompt, go to your app data, which you can just go to your actual user account and then see the app data and then see the roaming and type dir right here. Right here is where we will have our Windows 32.exe copy of backdoor once we execute the reverse shell, or once the target executes the reverse shell. So let's leave this open as well as this open, and let's unplug our USB drive in order to transfer the actual reverse shell. So let me go to this directory, move the reverse shell to media, root, and the actual USB drive. Let's see, why is it not plugged in yet? So USB, let's unplug it and plug it again. For some reason it won't plug in. Okay, so let's wait for it to plug in. There it is. Right now if we move the reverse shell to media, root, Kali live, takes a few seconds. You can also transfer this reverse shell over Apache 2 web server if you want to, whatever you find easier. For me right now I will just use the USB drive because it comes pretty handy and I believe it's faster, maybe not. But just make sure that you know that once you actually download the file from the internet or from the Apache 2, it will prompt users saying this is an exe file, would you like to run it? But that actually comes with every file that is actually exe download from the internet, so it doesn't have to do anything with the viruses, so don't worry. Right here we want to go one directory back and run our server.py. Let us actually remove the USB drive. Type right here, or put it right here, and then run it. Let's see if our reverse shell.exe will work right now. So as soon as it connects, and it already did connect, we can execute commands. So what this means that it already completed the process of copying the file and creating the persistence with our registry key in our HKey current user registry. So let us see. First of all, check the command prompt. Right here, you cannot see any Windows 32.exe folder or file. If you type here once again, let me just find it. Here it is. So right now we do have a Windows 32.exe, which is a copy of our backdoor. And if we go to our actual registry edit, when we refresh with F5, we can see right now we have a new registry, which is the backdoor. It is called backdoor. Now you can call it anything you want, just specify in the actual reverse shell the different name. If you think this is actually noticeable, which indeed it is, and we can see the path to the program that it will run at the startup, which is the path to our Windows 32.exe. And right now, even if the actual target took this reverse shell and deleted it, and even if they shut down their PC and turned their PC tomorrow, or in 2 weeks, or in 2 years, you would still be able to connect back, or basically to connect to their target PC and execute the commands. So let's just close this, since we don't need it. Even though, let me show you, even after you actually delete this, so it is deleted, but it will still remain in here. So that would be about it for this tutorial. We saw how we can successfully create persistence. We hid our backdoor into a different file. And in the next video, we will see some of the different options we can actually add to our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back. And in this tutorial, we are going to see how we can actually perform the connection to the actual server every 20 seconds. So you might have noticed that every time we actually tested our reverse shell, we needed to wait, for example, before we actually ran the reverse shell, we had to set up our server in order to connect back. Now what, for example, if our target suddenly opens the reverse shell without us listening for a connection? It will not be able to connect back to us, and it will basically just close the program, and we will not be able to execute the commands or do anything else to target PC. So we want to implement something in our reverse shell which will try to connect back to our server basically every 20 seconds, or doesn't have to be 20 seconds, it can be any amount of time you want to specify. So in order to do that, let us go to our reverse shell. Oops, let me just delete from the previous compilation unnecessary files and folders. So we can only have these two files. Let us also delete the hello.txt and test.txt. And let us nano the reverse shell.py. Right here, what we want to do is, instead of this connection right here, first of all, what we want to do is delete it. Since we don't want to connect right here, we will make a simple function which will do that for us. So just delete this right here. Oops, not everything. So socket.sock_stream. Okay, and right here, we will basically just call a function which will be called connection. So this function is the function that will perform the connection. Just go up here, right here, go up, and we can code the actual function right here. So def connection, open and close brackets, let's add the two dots. And in order to be able to actually execute the connection every 20 seconds, we need to run this in an infinite while loop. So while true, we will add something called sleep, which is a function that comes in the time library. And in order to use it, we need to import time. This is a library which will allow us to use this sleep function, which will basically just not execute any part of the code for the specified amount of time. So this sleep function actually takes one argument, which is the amount of seconds you want your program to sleep. In our case, we will specify 20 seconds. And after that, we can try to connect. So try sock.connect, open double and open double close brackets. And between the double quotes, we need to specify the IP address, which in my case is 192.168.1.9, which is the IP address of my Kali Linux machine. Then comma, and the port that we are listening on. So in my case, 54321. And after that, once it connects, we can actually enter our shell from here. So if we are entering our shell from here, we don't need to have the shell specified right here, so we can delete the calling of the shell function from here, and we will call it from the actual connection function. In case it doesn't actually manage to connect, that means that our server is not open and running and it is not listening for connections. So in that case, we will call connection function once again. So this is a recursive function. It basically calls itself. As you can see, we call the function connection from the connection function, and this will go in circles until it manages to connect to our server. So for example, if someone ran this reverse shell and then 3 hours later you actually opened and started your server, it would actually connect to it even 3 hours after running the reverse shell. So let us save this. Time sleep, 20 seconds, everything is good. We can now try to compile the program. So wine, root.wine, drive C, Python 27, scripts by installer. Okay, so now console, one file, and then reverse_shell.py. Let's press enter right here. Let us import the USB drive. And right now what we are going to do is we are going to run the reverse shell first, then we will wait a few seconds, and then we will run our server in order to see whether it will connect or not. So let me just go right here, go to dist, and move the reverse shell to my USB. Also, since we already have from the previous video the copied backdoor into our roaming folder and also a registry key in our registry editor, this reverse shell right now will not perform the persistence since it already performed it in the previous time we actually ran it, as you can see in the actual code. So let me just go right here. It is good to know that .py. You can see that we coded right here that it should not perform these two commands in case this location right here exists. So since it does exist, since we coded it last time and we actually copied it, it will exist and it will just skip this part right here and it will go straight to the socket creation and then connection function. So that is good as well. Let us run our server. Let us unplug the USB drive. Copy the backdoor or the reverse shell to the desktop. Run it. Oops, we actually made a mistake. Let's wait for it to actually connect. We should have waited 20 seconds and we should have run the reverse shell first. So what I will do is I will just close as soon as this connects. I will just press Q to close the connection, and then I will start the reverse shell once again and just basically wait a few seconds before starting the server. So I quitted the server. Let us start the reverse shell once again. Okay, so it is started. We can see nothing is opening, nothing is running. Basically right here, we don't have our server opened. Now let's wait a few seconds and actually start our server. So clear the screen. There wasn't really point to clear the screen, but doesn't really matter. And let's right now run the actual server. It is listening for incoming connections even after we run our reverse shell. And right now, hopefully, we will get connection back. So let's wait a few more seconds since we specified the timeout to be 20 seconds. So in less than 20 seconds, we should connect to the target. And we did, so we can see we got a connection from our Windows PC at this port, or the connection is from this port. We can execute the commands, we can do anything as in the previous videos. So our actually persistent with the timeout of connecting actually works right now. So at this point, all you need to do is deliver this reverse shell to the actual target and you will be able to connect to them anytime you want, as long as their PC is on. So that will be about it for this tutorial. I hope you enjoyed it. And in the next video, what we will do is we will see how we can actually download some files from the internet with our reverse shell. Hope you enjoyed this tutorial and take care. Bye. Hello everybody and welcome back to this tutorial. And right now, let us call the function in our reverse shell, which will allow us to download to the target system any program we find online. So all we will need to specify is the path to that program in a certain website, and our reverse shell will automatically download it in the target PC. So let us go to our reverse shell. Let me just delete once again everything unnecessary. And nano my reverse shell.py. And right here, in order to do that, what I need to import is the actual requests library. So import requests. What this library allows me to do is actually navigate through the actual website and get a certain URL and get its content so I can write it back to a file. So that is basically what we are going to do. We are going to get the URL, read its content, and write that content from that file into another file that we make on target PC. So we will call that function right here, and we will call it download. So simply as that. Now don't actually confuse this download right here with the download from here. This download is basically downloading the files from the target PC, and this download is actually downloading the files to target PC from the internet. So let us paste it right here, and this download function can take the URL as an actual input. So we will paste the URL to this function, and all we want to do is make something called get response from this certain URL, and in order to do that we need to code requests.get. This function right here will basically get this URL that we specified with the requests library. Then its contents we need to write to the file. In order to actually name a file the same as the file that we want to actually download, we can just type here file underscore name will be equal to the URL.split. We want to split it at the slash. Now I will explain this in case you don't understand. And we want to take the last part of the split. This -1 basically represents the last part. So let me show you what I mean. So for example, if you have google.com/release/downloads/python.exe. For example, this is the URL, and python.exe is the file that we want to download to the target PC. What this right here will do is it will split the URL everywhere there where it has slash, and it will take the last part from the URL, which will be just python.exe, which will be our file name. So let me just delete this. Our file name is specified. All we need to do is run our with open, and the name that we want to write to the file is basically stored in the file name variable. We want to write bytes, so VB, and we will call it the file descriptor as out_file. We can call it just like that. And what we want to do is out_file.write. And the thing that we want to write to this file is from the get response get_response, we want to get its content. This will be the content of the file that we are downloading. So this is basically the entire function. All we need to do is call it in our shell function once someone specifies a certain command. So in order to name that command, we can just call it get. So if you specify get and then there's an empty space and then the URL, it will download that file. So let's do it like this. We know that get has 3 letters, so else if command and then first 3 letters equal to get, then we will try and accept the download function. So we will try to download the URL. So right here we need to specify the URL, and in order to specify any URL that the user of our server specifies, we need to type here command and from the 5th element till the end. Since our command will look something like this, so get google.com/release/blah blah blah, and then we need to get the URL from the 5th element, so it will just print the rest of this string. So let us go back here. We specify the download function right here, and what we want to do is send to our server reliable_send. We will send with a plus downloaded file from specified URL. So we will send this, and in case it doesn't work, we will just send, so reliable_send failed to download that file. So these are the 2 strings that we were sent, whether the download function works or whether it doesn't work. And right now I believe this is all we need to code. In the server side of the code, we don't really need to code anything because we send the command to download the actual file from the URL, and then we wait for the reply. The reply will be stored in the result, and it will get printed either failed to download the file or download the file successfully. So nothing really here to code anymore. All we need to do is compile the actual program, root.wine, drive C, Python. We will see this 1,000 times in this section. So scripts by installer, no console, one file, reverse_shell.py. So let's let this compile, then we will transfer it to the actual Windows 10. So let me plug in my USB drive. Okay, USB drive plugged in, reverse shell compiled. We need to remove it or move it to the media root Kali Live. Let me just delete everything right now. And I will run my server right here in order to listen for the connection. Let's run the reverse shell as well. So run it late. Okay, so fail to execute script reverse shell. Now this is a good error because I believe I know why it happened. So let me just show you what we can do. First of all, we will need to close this. This can happen because our reverse shell, if I nano it, you can see we right here have a requests library. Now, basically, our PyInstaller, or pardon me, our PyInstaller doesn't really know this library, so we probably need to actually download it to our Wine folder. Or let me just check if I name this library correct. Requests. Okay, so that is correct. In order to get the requests library for the PyInstaller, we can type wine.root.wine then we need to specify drive C, Python 27, and then python.exe -m, and then pip install requests. You just press here enter, and right here it will collect the requests library, and then if we compile it once again, right now it should work. Hopefully this is the error, so we can actually fix it right here. Let's wait for the requests library to actually download for our Vine, and you can see it is downloading it. So that was the actual error, and this is a really good error to actually get, since right now you know how to download any library that you might not have for the Vine. So you can just download it with that command. Just at the end, all you need to specify is the name of the actual library. But right now what we need to do is actually compile it once again. So we compile it, we will plug in the USB drive in order to send it once again back. Okay, so USB drive is plugged in. This is compiling. Hopefully it shouldn't take too long. Here it is. Let us go to this directory and move reverse shell to the media, root, and Kali live. Go one directory back, run our server. Okay, address is already in use. We will fix that just by actually restarting our terminal. So open once again terminal. Let me enlarge this in. And let me go to my Python, reverse, and then run my server. Right here, I will paste once again my reverse shell, run it. You can see right now we do not get any error, so everything works perfectly right now that we actually downloaded the requests library. And here, in a few seconds, since the 20-second timeout, we will be getting the connection from our Windows 10 machine. And then what we can do is actually test our get function. So in order to test it, first of all, we need a file to download from the website. We will use my Apache 2 web server. So in order to actually run the Apache 2, you can just type service Apache 2 start. Once it started the Apache 2, we go to the cd var www.html, and there you will need to download some of these files. So in my case, let us download the index.html. So let me just remove the other file so it doesn't confuse us. And we will try to download this index.html file. So if you go right here, 192.168.1.9, the index.html file is basically this HTML file containing the Facebook page. It is from our previous part in our course. So we'll try to actually download that file, which will contain the HTML code for the Facebook page. So let me close this. It is at place. We try to execute some command right here, and then we get http 2.192.168.1.9/index.html. Downloaded file from specified URL. So let us see if we go right here. We have the index.html file right here. If we open it, it should open the same page as the Facebook page saved on our Apache 2 web server running on Kali Linux. So let us see. It is opening, and here it is. Okay, our get function works really well. So that would be about it for this tutorial. Hope you enjoyed it, and we will continue coding in the next lecture. Bye. Hello everybody, and welcome back to our reverse shell coding. And in the previous video what we did is we coded a function that will be able to download a file from the internet to the target PC. Now let's see what else we can code for our reverse shell for it to have multiple functions that we can use once we actually infect the target with our payload. So let me just zoom this in, and we will navigate to our Python programs, reverse shell, and we will nano our reverse shell. Let me just delete from the previous compilation these unnecessary files, so we can only have our two main files, which is the server and reverse shell, and let me nano my reverse shell. So we have the download function right here. We perform the connection every 20 seconds. Now let's see, for example, how we can take a screenshot from the target PC. For example, let's say they are using Facebook and sending messages, and we want to, for example, see what messages they are sending. Without implementing a keylogger yet, we can actually run a screenshot and see their entire screen as many times as we actually want. So in order to do that, we will need to import a library, which I'm not really sure if it comes with the PyInstaller. Maybe we will need to install it while compiling the program. So the library is called MSS, and we will import it like this. So from MSS, import MSS. Now before I do this, let me just check out in Python, import MSS. Okay, so Python 2 doesn't have it. Let me just try to import it like this. So from MSS, import MSS. Okay, so we know that the library is not in Python 2, and we can install it with pip install MSS. Now if this doesn't work, we will just install it for the actual PyInstaller in the Wine folder, since that is actually where we need it. But you can also install it for your own Python in Kali Linux if you want to. We will not really be running this on the Kali Linux target, we will be running it on the Windows machine, as usual. So we can see it successfully installed, and now if we go to the Python and import MSS, it is there now. So you also have it in Kali Linux Python. So we imported it. Now let's make a function right here, for example, and we will call it screenshot. Let's leave it for now on. Right here, we will code it in just a second. What we want to do is add an actual option right here. So we want to create another else if statement for the actual screenshot. So let us add it right after the get command. We can just go down here, make else if, and then the usual command. And then let's count the letters. So screenshot actually has 10 letters. So we want to make sure that we specify everything until the 10th character equals to the screenshot. This is the function that we will use in order to screenshot target PC. So we will just type in the server command line screenshot, and then we will get back the screenshot from their PC. And what we will try, since this doesn't work every time, for example, I tried getting this to work on Windows XP and it just doesn't work. I believe it works on Windows 10 and Windows 7. On Windows 10 it works for sure, on Windows 7 I'm not so sure, we will have to try it out later. So we need to run it in a try and except rule in order for our program not to crash, for example, once we encounter a target that cannot take screenshot. So what we will try is we will try our screenshot function that we will code in just a second. Once we do the screenshot function, we need to send that screenshot to our Kali Linux machine. So basically, since we are on the reverse shell code right now, what we will do is we will actually open that file for reading bytes, and we will send the actual data to our server. So now before we do any of that, the actual screenshot, once you use the MSS library, will save the screenshot under the name like this. So monitor -1 .png. So this is the name how this MSS library will save the screenshot under, and every screenshot will be actually saved under this name. So that can present a problem to us, because if we make one screenshot and it saves under this name, and we want to, for example, take a second screenshot, and we take it, it will rewrite this screenshot right here, because it will have the same name. So we will no longer have the first screenshot. So we need to actually make sure that doesn't happen. So how we will do that is we will actually fix that in the server-side code. For now on, all we want to do is open the file under this name, since after we perform this function, there will be a screenshot on target PC. We want to open it, read data, and send data to the server. And in the server, we will rename this so it doesn't actually rewrite other screenshots that we take. So first of all, with open and close brackets, between the double quotes, let's specify monitor -1. Now make sure to specify exactly the same name, otherwise this will not work. So PNG, and then comma, and we want to read bytes from that screenshot. Since we are getting a picture, oops, we don't need another bracket. We want to open it, let's say, as CS, so shortly for the screenshot. And what we want to do is reliable send, reliable_send, base64, base64.b64 encode. Since we are the one that are actually sending this, we want to encode, And the thing that we want to encode is the sc, or our screenshot.read. So let me just count the brackets. We have 1 open, 2 open, 3 open, and 3 closed. So everything is good right here. And also, for example, let's say that the reverse shell is running on the desktop. So the target found it on the desktop, double-clicked it, opened it, and we took a screenshot. The monitor-1.png file will be saved on the desktop, which can actually trigger some users. They basically find the screenshot of their own PC, so they maybe believe something is wrong by then. So what we want to do is actually delete the screenshot as soon as we send it. Now you will notice that you will not even be able to see the screenshot for a fragment of a second, so nothing will be suspicious if after the actual opening of the file and sending. What we want to do is use the OS library and we want to .remove, which will remove a file that we specified between the brackets. So let us just copy the name of this file, which is monitor-1.png, paste it between these brackets, and this will remove the actual screenshot right after we send it. And in the except rule, what we want to do is reliable send underscore send, and let's send a string, basically a string that will say failed to take screenshot. Now why we are sending the string? Well, basically, if we fail to take the screenshot, we will have a file, or not a file, we will get prompted this string right here, failed to take screenshot, and then we will know that the screenshot function doesn't really work on that target. So now that we did this, what we need to do is actually code the actual screenshot function, which is rather short. It is just 2 lines, so don't worry, nothing really too much. Our MSS library already did the entire job for us. All we need to do is type with MSS, and that as a function as screenshot. So this is the name. You can specify anything you want. It doesn't really matter. We want to use screenshot.shot. And this will save the screenshot for us. This is the entire screenshot function. So basically, if I'm not mistaken, this should be entire actual code for the screenshot. Now let us save this. So Ctrl-O save, Ctrl-X to exit, and let us nano our server and see what we need to do once we actually get the screenshot back. So let's first think about it, or let me just at the beginning create the actual else if statement. So else if, we need to perform the same thing, command first 10 characters equal to screenshot. Let's think about it, what we actually need to do right here. As I said, it will save every screenshot as the same file, so we need to change that. We will use a counter, for example, or not a counter, we will just increase the variables. For example, let me show you right here, so maybe you will understand it better. If you go down here, and for example, at the beginning, you create a variable count equals 1. So count equals 1, and that is a global variable, so we can use it in this function right here. The reason why we are using the global variable is because we need to actually increase that count variable every time we run this screenshot function in the while true loop in the shell function. So let me just show you. We will actually receive the data first of all, but before receiving it, we need to open the file under a specified name that we want. So what we will do, in order for that file not to rewrite, since every screenshot has the same name, we will name it screenshot%d, and then we need to use the %count to be replaced instead of this %d. So since count is 1 at the first screenshot, it will be the name of screenshot 1. Then we will increase it at the end, and it will be screenshot 2, and so on and so on. So since we are the server, we need to open for the writing bytes, and the name, we can name it fin. Doesn't even matter. You can name it anything you want. Or maybe if it is actually confusing for you, let's name it just screen, so you know it's a screenshot file. And actually, we need to receive that file right now. So let's do it like this. We will create an image variable, and that image variable will store the data from the received screenshot. So reliable receive. And since we encoded it with base64 encoding, we need to decode it. So we'll create image underscore decode or decoded equals base64 dot b64 decode. And the thing that we are actually decoding is the image itself. So just type here image. And now what we want to do, since the try rule in our reverse shell actually saves the image or sends the data for the image, what we want to do is if we successfully took a screenshot, we want to save that to a file. If we didn't take successfully screenshot, that means that we are getting the string back, which will say failed to take screenshot. In that case, we want to print it to our screen. So in order to check that, we can just check first 4 characters, for example. So if image underscore decoded, and then first 4 characters equal to this string, which is the string that we specified at the beginning of the failed to take screenshot function, then we want to print image underscore decoded, because that means that the actual image failed to take. So image underscore decoded. And in any other case, we want to actually write it to a file, because that means that we successfully took the screenshot. So we'll just use screen.write. And we want to write image underscore decoded. And make sure that you increase the count variable right after you do this. But not right here, since that it will increase it even after you don't take the screenshot. You want to increase it right here. So count plus equals 1, which will just increase the count variable by 1. So that is the entire actual program. Let us now save this. We can compile our reverse shell. So wine root drive C Python scripts installer -- no console -- what's the next thing? Okay, one file, and then reverse shell.py. Let us run this with enter. This will compile, and then we will run it on the actual Windows 10 PC. And later on, when we'll actually code the threaded server, which will accept multiple connections, we will try to run a screenshot on Windows 10 and on Windows XP. So let's wait for this to compile. Now, if my IP address changed, we will need to compile it once again, since I just started Kali Linux. Didn't really check the IP address. Hopefully it didn't. Okay, so let us check the IP address, .1.9, and let me check the IP address that is specified in the actual Kali Linux machine. No, pardon me, in the program. Okay, so it is .1.9. Good. So right now, let us plug in my USB drive. Or let me actually show you another way that you can download this reverseshell.exe without plugging in your USB drive. You can just go to the Google Chrome. If you, for example, for some reason don't have USB drive, then you can just go cd dist, and you can move this to the move the reverse shell to the var/www/html, which is the standard Apache 2 folder. So you just move it right there. You can see it's no longer here. We can delete the rest of the files. And all you need to do right now is actually run the Apache 2. So you can do that with service Apache 2, start. And this will start the Apache 2 for you. All you need to do right now in order to access that file is you need to know the IP address of your Kali Linux machine, which we already really know. It is 192.168.1.9. So we can just go right here, just type 192.168.1. We have 2 dots, so .168.1.9. Okay, so we still have the Facebook login page from the previous tutorials. Let us just remove the actual Facebook login page so we can see the file. If we remove index.html, we only have our reverse shell.exe. If we refresh, here is our reverse shell.exe. So all you need to do is just click this in order for this to download. You can see it downloaded successfully, but you will notice one thing. Let me just show you. Once it is on our desktop and we downloaded it from the actual Apache 2, it will no longer run as the USB transportation. As you can see, this is something that we didn't really encounter before. Right now it says Windows protected your PC, prevented an anachronized app from start running. This app might put your PC at risk. All you need to do is go to the more info and run anyway. So now our reverse shell is ran, and for some reason we get fatal error. Okay, I think I know what the reason is. The reason is because we actually only installed the MSS library for the actual Python in Kali Linux. We forgot to install it for the Python in Wine, which for some reason I said we need to do that and then I forgot to do it. But let me just do that real quick. In order to install it for the Wine, run this command right here. So wine/root /wine/drive/c/ Python 27, I believe, and then python.exe. Then you need to specify -m and then pip install and then MSS. Run this command, and this command will basically just download the MSS library for the Wine, and then hopefully everything will work as usual. So until then, I will just plug in my USB drive, because I find it easier to actually transport via the USB. Okay, so we can see here it is. Now we have the MSS library. Now we can actually, let me just find where the reverse shell is. Okay, so here it is. Let us navigate to the previous command. Here it is. I will compile this real fast so we don't waste time. Everything has finished. Go to the dist, move the reverse shell to your Windows 10. So root media, or it is media root. Or basically, I just need to plug in the actual USB drive before I try any of that. So /media root Kali Live. We move the reverse shell. Hopefully that was the error. I really can't think of anything else being the error. So remove this, remove build, remove reverse.spec. Let us unplug my USB drive. And I can run my server. For the listener, even though we can actually run the reverse shell first, as we saw that we actually created a function to connect every 20 seconds. And right now, if we run, first of all, you will notice we don't get that error prompted, we don't get that warning prompted that says this app might put your PC as a target or something like that. I'm not really sure what it even said, but it doesn't even matter. Right now it doesn't say it because we didn't download it from the internet. And here we get the connection back. So all we need to do is first lower this so you can actually recognize the screenshot once I take it. And if I just type screenshot, oops, local variable count referenced before assignment. Okay. What do you mean? So nanoserver.py. Yeah, actually, let me just double check everything right here. We need to actually code this at the beginning because it goes through all these functions and then it runs to a count variable which it doesn't really recognize. So let us code it. Just move the count equals 1 at the beginning, even though we didn't really run that function yet, but it doesn't even matter. Let us just try once again. We listen for the incoming connections. It should come any second. As you remember, we have a timeout of 20 seconds before connecting. And as soon as it does, we will just, first of all, check a simple command to see if our program works. And then we will run the screenshot and see how it looks like. So here it is. Let us just run who am I just for a simple check. Then I can lower this so you can see the screenshot better. And if I just type screenshot, what do you mean count referenced before assignment? Oh, I think I know what does it mean. Sorry about that. It doesn't really know what count variable we are using. We need to specify right here at the beginning that we are referring to the global count variable. I believe that is the problem. Sorry about that once again. And hopefully third time, third luck, so we will be able to run this right now. Even though we crashed already 3 or 2 times, something like that. but hopefully everything will be good to go right now. The problem was, I believe, because that global count string, or pardon me, global count command wasn't really implied in the actual shell function. So let us just run it straight away. Screenshot, we can see it finishes relatively fast. Now let me just lower my screen right here so you can see. Screenshot, if I run it, you can see there really isn't anything on the screen that appears, such as the monitor1.png, since this performs really fast and it sends the data, and as soon as it does it, it will remove the screenshot. And if you want to check actually where the screenshots are, we can first of all press Q to quit the program, and you can just type ls and you will see in this folder there is screenshot 1 and screenshot 2. Let us navigate to that folder. It is in the root, Python programs, and then reverse shell. Oops, we need to go to the places, I believe. Then go to the computer. Then find the root right here. You just find it. Here it is. Go to the Python programs. Go to the, where is it? Reverse shell. And screenshot 1 is basically just the screenshot of our full screen Kali Linux, as you can see. You know it's a screenshot of Windows 10 PC because we can see our Windows 10 icons down here. And the second one is more convincing since we can see even the Windows 10 background in the actual screenshot. So our screenshot actually works perfectly. It is even a good resolution, so everything is good to go. You can see everything in the actual picture, and you can perform as much screenshots as you really like. All I need to do afterwards is just delete these screenshots if you want to. So remove screenshot 1, remove screenshot 2, and you will be good to go for running the next program. So that would be about it for this tutorial. What we will do in the next one is we will code a simple help function that will print the help to anyone using our program. So we will just implement all of these things that we coded in a help function, and later on we will continue implementing more things to our actual reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And before we actually implement our help function, what I want to do is show you a simple function that will check whether your target is running your reverse shell as an administrator or as user privileges. That way you can know what your limitations are and what you can do with the target PC. So let us nano our reverse shell.py. And right here, what we will do is, for example, right here, we will code a simple function called is_admin, which will check the admin for the admin privileges. What we need to do is use a global variable admin. Now, the reason why we need to use a global variable admin is because we will actually use it in the shell function as well. Now, there is another way, and you can just return the variable admin from this function to the shell function, but it doesn't really matter. Whatever you prefer, you can continue with that. I will use the global variable admin. In order for us to do this, what we need to do is try and accept as usual. So we want to try and accept. What we want to try is actually accessing a certain directory in Windows, or the temp directory. Now, the reason why we are trying to access that directory is because that directory can only be accessed once you're an administrator. So what we will do is we will try to access it, and then if we actually can't access it, we will know that we are not the admin. If we can access it, we are running this reverse shell as the administrator, and we know what our limitations are. So in order to do that, we will just put it in the temp library, variable equals os.list here. What we will do right here is we will try to list directory as it says right here, and we will use an OS library to perform that. So os.sep.join, and what we want to do right here is use an actual thing that we already used before, which is the os.environ, which we used in the app data. So right here, we want to get a certain environment. So, and that environment will be the temp directory. So let's open this. Now make sure to open it like this. So in these inner brackets, what you need to type is between single quotes, you want to type system and then root, then comma, and then another single quotes, C, we want to access C, 2 dots, backslash, and then we want to use Windows. So basically, then you close the first bracket, and then you type comma between the first and the second bracket, and there in the single quotes you type temp. Or let me just, we need the actual square brackets right here and not the, let me see in our app data what type of brackets we use. So we use the actual square brackets, not really sure right here. Probably we need to use them here as well, or we need to use them right here, I believe. So if we just type square brackets right here, open it there, close it right here after the temp, and then close these two brackets, which are the other two brackets from here. So this one and this one are rather confusing command, but it doesn't really matter. And then if that works, or if that doesn't work, we want to type admin variable, which is our global variable, 2 exclamation marks for the error, and we want to type user privileges, exclamation mark. In any other case, or basically in case where it did work, we want to type, or not exclamation mark, we want to add a plus as it did work. Let me adjust the space between the double quotes and the actual equal sign, and we want to type administrator privileges, exclamation mark. So this is our entire function. All we are left to do actually is just basically code the isAdmin in our else if statements. We will code it as a check function, so we want to actually add it, for example, right here. We can say else if command, and then first 5 letters equal to check. So once the user of our server just types check, it will check for the administrator privileges. And how we can do that? We can just try to run the actual is_admin, and then we will reliably send the admin variable. Since it is a global variable, we can access it from here, and we want to send the global variable. In the accept, all we need to do is just reliable send _send, and between the brackets we can just type here can't perform the check, since something went wrong and we really can't take any action in order to see whether we are administrator or whether we are a user. So that would be about it. Let me just compile the actual shell right here. Let's compile it real fast. Let us, while it is compiling, move it right here. A rather small and short tutorial. This is really fast function. We just want to have that just so we can know. Well, basically it's not really that much of a useful function, such as the other ones that we coded, but there's really no point in not having it there. Of course, you can add as many functions as you want, as many available options as you want to this reverse shell. We will not be adding any more except the actual keylogger and the threaded server, which is really important, so make sure to stick for that. So let me just move this to root, Kali live. But as I was saying, you can add multiple functions. Just search on the internet, for example, any type of function you want to input right here, and then make sure to code it properly into the actual server and the reverse shell code. So remove this, remove build, remove. Okay. Let us paste this to the actual desktop right here. And what we can do, run our server and run the reverse shell. So it seems that it worked properly. Let us go to our actual Kali Linux and we will perform the check right away, and we will see whether it works or whether it doesn't. So just type check. You can see we are user privileges. So we know that we are now user privileges, but if we, for example, quit this and run this server once again, or we can actually run this first and right click, run as administrator. We want to run it as administrator. Our reverse shell is now running, and we run the server once again. I will leave this so you can see the difference. So first time we got the user privileges, and right now if we run the check once again, we will see what we will get. Hopefully we get administrator privileges, otherwise this doesn't really work. So check, and we can see right now we are administrator privileges. So this function works really well. Rather short tutorial, and we will continue in the next tutorial with making our help options and then proceeding to the keylogger coding. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial, and this is the last part of actually our reverse shell, or basically of focusing mainly on our reverse shell. And right here we will code our help options to prompt the user. And what we will do after that is we will try to implement a keylogger to our reverse shell, so not a specific keylogger that will be a standalone program. It will be rather implemented in our backdoor, and then we will, with two different actual commands, run the keylogger and stop the keylogger. And then afterwards, once we do all of that, what we will do is we will actually try to create another server. We will not be coding anything in the reverse shell anymore, but we will try to create another server which will be able to accept multiple connections at once. And then we can navigate between the sessions and choose which target we want to actually compromise at that moment, which is basically a command and control center. You can then use it further on to perform DDoS attacks, or something like that. It's most likely used for that, since you gather multiple PCs connected, then you send the same command to all of them, and then they start doing what you want them to do. But more about that later. Right now what we want to do is go to the reverse shell, and all we can do right here is code a simple string which we will send to our actual server. We can code it right after the queue option. So then we will have else if command equals to help. What we can do is basically just make a variable called help_options, and that variable will be equal to a string containing all of the current options that we have. So we will use triple single quotes in order to be able to actually create a multi-line string. So I will show you how this works. What you need to do is, first of all, let me just check it right here. 1, 2, 3, 4, 5. And also here I need to tab it 5 times. 1, 2, 3, 4, 5. So it can actually be in the same line. And first thing we want to type is download path. Now this download is the function, and then path is the path that we want to download from the target PC. Okay, so, and we can do it like this. Download a file from target PC. All we need to do is right here, use the same for the upload. So upload and then the path. And then we can use 2 dashes and then arrow. Upload a file to target PC. The next thing is the get URL, which is our download function for downloading the file from the internet. And then what we want to do, download a file to target PC from any website. From any. Now, of course, you don't need to actually name all of this as I do. You can just name it whatever you find easy, and start path. Or actually, did we code the start? Let me just check right here. If we didn't, we will code it really fast. Okay, so it seems that we didn't. And what start does is basically it will start a program without us waiting on a single program to close before continuing. Now, what I mean by that is, for example, I will just explain it in theory right now, so we didn't actually compile and run it, just to show you. But basically, just imagine that we ran the reverse shell, and then as a command, we send to the target start notepad. Now, if you can see, if I open my command prompt and actually run that command, start notepad, it will start a notepad. But if we did that from our reverse shell, it still would start a notepad, but also it would actually block on that notepad, and it will not allow us to execute more commands until that notepad is closed. So we will need to wait for a target to actually close the notepad, and then we will be able to actually continue executing commands. Same for the example calculator. So start calc. It will start the calculator, but then still we wouldn't be able to execute further commands until the target actually closes the calculator. What we want to do is actually be able to open programs, and as soon as they open, we can actually execute more commands right after they open without the target needing to close them in order for us to continue. So we will use a subprocess library to do that. Don't worry, it is a rather short function. We will just code it right here, right beneath the screenshot function. So else if command, and then first 5 letters equal to actually starting the program. So start. What we need to do is try to open the program. So make sure to always use try and except, because anytime, for example, the user of our server can specify the name of the program wrong, basically they just mistype the notepad name, and then our program will crash because you don't have the try and except rule. So make sure to always have it, and we will use subprocess.popen for opening the actual process, and we want to open the process named from the 6th letter, from the 6th character till the end. Of course, the 6th because start has 5, and then the empty space 6th, and then goes the name of the program. And also we need to make sure to specify shell equals true. And then we can send to our target, so the server actually receives something. We can send reliable underscore send, and we can send started. Simple as that. And all we need to do is in the except rule just send fail to start. And that is the entire actual start function. So plus, or not plus, we need to do exclamation marks, or you can use a minus, whatever you feel like it. And then failed to start. Okay, so that part is coded. So right now we can add it to our actual help settings. So dash dash start program on target PC. The next thing we want to do is screenshot. So screenshot, take a screenshot of target's monitor. The next thing is the check. So check for the administrator privileges. Did I code that correctly? Hopefully that is how you pronounce privileges. Doesn't even matter anyway. And the last thing we want to add is the Q command. So Q is equal to closing the connection or exit the reverse shell. And all we need to do, since we opened the triple quotes at the beginning, we need to close them right here in order to make this a string. As you can see now, it is a multi-line string. And then all we need to do is send the actual string to the server. So reliable underscore send help options. Okay, so if I'm not mistaken, this should be it. And right now, if I save this and we compile our reverse shell with the same command as usual, and we go right here and plug our USB drive. Let's wait for this to compile, and then we will first check the start function that we just coded to start, for example, Notepad, Calculator, Explorer, and so on and so on. And then we will actually get the help options, or we can just do in reverse, doesn't even matter. Let's move our reverse shell to the USB drive, media, root, Kali live. Okay, we can unplug the USB drive now. Open it, paste the reverse shell.exe, run the reverse shell.exe. We don't get any error, that is good. Now, until that is running, we can just delete all these files. So remove this, remove build, remove reverse.spec, and let's run our server right now. So first of all, let us try for the help command, so we can get the help options printed back. We got everything. Let's say who am I works, and then help. and here are our help options. Let's try to run some program, for example, Notepad. If I just type start Notepad, it says started, Notepad is still open, and we can still execute commands further on. But let me just show you what I was talking about. If I just close this Notepad and instead of start Notepad, type Notepad, it will still open the Notepad, as you can see right here. But right now, I need to wait for that Notepad to actually close, as you can see, to be able to get the shell back and execute more commands, as you can see. Instead, I can just type start calc. For starting the calculator, it will print started and it will open the calculator, and then I can start Notepad as well, and so on without closing the previous programs. And let's press Q in order to quit the reverse shell, and everything works properly. So, hope you enjoyed this tutorial. What I will show you in the next video is how you can compile this program in order to make it more believable and in order to make your target actually open it. We will see how we can create an image out of this program. It doesn't have to be an image. We can create something as a PDF file or something like that. So, hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our reverse shell section. And in this tutorial, which is basically our last tutorial, we will see how we can compile our reverse shell in order to make it more actually convincible to the target. So for now on, we saw the usual compilation command, which is, let me just find it, which is this command. As we can see, we use divine, the points dollar. We set the settings to be no console. We set another setting to be one file, and then the name of our actual file. Right now, what we can do is we can actually create any icon we want for our actual reverse shell. As you remember, the previous reverse shells actually had the icon, let me just show you, the icon similar to this, which is a standard PyInstaller or Python exe icon, which really doesn't seem convincible, and if target sees this, they will not open it. But you can add some regular icons to our reverse shell, and it will make the target actually click it. We can also make our reverse shell to be an audio file. We can make it to be an image. We can make it to be a PDF file. Basically, the process is the same. I will show you how you can make an image, and I will show you how you can make a simple icon. So first of all, let us start with the actual icon. You can just go to the, let me just move this in since we will not run any command. You can just go to your Firefox and simply just search some icons on the actual Firefox or some websites that actually have icons. Then you can download that icon file, and then you can use it in the compilation of your reverse shell. So you just go right here, type icons, for example, doesn't even matter. Hopefully something will come out. I remember using one website which had a bunch of different icons, but I'm not really sure how it was called. Hopefully we will find something like that. Okay, I believe it was Icon Finder. So let's go with that one. You click on the Icon Finder right here. Not really sure why is it this slow. Okay, so here it is. Search for icons, and then you can just type here, for example, Google Chrome icon. For example, it doesn't have to be, you can just type PDF, Facebook. As I said right there, you can just type any icon you want. And here you have a bunch of different Google Chrome icons. You can use the regular Google Chrome. Oops, where did it go? Okay, so here it is. You can use regular Google Chrome icon. You can take any of these icons you want. For example, let's take this one or this one. Let me just go right here. We can download the actual icon. I believe it is in the download the second PNG format. Okay, so let's download it in the PNG format. And then what we will need to do is we will need to actually convert it to the icon file. So first of all, let's see if it will even download. I hope this is a free one. Yeah, it is. Open in icon editor, free icon downloading it. Okay, so open file. We don't want to open it. We just want to save the file. Okay, we have it right here. It is in our downloads folder. You can see my Firefox is currently a little bit slow, but here it is. icon finder, Chrome, and let's actually try to make an icon from that image. Since we got the .png file, now we can use the png to icon. Just simply search that, icon convert, create icons from PNG and JPEG images online. So let's see how this will work. I am for the first time using this website, so let's browse for our file. We go to the downloads, and in the downloads we open our file. So, and then we upload it. It will say successfully uploaded it. And let's see what we need to do. Crop your image. We don't want to crop anything. Convert to ICO for Windows 7, Windows 8, Vista and XP. Doesn't seem to have Windows 10, but hopefully it will work. Download your icons. Here it is some icon file. Okay, save it. And it should be in the same folder as our PNG file, or our PNG Chrome image. So let's open our downloads folder. Why aren't you opening it? Let's just navigate it through our terminal since our Kali Linux is a little bit slow. Here it is right here. Let us rename it. So move icon finder underscore ICO to black chrome dot ICO, since it will be much simpler to actually use it. And now let's see if we can actually compile with this. So we can go to our root, or not, yeah, root, Python down, programs, reverse shell, and let's navigate, or not navigate, let's compile our program and make it have an actual icon. So we use the same thing as before, wine, drive C, then scripts, or no, Python 27, then scripts, then PyInstaller.exe. Next thing we want to do is use one file, no console, and then in the order to add the icon, we need to specify -- icon, and then the path to the actual icon, which is root, downloads, and then blackchrome.ico, and then the name of our file. So let's press here enter to see whether this will work or not. So this is compiling. Then we will plug in our USB drive. In order to move our reverse shell to the USB drive. So let's wait for this to finish. And then after actually seeing if this will work, we will add an icon of our actual image that I have on my USB drive, and we will see how our program or our reverse shell can have an icon of an image and also open an image. So let me just check this out right here. Change directory to this, move reverse shell to media root Kali Live. Unplug my USB drive. Let's check it out. Okay, so it doesn't seem to have the actual icon. Well, that seems a little bit strange, but it doesn't even matter. I use some website that I haven't used before. Let me just check something out. Sometimes you need to refresh multiple times in order for it to show for some reason. But no, this one just doesn't have it. Okay, let us try another one. And that another one can just be our picture, since I actually took in matter that this might happen. So I used some picture that I already tested before, which is the actual, let me just change my directory to my Kali Live, which is this dragon wallpaper Chinese.jpg. If I copy it, so copy to my root Python programs reverse shell. And then I can change my directory to there. Python programs reverse shell. And now, at the same time, let's make our reverse shell open this as well as have the icon of this image. So in order to do that, we need to navigate our reverse shell.py, but let me delete this other stuff for now. And let me nano reverse shell.py. And we need to import a certain library if we don't have it imported yet. Let me just check everything right here. We need to go down to our program, and right here where we actually create the persistence, right after it we want to open the actual image. Now in order to do that, we will use a PyInstaller folder or temporary folder, which we can access with the sys._me ipass, or let me just show you. If we create an actual location, which will be _file name, which will be the location where our PyInstaller will store the actual image which we compiled during the compilation, which in our case will be the Dragon Wallpaper Chinese. I believe that is the actual name. So we need to specify the location to be sys._me ipass and then plus, and between the double quotes we need the backslash and then the name of the actual image. So let me just save this, type ls, copy the name of the image, just so we don't mistype anything. So make sure to copy the exact same name of any JPEG image you want, and then specify it right here. So use your JPEG image, paste it right here. We can see right now we have the full path, and all I want to do right now is try to open this path with this subprocess, subprocess.popen, and we want to use the subprocess library so we can continue executing our code even after the image is opened. We want to open the program, or in our case image, at the location of file name, shell equals true as usual, and in any other case we can just perform any type of code, doesn't even matter. We can just perform some simple addition. So number equals 1, number 2 equals 2, number 3 equals number plus number 2. Now you might be asking, why am I doing this? Well, basically, first of all, we don't really have anything to do in the except rule, and second of all, we want to perform some simple functions that really do not do anything for our code, because sometimes these functions can help bypass the antivirus. Since sometimes antivirus can check out your program and see that you have some regular functions, such as in our case this simple addition function, and then they think this is a legit program. Now that is another case, but for now on we just don't need to bother coding anything else. If this doesn't work, we will just proceed to actually opening the shell. Now also make sure that I'm running this in the actual if not os.path.exists. Now that is the reason behind that is, for example, if we are not running this on the target for the first time, we don't want to actually open an image. So if we run it for the first time, let's say target downloads an image, which is an actual reverse shell from us, they put it right here. Let me just delete this for now. They place it right here, they run it, the image opens up, and then we create the persistence, which will open the backdoor at every boot up of the actual computer. Now imagine if at every boot up the same image opened every time. It would create a suspicion, they would know something is wrong, and then they would investigate further on. So we only want to open the image for the first time of the target running the program, and any other time we don't want to open anything. That's why this part of code is tabbed in this section right here. So right now, if everything is performed correctly, we can save this, and all we are left to do is perform the conversion of JPEG to ICO. So we can just use a simple website, JPEG to ICO. We can go to the icon converter, or no, this was the one that we actually used, so we can go to the second one, which is convert ICO, JPEG to ICO. Let's click right there. It will probably ask us to actually upload the file itself. Okay, so here it is. Now let's click, let me just find, okay, so click right here. Let's navigate to our actual Python programs, reverse shell, and our Dragon Wallpaper Chinese. So open this. And you can see right here at the right side, it asks us to download the actual ICO file for this image. Just click on this arrow right here. It will ask you to save the file. Click Save File. It will download it. It will download it in the Downloads folder of your Kali Linux machine. Let us just double check that, just in case. Just as usual, our actual Firefox is a little bit slow. Okay. Doesn't even matter, let us just close this. We downloaded everything successfully. We don't really need this to be open anymore. Let us just check if it is really in the root downloads folder. If we just type ls, this black chrome.ico we don't really need anymore. We also don't need icon finder, chrome.png. And we have our dragon wallpaper Chinese.ico. So all we want to do right now is go back to our root Python programs, reverse shell, and perform the full compilation in order to get this icon to be the icon of our reverse shell, and also for the image to actually open once we start the program. So the full command will be something like this: wine, then root.wine, and then drive C, Python 27 scripts, PyInstaller. And first thing we want to do is use an option called add and then or --add -data, and between the double quotes we need to specify the path to the image we want to open, not to the ICO file but to the JPEG file. Okay, so we need to specify root Python programs reverse shell dragon wallpaper Chinese.jpg. Now also make sure that at the end, before closing the double quotes, at the end of the actual path, add the dot and the comma, and then add the comma, and then add the dot at the end. So this specifies that we only use this file right here. So once again, --add -data, open double quotes, path specified, then dot comma, and then dot, and then close double quotes. And then afterwards we can specify --one file, --no console, --icon, and then the path to the actual icon, which is in our downloads folder. So the path is root downloads, and then the actual name is dragon wallpaper Chinese.ico. And all we are left to do afterwards is actually specify the name of the file that we are compiling. Press here enter. And while this is compiling, make sure that you go to your command prompt and to your registry. And if you ran the program before and didn't delete the registry, let me just go right here, and didn't delete the registry and didn't delete the actual backdoor from the app data, make sure to delete it, otherwise this will not actually open an image. So right here, you can see I don't have anything. If I go to the app data, the roaming, dir right here, just delete. You just type, or let me just enlarge this, type dir once again. Windows 32 exe needs to go, or not dir, I need to del Windows 32.exe. And if I just type dir once again, it is no longer there. It is also no longer in the actual registry. So that means that we are going to run our program for the first time according to the actual computer. And then, okay, so it is already plugged in. Move reverse shell to the /media/root and then Kali Live. We move our program, and right now we will close the actual USB drive, and then we will run it right here. And let's see what opens right here. For some reason, once again, we don't have an actual icon. But never mind, let's see if it will open the actual image once started. So we double click this. And we can see that it is actually opening image. It takes a little while to load up, but eventually it will load up. Okay, so here it is. This is the image that we actually coded in our program. And also, after opening this image, it even started our reverse shell. So now, if our icon actually worked, for some reason it doesn't want to show, But for example, if you restarted your PC, then the icon would be right here. Sometimes it just doesn't want to work and sometimes it does. Basically, the command is always the same, so the command is this one. Let me just show it right here. You will always use this command. So whether it works now or not, it doesn't even matter. What matters is if we run our server, let me go on directory back and run our server, listening for the incoming connections, we should receive the connection from this reverse_shell.txt. Here it is. You can run usual things such as who am I, then help to check our available options, and everything is good as usual. Now, we managed to actually open an image. That image could have also been a PDF file. It could have been an audio file, for example, some song or something like that. It could have been a PNG image. Now, some images don't really work, but most of them really do. I remember encountering some that didn't even want to compile for some reason. But the actual icon didn't seem to load this time, even though I think it is just a glitch in my desktop because I used the same thing I used before. And for some reason it doesn't want to show it right here, but if you try it a few different times, you will be good to go. Maybe try it with some different image and maybe it will go even faster. So that will be about it for this tutorial. I hope you enjoyed it, and I hope that in the next tutorial you will stick with me where we will actually code our keylogger for the backdoor. So that will be about it for this section. Hope I see you in the next one and take care. Bye. Hello everybody and welcome back to the first tutorial of actually coding our keylogger. Now don't worry, this will be a rather shorter program than our reverse shell and server, as there is only a few things we need to do, such as actually processing the keys, then writing those keys to a file, and also just doing a little bit of changes to the keys here and there. But before we do anything, let us download the library that we will need for this, both for our Kali Linux Python and for our winstaller Python. Or pardon me, for our wine Python. Because then later on we will forget to do that and then we will need to compile multiple times. So let us do it right at the beginning. If you just go open up your Python and try to import pyenput.keyboard, you will see there is no module named pyenput.keyboard. But this is an actual module or library that we need to use for our keylogger. So let me just exit this and install it with pip install and then pyenput.keyboard. This is us first installing it for our Kali Linux Python 2, and then we will install it for our pyenstaller, Python 2. So collecting pyenput.keyboard. Now what this module or library allows us to do is use a function which is the listener function, which will listen for the input keys from the target keyboard. Now let me see, could not find a version that satisfies the requirements pyenput.keyboard. So let us just try with the pyenput without .keyboard. Maybe that will work. Not really sure, can't really remember how I downloaded this, but we will get it to work, don't worry. So collecting pyenput right now. This should finish any moment. This is not a big library. And here it is. It downloaded some things and right now we have the pyenput installed. So if I open Python 2 and try to input pyenput.keyboard, which is a module that we want to use because we are only focusing at the keyboard at the moment. Okay, so here it is installed. And let us now also install it for the actual PyInstaller. So we'll use the same command as before for installing libraries. So wine/root/.wine, drive C I believe, then Python 27, scripts, PyInstaller, and then we want to, or pardon me, not PyInstaller, we don't want to use Python 27, we want to use python.exe, since we are installing the library, not compiling anything, then -m for the actual installing of a library, and then pip install, and then the name of the library itself, which is pyenput. So right now, once we finish this, we're good to go, and we can create or start creating our keylogger. First of all, we will see how we can actually capture those keystrokes and how we can print them to the screen. Okay, so it has finished right here. We are good to go right now. So let us actually first of all delete from the previous compilation everything, and we will code our keylogger in the exact same directory as our current reverse shell and server. since we will need it to compile, so there is not really a point in making a certain directory for that. So let us just create it right here. But before we actually start coding anything, let us see how we can do it in simple Python interpreter. So in order to create a listener, it is rather simple. Right after importing the actual PyInput.keyboard, we can with one line create a keyboard listener. So let's call it keyboard_listener. It will equal to PyInput.keyboard, and then we will use an actual function listener, which needs to take an actual input of an argument or of an actual function that we will use to process the keys. So it is specified like this: on_press, which means right after you press the key, it will process it with process keys function. For example, let's say that is how we call it. If you just press here enter, let me just see, process keys is not defined. Yeah, of course. First of all, we need to simply just code the actual function itself. So let's call it def process_keys. That function will take an argument of actual key. So we are parsing the key that is pressed on the keyboard to this function. And all we want to do is print that key for now on. So our function is right here. We can then just use this same right here. So we created a keyboard listener. We use the listener method on it, and we use the onPress to be processed with the process keys function. So let's press here enter. All we need to do is run something like this, So with keyboard_listener, similar to opening files, and then keyboard_listener.join. It is similar to, and this one is similar to joining threads. And then if you press here enter and enter once again, you can see we no longer get the interpreter back. It seems to just hang. Now that is because this right here is now waiting for an input from our keyboard. For example, if I just type here S, you can see it prints S. It prints, just typing anything right here, it will print bunch of letters. But you will also see this U letter right here. Now that U letter right here is basically because of us actually using the encoding of these letters. Or basically it encodes these letters, and this really looks ugly to look at. So there are a few things that we need to fix in order for this to work properly. So, but for now on, we saw how we can simply create a keyboard listener, and we saw how we can download the actual library that we need. And in the next tutorial, we will start off by actually fixing our keylogger and getting it to work. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And right now, let us actually implement our simple keylogger from the previous video into a file. Now we will code it right here, and we will also try to write those keystrokes to a file that we will name right here. So first of all, let us nano something called keylogger test1.py. Since this is not our final project, we want to just call it test. Let's use the user bin Python as usual. And what we want to do is simply just import this actual user bin Python. And let's import our Python keyboard, PyInput.keyboard, pardon me. So this is the only thing we want to input. And let's actually process the keys. So def process_keys takes an input of a key. And first of all, we want to print this to an actual screen just to see if we actually print everything correctly. And we also want to with open, and let's call it log.txt. Now make sure as a mode in this file, we don't want to use read or write. We want to use A for the appending. Since if we used, for example, W for writing, we would actually rewrite every single character that we input in our keyboard. So make sure to specify A right here for the appending. And let's open it as fin. And we will simply just fin.write the string of the actual key. Now you will see what the problem is with this, but for now on, let us just leave it like this. So keyboard_listener equals PyInput. Now this is basically the same as from the previous video, so nothing really new right here. PyInput.keyboard.listener, and right here on_press equals process keys. And all we need to do is with keyboard listener, we need to join the keyboard listener. So same as in the previous video, nothing new right here. And right now, if we save this, we chmod it in order to make it an executable, and we run it, you can see once we type something, it will print it to the screen, but also if we quit the program and type ls, we will have a log.txt file right here. If we cat the log.txt, you can see there are a bunch of these actual strings, or not strings, characters right here, all separated by this u right here. And we also have something as key.ctrl, key.ctrl, so it also prints those characters as well. So right now what we want to do is, first of all, we want to actually get the character of the actual key, since the string of this key will print this with u, and we want to get rid of this u right here because it ruins our keylogger. We don't want to actually skip and just get these characters like this, so D, F, S, D, F, and so on. We want to actually remove completely the u, so let us go to our Python, or how did we call it, keylogger test1.py, and in the process keys, first of all, we no longer want to print the actual keys anymore. No really point. Let me just, before we do this, delete the actual current log.txt so it doesn't present us any problem. What we want to do is, in the process keys function, we want to use the global variable, which will be the global variable log. So we will define it right here to be a simple string or an empty string, however you want to call it, since it really doesn't have anything between this. Make sure to not have a space, so just simple two double quotes, one next to each other. Then in the global log, or after the global log, what we want to try is, first of all, we need to put this in the actual hashes, since this is not the part of code we want to deal with right now. We first of all want to try to print the characters without the u character. In order to do that, we can just use the log variable, and we can add to that log variable a string of the key and then .char. This key.char will print our character without the u character, as you saw in the previous test. And you will notice that if you try to print the character of, for example, enter, or the character of space, or the character of Control-C, or backspace, or any other characters that are not an actual letter or a number, you will get an error and your program will crash. That's why we need to accept the error that is called attribute error. So make sure to specify it, the correct name, attribute error. That is the error that will pop up if you try to print the character of space, for example. And then we want to see what we can do with it. For now on, or let's use, for example, just the space. So if key is equal to the key.space, we want to add to our log a simple empty space. So right now you want to type a double quote, then the space, and then another double quote in order to make an actual space. And then right afterwards, we want to print each actual log after every time we actually input the key itself. So let's see how this will work. Make sure to hash these two so it doesn't present us a problem. We didn't do anything to the actual keyboard listener. It is same as before. All we did was we create an actual global variable. We put the character of the key that is inputted in the keyboard to the global variable log. And in any case that key can be printed as a character, such as I said before, enter, space, backspace, we will just do a simple statement for each of these cases. For now on, we will just use if key equals key space. Let me just run this right here. Let us print. You can see it prints everything. But you can also see it prints the previous thing as well as the new thing. And if you just type here space, you can see it also prints space. But if you just type here enter, or backspace, or escape, you can see nothing really is printed right here. But we also want to print the actual enter and the actual backspace and so on and so on. So in order to do that, in the if else statement right here, we can just add the else. In any other case, that the character is not a number or a letter and that it is not a space, we want to just add to the log the previous log plus the empty space plus the string of the actual key. Now the string of the actual key, for example, for the key enter, will just print key.enter, as you will see in just a second, and then also add another empty space so we can separate it from the next strings. So let's try to run it once again right here. You can see everything is as usual, but if I just type key enter, key backspace, key escape, control C, you can see it prints them like this. Now we need to have these characters as well, so we know when user prints something like this. For example, let's say they're typing a password and they press a backspace and we didn't print the backspace, we would not know when they deleted a certain letter. But if we have the key.backspace, we will know that they deleted the previous letter that is typed in. So simple as that. Now, since we have printed it to the actual screen, we need to make sure to actually print it into an actual file. So in order to do that, we will need a simple function which will report every certain period of time. Now that function will be run on an actual thread. We will use a thread in order to be able to run this program while executing the reverse shell commands, since this keylogger must be executed on a thread in order for us to be able to execute both things at the same time. But we will do that in the next video. For now on, we simply just printed these characters and we also saw how we can start our keyboard listener. So hope you enjoyed this tutorial and I hope I see you in the next one. Bye! Hello everybody and welcome back to this tutorial, and right now what we're going to do is we're going to try to finish the entire keylogger, and then in the next video we will test it and see how it will work. So right now let's see what we got for now on. So nano keylogger test.py. This is what we have for now. So there are a few things that we want to implement right here. One thing is the one that we put in the hash, which is the actual writing to a file. We need to make sure to actually write it to a file. Just we will not call the file log.txt since that would be too suspicious. We will try to hide the actual file and we will try to print to that file in, for example, app data directory. We will make a file that will capture keystrokes to be located at the same directory where our copy of our backdoor is located. That's how the user or the target will never be able to find it unless they search for it. We will also name it something different so it doesn't catch any attention. So first of all, our process keys function doesn't really need to print the keys anymore. We only use that to actually test our program. All we need to do right now is add some simple statements for other keys as well. So else if is for the enter, for example. So else if key.enter. And the reason why we are using the key.enter, or let's just keep it like this. We can leave this statement right here to be else for every key that we will need, but for every key that we don't need, such as upper arrows, down arrows, and so on, those are the characters we don't really need to print to the screen, since the upper arrow, the lower arrow really doesn't give us any information. We want to get rid of those characters. So else if key.write for the right arrow, we will just add log equals log plus and then nothing. So we want to add simply nothing. Same we want to do for others. So key.left, log equals log plus nothing. For right as well. So else if key.up equals, or pardon me, yeah, okay, so yeah, equals. Let me just see. Or not equals right here. We need to type here the two dots. Let me just see. I forgot to add everything right here. So else if key right equals key space. We are processing the keys. Else if key equals. Okay, so we are forgetting right here to specify that the key is equal to key right. Then we want to add nothing to the log. If the key is equal to key left, we also want to add nothing to the actual log. Same for the upper arrow. So if equals to key up, log equals log plus nothing. and the one that we are left will be the else if key equals key dot down, log will be equal to log plus nothing. So simple as that. Let's see if there are any other characters that we can get rid of. For example, enter, we can get rid of it. It doesn't really provide us much of information. Or you can just leave it, it doesn't really matter. Maybe it will provide you information once actually the password is submitted or once the message is sent or so on and so on. So let's leave it just in case. For any other characters that are not these arrows, we want to print the actual string of those characters. As we saw in the previous video, that will be key.ctrl for control, key.backspace for backspace, key.enter for enter, and so on and so on. These arrows won't be printed, and the key.space will have an empty space printed between the characters. So this is our entire actual process keys function. All we want to do right now is create a path that we will actually submit the keystrokes to. So what we want to do is first of all import threading, since we will start a thread in our next function, and we also want to import OS so we can actually get the environment of the app data folder. So we will create a path variable right here to be the os.environ, and then double open quotes, app data, close these square brackets, plus, and then we need to add the open double quotes once again, and between them 2 backslashes. Oops, between them, not before them. Okay, so between them 2 backslashes, and we need to specify the name of the file that we want to make in the app data folder. So let's call it in this case process manager.txt. Since this doesn't look suspicious at all, it looks like a normal file such as process manager, and we want to save it under that name. This file in the app data folder, which is the same folder as in the actual previous backdoor creation, you can see it is this path right here, so /appdata/roaming, and there we will have our windows2.txt, which is a copy of our backdoor, and we will also have the process manager.txt, which is an actual file containing the keystrokes. All we need to do right now is actually start this keylogger and save it to an actual file, or save the keystrokes to an actual file. So what we will do is we will make a function called report, which will report every certain period of time. We also need to call that function in the keyboard listener. So before the keyboard listener.join, we want to type here report, calling the actual function. And in this function right here, we want to access the global variable log, which we created right here and use right here as well. And we also want to access the global variable path, which is the path to our process manager. Then what we want to do, open the path to that file and append to that file. So fin equals open. In the brackets we specify the actual path to be the name of the file, and the append or a for the actual appending, since we want to append the characters. Then all we want to do is fin.write, and we want to write the actual log to that certain file. Then after we actually write the log, we need to make sure that we clear the log for so it doesn't, in the next process of actually writing the log to a file, write the previous stuff as well. Since it will write something, for example, something like this, let's say the target types AAA, then it will write that, it will finish the function, it will go to the beginning, and then let's say the next thing the target types is BBB. It will not write just BBB, it will write another time 3 times A, and then afterwards BBB. So we want to get rid of that, we only want to print everything once, and in order to do that we can just set the log to be equal to empty once again, right after this. Then we can close the actual file. We just go down here. After closing the file, we need to call the timer on our actual thread, which will call a timer on the function itself from where it is starting. So we will call it like this, timer equals threading.timer. Every 10 seconds we want to call the report function, and all we want to do is type here timer.start. Another thing we want to do is, before we actually close this program, is we want to make an actual, let me just double check everything right here. Everything seems to work fine, or to be fine. Let's make a function, def start, which will take this. So this is a function that will actually start the program itself. Now we need this function in order to be able to call it from our backdoor. Otherwise, we will not be able to have a way to call it. And you might notice that we are not running the start function in this program. This is just a program that we will import to our backdoor, which will allow us to use the functions from this program right here. Now the good thing is that all we need to do is access this start function from our backdoor, and it will run the entire rest of the code by itself. As we can see, the actual start function calls the report function, and the report function basically calls the keyboard listener function calls the process keys, and the start function calls the report function. So everything is called within this start function right here. So this is our entire keylogger, I believe. Now we will test it in the next video. So let us save this for now. And in the next video, what we will do, first of all, let's rename the keylogger test.py into just keylogger.py, since it is no longer a test file. This is a file right now that we actually want to import to our reverse-shell.py, which we will do in the next video. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And in this tutorial we will see how we can implement our keylogger to our backdoor. So we have our keylogger right here. It is the entire code of our keylogger, and we want to implement that in our reverse_shell_py. So we can see our reverse shell is complete from the previous section, and all we want to do is add a few things right here which will allow us to actually run our keylogger. Now, for those of you that are using that used before the Metasploit framework, you know that we can actually start the keylogger with a single command, and we can also dump the keystrokes with another command. So we want to perform something similar to that. So let us see how we can do that. Let us go down here, and let's code the actual keylogger command right here. So we will do something like this, or else if the command and the first 12 characters of that command are equal to the open double quotes keylog_start. If that is the case, we want to run a thread on an actual keylogger library or on the start function in our keylogger. Now, in order to be able to do that, we first of all need to import the keylogger, otherwise this will not work. So import threading first and import keylogger as well. Make sure to name the import right here the same as the name of your keylogger. For example, if you named it something differently, make sure to specify here the different name as well. So import threading and import keylogger in order to be able to do this. So let's go down here now and continue with this implementation. And what we want to do is simply run the thread on our keylogger. So T1 will be the thread that we are going to use, equals threading.thread. The target will be the target function from our keylogger library, and the function will be start function. So what we are doing with this command is creating a single thread to be run separately from our program. The thread is running the function which is stored in the keylogger library, and the function is called the start. And all we need to do is actually start the thread, so we can just t1.start. Now make sure to not confuse this start function right here and this start function right here. Basically, this start function is a start function from our keylogger program, and this start function is a start function that will start a thread, and it is a part of the threading library. So those are not two same functions, so don't worry about that. And the next thing we want to do is how we can actually get those keystrokes back. We need to get those keystrokes back by reading from that file and sending the actual keystrokes to the server. So else if, let's do something like this, else if command, and then first 11 characters are equal to the actual keylog underscore dump. What we want to do is open that file, and remember that you actually need to have the file specified right here. So basically, we want to add, first of all, a global variable, which will be the same file path to the actual file path of the process manager.txt that we coded in our keylogger. So all we need to do is, first of all, let me just save this, nano my keylogger.py, copy this path right here. So copy it, nano our reverse shell right here. Let's go all the way down, and right here let us paste that path, so it will be global path. We can use it everywhere we want. Let's call it keylogger underscore path. Now make sure that before you actually use it right here, that you specify at the beginning the global path variable. Otherwise, I don't think that you will be able to use it in an actual shell function. So global keylogger path, or let me just check it right here. Maybe you will be able to use it. Keylogger path, okay, so keylog dump. Let us just go with this way, and if it doesn't work, we'll just fix it. So fn, we are opening a file, so open. We want to open a file at the location of keylogger underscore path. Let me just create space right here for it to look a little bit better. And right now we want to read from that file. As soon as we read from that file, we want to reliable underscore send fn.read. So if I'm not mistaken, this is the entire thing that we actually need to code in order for this to work. And this is the part of the reverse shell code. What we need to do is do a simple modification to our server-side code in order for it to not actually lock out once we actually call the keylog start function. As you can see that this command right here will not send back anything to our server. That's why we need to make sure to actually tell the server to just continue once it sends that command. Since in other case, if we don't, it will just wait for a result which it will never receive. So we can go right here, else if command, and then first 12 characters are equal to the actual keylog underscore start. Okay. We want to simply just continue. We don't want to do anything else. So just press here continue, and it will go to the beginning of the while true loop. So let us save this. And right now, if everything is coded correctly, if we are not missing any library or anything else, we should be good to go, and we should be able to actually compile our program. So let's do it. Wine, and then the root.wine drive C, Python 27 scripts by installer, and then dash no console dash no console one file, and then reverse shell.py. Now, if you want to, you can also use the images, PDF files, or whatever you want in order to make it more believable. But for now, I will just not use it, since all I want to do is test my keylogger. We are not really doing a real attack right here. But if you want to test it out with, for example, image, whether it will open an image or not, you can do that. So let us go right here. Let us go to the dist, plug in the USB drive. Here is our reverse shell.exe. Move the reverse shell.exe to media root Kali live. Once it is out, we can delete everything. And we can run our server and unplug our USB drive. Okay, let us take our reverse shell, place it right here, and run it. Hopefully we don't get any error prompted right here, and we indeed don't. So let us go to our actual Kali Linux and wait for the connection to come back, and then we will test our keylogger. Now before we do any of that, you can check right here. If you just type right here dir, you will notice that right now we have the windows32.txt, but we don't have the process manager.txt. So once we run the keylog_start function, it should create a process.txt in this directory right here. So here is the connection back. Let's test with a simple command, who am I, help, works. And now if we just type keylog_start, nothing is prompted back. If I just type who am I once again, we can still execute commands. But you can see right here, there is no process manager, but if I just type dir once again, you can see right now, there is a file called processmanager.txt. And if we just type in our terminal, hello world, how is your day today? Okay, so I mistyped the Y with Z, doesn't even matter. And if I just go in my Kali Linux and just type keylog_dump, you can see who am I, key backspace, hello world, how is Zour days today? That is because I mistyped this. And we can see that it prints everything well enough, and our keylogger simply works. In any case, what we want to do is basically add also the keylog start and keylog dump to this actual help options right here, so we can have them stored there. So let us just quit the actual connection, go to our reverse shell, and add them here. So we can just add them before the actual q command, doesn't even matter, keylog_start, and we will need to move this a little bit, so let us just do it like this. Just so it looks prettier. Okay, so keylog_start will start the keylogger. Let's also move the Q as well. And let's add the keylog_dump. So keylog_dump will dump the keystrokes from keylogger. Okay, so these are all our available options. Let us save this. And right now our reverse shell is, I believe, complete. There is really nothing else to add right here. Of course, as I said before, you can add anything you want. If you have any idea what you would like, you can also search it up on the internet. For example, if you want to record microphone, you can just search up how to record microphone with Python, and then you would save that to, for example, an audio file, and then you would send the contents from that audio file to our server, which will then save that on our Kali Linux machine. It is simple. It is the same principle as for the images, so nothing really to worry about there. Basically anything that comes to your mind, you can just input it right here. Also, if you want to, at the end of an actual program, you can join this thread right here. So let me just set it right here. In order to create this, since you started this thread right here, you can also code a part which will close this thread, and then you can delete the processmanager.txt folder right after you quit the connection. For that, you will need to set a certain flag, for example, a flag in the keylogger, which will check every time whether that flag is set. If it is not set, then it will actually close the actual function. We will see an actual principle behind it in the next section, where we'll code our threaded server or our command and control center. And basically then, once you see it there, if you have no idea right now how you can implement it, you can come back to this program right here and implement it in the keylogger program. Then you would use a thread.join in order to join threads at the end, and then you would need to delete the process manager at the end of the program so you can leave no trace behind. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome to this section where we'll code our command and control center. Now before we begin, let us explain what the command and control center is, or as should I say, the threaded server. Now, as you can see here, I have our server code from the previous sections where we simply just got our shell back and we started executing some of the functions right after we created the socket object and right after we binded the port and listened for the incoming connections. Now, the server, basically the principle, is similar to this, or not similar, it is rather the same to this, just we are not accepting one connection, we are going to accept multiple connections to our server, and we will be able to manage multiple sessions with different targets at the same time. What we will do is we will code a simple command control center which will have a while true loop inside a while true loop, where we will have a certain outline part where we will code the commands for the center itself, and then we will just paste the shell function from here as the inner while true loop, which will be referring to a single connection if we want to communicate with a single target at a time. We will also code a function which will be able to send or not multiple commands, which will be able to send one command to multiple targets at the same time. Now, the reason why we need this, basically that is the principle behind the DDoS attacks. If you send to multiple targets at the same time to ping a certain target, then all of them will at the same time send packets to the target, which will make the target crash. Now, the more PCs you have, the easier this will be. But for now on, we are not really learning how to run a DDoS attack, since there is really no point in learning that. It is rather simple, and basically you shouldn't be doing it unless you have the permission to do so. But what we are teaching right here is how you can actually accept multiple connections to your PC. So let us see how that will look like. I have Paint right here, and you can see in our server, the first thing we do once we set up the actual socket is we actually waited for the target and IP in order to accept that. What we will do in our actual threaded server is, let's say this is our Kali Linux machine right here. Such a bad drawing, but doesn't even matter. This is our Kali Linux machine, and it takes the connection from, let's say, two different PCs at the same time. So this is PC A and this is PC B. Oops. What we will try to implement in our code is a function which will accept the connections, such as the server function from our server video. It will basically use the socket.accept function from the socket library in order to accept the connection, but we will run that server function in a thread. So we will try to run it the entire time. And as soon as someone connects, we will create a list. Our first list will be a list of actual socket objects, which will be a socket object from, let's say, the first one that connects is the PC A, and then the second one that connects will add to a list its socket object, which will be PCB. Then we will have a list, which we will name, for example, targets or something like that, containing these socket objects. And another list we will have in order to contain the IP address from those socket objects. So IP from the actual A PC, and the next one, once B connects, we will have the IP address and the port from the actual PCB. Now this list right here, the second one, only we need in order to determine and differentiate different targets. So we want to have their IP addresses, and we want to know from where the connection is coming from and to who are we actually connecting to. While as the first list, we will use to enter the shell function, which will allow us to communicate with one target at that certain time. So let us see what we need to do. Basically, as I said before, we will have to code two different options for our center. One of them will be, for example, we will call it Q, as in the previous server, but that Q function will not close the connection, it will just close the connection from the center in order to connect to a different PC. You will still be able to access that other PC even though you specified Q to close the actual shell. You will be able to just select it whenever you want and connect to it whenever you want. So that would be about it for the introduction. Now, of course, if you don't understand it at the moment, don't worry, you will understand everything in great details as we go through the code. So that will be about it for this introductory video. Hope you enjoyed it and take care. Bye. Hello everybody and welcome to our first coding tutorial for our threaded server. Now, this is our server, so let us close it. and let's name something called threaded.py. We start with the user bin Python, and we will import right away all the libraries that we need. Since I already have the prototype of this program, I will just import everything right now, and we will go through the code together while coding it. Now make sure to realize that first of all, this is not something that is properly coded, neither it should be. For as long as it really works, it doesn't really matter if we imported classes or imported anything else. We'll try to make it as simple as possible so that you can understand it the better. And then if you want to later on, you can just do some modification to the code for your own needs. We are not, once again, we are not the programmers, we are hackers, and all we want to do is get something to work. Then afterwards, if we want to, we can add specific modifications to it for our own needs. So we included our user bin Python line. Right now, let us import the needed libraries. First of all, we know that we are going to need our socket library in order to perform the connection, the binding, the accepting, and the communication between the targets. We also need the JSON library in order for us to implement our reliable send and reliable receive functions, which will allow us to specify any amount of data we want to be received and sent from the target PC. Next thing we want to actually import is the OS library, and the next thing is the base64 library. Now we know that the base64 we will use in order to, for example, receive images and so on and so on. Anything that basically is not a TXT file will crash if you do not encode it and decode it during the sending over socket object. And one last thing, but the most important thing for this project, right after socket, is the threading library. So we cannot create the actual threaded server if we actually do not import a threading library, which will allow us to do that. So first of all, what we will start is actually coding the simple socket connection now, or binding the socket, however you want to call it. This will not be put into any function anywhere. This will simply be outside of any function. Let me just show you. We will start off by creating a global variable s. Now that global variable will be our socket object, but before we define the socket, let us create the two lists that I was talking about in the previous video. One list will accept or will get the actual IP addresses and binded ports to those IP addresses from the target, and the second list will get the socket descriptors that will actually define to who does which the socket object belong to. So IPs will be the list containing the IP addresses of our targets, and the targets will be the list containing the socket objects of our actual targets. Now we can actually create the socket object itself. It doesn't even matter. We will use the same as in our server. So socket.socket, socket.af_inet, socket.sock_stream. Same thing as before. So we want to use the IPv4 connection over TCP. Let's set the socket option. So set sock opt. We want to use socket.salt_socket and socket.so_vuse ADDR, also comma 1. And we created everything that is actually regarding our socket. All we need to do right now is bind a port and the IP address and listen for the incoming connections. So we already know how to do all of that. Of course, we are already familiar with everything. We need two open brackets and two close brackets, and we need the IP address of our Kali Linux machine, which is 192.168.1.9 in my case. In your case, you can check it out. And let's say we want to connect to the port 54321 as our usual port. This is our listening port actually. And now we want to listen for the incoming connections, and let's specify 5 connections for now on. So this is our socket creation. We will leave it just like this. All we want to do right now is make an actual function which will accept the connections while the rest of the program is running. Now this may be sounding a little bit complicated, but it really isn't once you really understand it. Basically what we will do is we will go up here and we will make a server function. So right here, And that server function will run a while true loop, and in this infinite loop, it will accept connections. So what we can do is, first of all, in order to accept connections for a short period of time, we need to set this socket timeout. So s.set timeout, we can set it to be just 1 second, and then we can try and accept. What we will try is we will try the target, IP equals socket.accept. Now make sure to differentiate. This is not targets and IPs. This is just target and the IP. So in singularity, not really the list that we specified right here. Now, as soon as they connect, we want to append the target to the targets list, which we created right here. So currently it is an empty list. Let me just think about it. Yeah, it is an empty list right here. And right here, we append the newly connected target to the actual list. So, or not targets.target, we want to targets.append, and in brackets, we need to specify what we are appending. The same we need to perform with the IPs. So IPs list.append, we want to append the newly connected binded IP with the port. Then we can print to the screen string from targets, and then what we need to do is find a way how we can actually pick a certain target from this list. Now we know that we can pick it with a number, so what we want to do is add a counter. The counter we can actually call the client, since at the moment at the beginning we can set the clients. So let's go down here. Clients variable will be equal to 0. Not cleanits, we need clients. So clients variable is equal to 0. Right after creating the socket, we don't have any target connected, and we can use the clients to be equal to 0. Then in our server function, we need to specify that we are using the global variable clients, and there, once we actually connect, once the target actually connects, we want to print the string from the targets list, from the element add the number of clients, which in this case will be 0, since our first target will take the element numberized under the number 0 in our targets list. Then after we print it, we will increase the clients by 1 for the next target that it might connect. So we close the brackets right here. We can print something like this. Doesn't even matter. Plus string from IPs, and then once again we want to use clients. Now, if you find this confusing, let me just see how many brackets I have closed and opened. 1, 2, 3. 1, 2, 3. Okay, everything is good. Now imagine something like this. Imagine our target actually has 2 pieces connected, or our server has 2 pieces connected, A and B, and also targets A and B, as we saw in the previous video once I draw it in the actual paint. Now, the actual clients will be set to 0, and this 0 client will represent the first client, which is client A, or target A, or however you want to call it. And then when A connects, we will print the session 0, which will be the target A, to be printed as it did connect. So we print it right here, print the string from this client, plus the string from the IPs of the client, and that means that someone has connected. So we can add it right here. Print string from the clients. You just see where I need to actually plus. And we can do something like this, has connected. Doesn't even matter, you can print it or you don't have to print it. It's not really that important. What is important is afterwards you increase the clients by 1. So we are increasing the clients, and then the next client, which will be client B, will take the element numberized under the number 1 in this list. And then we will print the 1, and then it will increase 1 once again, and then for the client C, and so on and so on. So that's the basics behind of this. Of course, in the accept rule, we need to just pass since really we are not going to do anything in the except part, there is really no point, and there is nothing really logical to do about it. What is logical to do is, you will notice, since we will run this server function in a thread, we need to actually create a flag variable, which will be a Boolean value, either true or either false. And what this flag variable will do is basically it will determine when this server function will close. Since this is an infinite function, we will never be able to close the program fully until we close this function right here. So in order to do that, we need to specify a value right here that will actually check, or not a value, we need to specify an if-else statement, which will check whether the flag is set or not. If it is set, we will quit the actual listening and accepting the connection, and we will quit the program, or our command and control center in this case. So let us make a variable right after the clients. We will call that variable stop threads. This is just a simple flag for our server function. We will set it right at the beginning to be equal to false, and then we will check in the while true loop in server whether it is set to be equal to true. So if stop threads is basically the same, if stop threads is equal to true, then we want to break from this while loop and quit this server function. And all we are left to do right now is actually start a thread on our actual server. So let us go down here and let's type it right here. T1 will be the name of our thread, will be equal to threading.thread target equals server. And then T1.start. And basically we finish this server function. We will make a pause right now and we will continue in the next tutorial. Let us make a brief overview of what we did right here. We created a simple socket object. We created two lists that will accept the clients or our targets. One of them will accept the socket objects. One of them will accept the IPs and ports. Then we created a simple variable clients, which will increase every time we actually get a connection. And basically, we also set the stop threads to be equal to false. And that is our flag, which will check when we actually want to close this server function after quitting the command and control center. We will set the stop threads to be equal to true, and then it will set this, it will check this statement right here, and then it will break out of this loop, closing this server function. Afterwards, at the end, right now, all we did was actually create a T1 thread that has a target argument of our server function, and we started that thread. So that would be about it for this tutorial. We'll continue in the next one, so hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to our command and control center coding. So, in the previous video, we finished all of this code. We coded our server function, we started a thread, and what we want to do right now is enter our first while true loop. Now, our first while true loop will actually be the center itself. So it will be our center command and control, or basically our center command line, where we will send the commands for all the targets at the same time. Now I will show you what I mean. Maybe if we finish it, you will understand it a little bit better. All we want to do after creating a thread and running our thread, we want to enter a while true loop. Oops. So while true, this is our first while true loop, and we will set a command variable to be equal to raw_input. And there we can actually take something similar as to our shell input. But right now, since it is not shell anymore, it is center, we can just do something like this. So center, or basically just center, doesn't even matter. You can specify anything you want later on. For now on, center will be good enough. Now let's see what possible commands we can send to our center. So first of all, we can send, for example, a command where we actually want to check out which targets we have connected. So we can just type, for example, simply just targets, and then our threaded server should print out all the targets that are currently connected to us. So let's see how we can implement that. It is rather simple. So basically, if this command is equal to targets, which will be our command for specifying all the targets, we can just create a variable which will be, for example, called count equals 0. And then we will just print all the targets from the IPs list that we created right here. So it will have some targets IP's address connected or basically imported in this list. All we want to do is read from this list one by one and print them. So for IP, in IPs, what we want to do is print, so open and close bracket, session plus string of count. So session, for example, 0, session 1, session 2, session 3, and so on and so on. Plus, and let's add, for example, the dot, so it can be session number 0, session number 1, and session number 2. So first, second, third, and so on. Then we can do something like this. Space once again, plus the string of the IP. Now what this will do, the reason why we set the count to be equal to 0 is the same reason why we send up here the clients to be equal to 0, because our IPs and targets will start counting from the 0 element. So the 0 is the first element in the list. Therefore, the session 0 will contain the IP address of the element 0 in the IPs list. So simple as that. Now all we need to do right now is, after we actually print this, we need to increase the count by 1. So count plus equals 1. So what this will do is it will print out, as I said before, all the available targets that are connected to us. So let me just check everything right here. Did we specify the same here? Okay, so we did. Right now, we need to go and perform a second thing that we possibly might need. So let's say that we actually want to enter a session with an actual target. So you remember from the Metasploit framework that if you connect multiple PCs and you type, for example, sessions, you will get prompted Meterpreter 1, Meterpreter 2, and then you can just type sessions -i1 and it will enter the session 1, and so on and so on. Right here we will try to implement something similar. So else if the command that we specify to the server equals for first 7 letters, since we will need to specify the number of the session we want as well, which can vary from our own needs. So, but the first part of the command will always be the same. That's why the first 7 letters of the command equal to session. So session, what we want to do is try and accept to enter that certain session. Now once again, why we are using try and accept? Well, basically, let's say you specify a number of session that doesn't really exist. We don't want our server to crash. So this is maybe a little bit harder part, even though it's not that long of a code. Maybe it will be harder for you to understand. What we need to actually do right here is get an integer number from our command. So our command will look something like this. Let me just specify it right here. Session 3. For example, we want to enter the 4th PC that connected to us. We will specify session 3. And then in order to parse that command right here, we need to make the first number, or the number that will be the number of the session itself, to be equal to an integer of the command of the 8th character and till the end. So from the 8th character will be strip out the session and strip out the empty space and just 3 till the end. So simply just 3 in our case. Then we need to select the target number and the target IP from this session. Now, what I mean by that is our targets and IPs list contain our target we want to specify with this command right here. So we need to access it with this number here, or with this number that we stored in this current variable. So how we can access that? Well, we can simply just type here target number, or shortly just tarnum variable will contain the targets element at the number of our specified number. Now what I mean by this is basically this tarnum variable will contain the socket object of our target, which then we will use to access simply just the target only. We also need to do the same for the IP, so target IP. So tar IP variable will store the IP address and port from the IPs list at the element numbered at the number stored in this variable right here, or the number that we specified with the command. So all we need to do afterwards is, since we have the tar num and tar IP, which is defining our target in total, all we need to do is enter the shell with that target with simply just using the shell function, which we will just paste from our server previously into our current threaded server later on, which will take an argument of the socket object from the target and from the target IP. Then we will enter a shell with that specific target, which will be a second while true loop, which is what I was talking about. So basically we will have a while true loop inside a while true loop. In any other case, so in the case it doesn't work, we will just print to the screen no session under that number. So simply as that, since, for example, let's say we have 3 targets connected and you specify number 7 right here, of course there will not be an actual session with that number. So that would be about it for this video. In the next video we will see how we can actually implement our shell function without coding it once again. Since we already have our payload or our reverse shell that we want to deliver, we only want to do minor changes to both of those servers and the reverse shells. So we will just copy the shell function from our previous server into this code right here, which will allow us to access individual session one at a time. So that will be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to our Command and Control Center. And in the previous video we started off our while true loop, which will take an input of the command for the center itself. We coded the first targets command to be equal to actually printing out all the available connections to our server. And then also we printed the session command, which will take an input of session and then the number itself. And then we will enter that session that we specify with this shell that will take an input of the target socket object and the target IP address and port. So right now, in order to get this to work, we need to save this first of all, nano our server.py, and copy our shell function. But we also want to copy it like this, so copy everything. I need to zoom this out so I can copy everything at the time. So what you want to copy is basically the entire shell function and also the reliable send and the reliable receive. So just copy everything from there. And then what you want to do is, first of all, let me just check if there is anything up here. Okay, so there is not. All we need to do is just print the actual copy to our threaded server. So let me just zoom this back in so you can see everything better. Nano threaded.py, and right up here we can code it right above the actual server. So here it is. We have everything right here. Now, all we need to do is do something that you might find a little bit strange. Basically, what we will do is now we will copy these two functions and paste them in the actual shell. So what we will have is we will have an actual functions within a function. So first of all, you can delete these two. We will not need them at the moment. All I wanted them is to copy them so I can paste them in the shell function itself. So delete it above the shell function and tab these two so that they belong to the actual function itself. So tab every line from these two functions. Now I will show you in just a second why we are doing this. Just as soon as I type this in. Okay, so here it is. Basically what you need to have is the shell function from our server from the previous sections, which has everything the same. So nothing really changed right here. We have our screenshots, keyloggers, download functions, change directories, and so on and so on. And we also implemented the reliable receive and reliable send into the shell function itself. So right now, what you want to do is basically the reason why we did this is because right now you need to add to the shell function the actual argument of the target and the IP. make sure to call it target and IP and not tarnum and IPnum, because you can see in our reliable send and receive, we use the target, right here, we use the IP right here. So basically what this will do is the arguments that is specified in the shell function between the brackets will be actually switched with this target and IP in these other functions within the code itself. That's why we had to put these two functions inside the shell function, so we don't actually code it twice. Right now we can actually call the reliable receive from the shell function itself without changing anything to this entire piece of code that we copied. So all we have to do right now is down here. Let me just see right here. Okay, so we called the shell function with the socket object and the target IP, so that is specified. And now let's see if this will work. Let's actually test this and see whether we get the connection to our session or connection to our server. So let's save this. First of all, let us try to run it, or not server, we want to run the threaded, which we need to probably compile. Okay, so threaded. Now if we run it, we get the center. Okay. And let me just check this out. We need to close this because we are missing something. We need to print listening for incoming connections. So let's see where we actually need to print that. Right before or right after starting the server. We can just print it before starting the server. So just print waiting for targets to connect. And then, for example, 3 dots, close double quotes, and let's save this. Then it will enter the actual server. Let me just check this right here. It will enter this server. Okay, yeah, it should be like that. So let us try it once again. Threaded, address already in use. We know how to fix that by restarting the actual terminal. Let's go right here, cd. Let me enlarge this so you can see everything better. Zoom this in, cd Python programs, and then reverse shell, and then threaded.py. We can see it says waiting for target to connect. Now let me see, we need to actually import my USB drive. Then we need to compile the shell from the previous video. Or let me just see if I already have it. Okay, so I don't have it anymore. So we need to compile it. Go to Python programs, reverse. Basically what you're compiling is the same shell from the previous section, so nothing really changed. So wine root.wine. Drive C, Python 27, scripts, pyinstaller.exe, no console, one file, and then reverse shell.py. We check, okay, so the USB drive is plugged in. You can see our server or our center is waiting for first target to connect. So what we will do is we will first of all try to connect the Windows 10 PC, and then if it works without any errors, we will also try to connect another PC in the actual server, or in the actual threaded server. So let us go to our this directory right here and move the reverse shell.exe to media root Kali Live. Okay, so we no longer need this. We can enlarge this right here, unplug the USB drive, and let's see whether this will work. So paste this right here. Everything is good to go. It shows no error while running, as it should. And basically right now we are waiting for the first connection. So it should print the socket object, and it should print the IP address, and also it should print as connected to the server or something like that. I forgot what we specified in our code. Here it is. As you can see, socket object at this address has connected from this IP address from this port. And basically has connected. So just click enter, you will get the center right here. And if we type targets, you can see we get a list of currently connected targets and their IP addresses. In our case, it is just one target right at the moment, and it is under the session 0. in order to be able to access this target, we can just type session and then space and then 0, which will lead us to an actual shell with this target. And then we can execute all the previous commands such as QMI, ifconfig, and so on and so on. Or pardon me, it's ipconfig for Windows. So here it is. Now we have a problem. In our shell, we have coded that once we press Q, it will actually quit the connection itself. So you can see right here targets, and then if we try to enter session once again and type who am I, it will not work. We will not get anything back. So this is something that we need to fix both in our threaded server and in our reverse shell. And we will do that in the next video, and also then we will try to connect multiple targets for the first time. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to our Command and Control Center coding, and let us continue with our server. So right now, if I go to my Python programs, reverse shell, nano my threaded.py, you can see in the previous video we had a simple problem where as we actually entered the shell successfully and were able to execute the commands, once we pressed Q, our shell actually disconnected and we were not able to access it anymore. So what we want to do is actually we want to actually fix this. So once we press Q, it doesn't close the connection, it just lies in the background waiting for the next command, while as we can enter a different session with a different target. So you can see in our threaded.py, let me just go right here. If we go to our shell part, which is up here, which is basically the shell part that is copied from the actual server from the previous section, we have if command equals to Q, then it is break. Now we want to leave this. We don't want to change anything right here because we actually want to break out of the while loop with the shell in order to get back to the actual center right here. Where is the center? Okay, so here it is. Once we press Q, we want to break out from this shell function and go back to this part right here. But in our reverse shell code, so let me just show you, nano reverse shell.py, or we have multiple, so reverse shell.spec. So nano reverse shell.py. Here in our shell code, you can see that if Q is specified, it is said to break out of the loop, which will basically terminate the connection since there is no outer loop for this program, and then we will just close the connection and close the reverse shell itself. So what we want to do right here is instead of, once we press Q, instead of it breaking and closing the program, we want to just continue. So all we want to do is simply just continue the program, which will go through this loop and go back here waiting for the next command. And it will just stay at this line until we actually enter the session with this target once again and want to execute some different commands. So let us see how this works. We need to compile the reverse shell once again. So root.wine drive C Python 27 script spy installer, no console. What is the next one? One file, and then the name of the file itself. But right now, we also want to try it on multiple targets. So let me run my Windows XP right here. I could have run Windows 7 as well, but Windows 7 takes a little bit more memory. So since I'm running already one virtual machine, I will just open Windows XP in order for this to not work that slow. So let's wait for this to actually compile till the end. Then let us plug in my USB drive. Let's see if our Windows XP is starting. Okay, so it is starting. Now you can test this on any Windows you want. Okay, so the Windows starting sound. Now you can test this on any Windows you want, doesn't have to be Windows XP. You can also test it on different machines if you want to, as long as they are all currently on the same network. We will see later on how to perform this while the targets are being across the actual internet. But for now on, everything should be on the same network. So that's why I'm using the actual Windows XP as a virtual machine. Now let me move my reverse shell to media root. Okay, so it is root media. Did I plug in my USB drive? Let me just check it. Where did it go? Let us unplug it and plug it in back again. And right now, hopefully it is there. Okay. We plug it into our Kali Linux machine. Let's wait for it to connect. Okay, so here it is. And right now we move the reverse shell to media root Kali live. Then we can unplug the actual USB drive. We need to paste the reverse shell to the desktop of our Windows 10 machine, and then we also need to paste it to the desktop of our Windows host. So let us go devices, USB drive, import the actual, this device can perform faster. Okay, so where is the actual device? Safely remove hardware, we do not want that. Let's access it from the actual My Computer. Of course, Windows XP is slow, but we can manage as long as it opens this. Okay, so here is Kali Live, and here is our actual reverse shell. So we paste it to the desktop here as well. And these are our two targets. So right now, let us run this. Error loading Python DLL. This application has failed to start because the application configuration is incorrect. Pre-installing the application may fix the problem. Okay, so I believe this is something to do with the actual Windows XP itself. So let us try to run it right here. Okay, so here it does work. Let's run our threaded server. Waiting for targets to connect. And let us try once again with our Windows XP. Not really sure why it doesn't work right here. It basically worked once I tried it 2 days ago, but for some reason right now it won't work. Error loading Python DLL. This application, okay, some configuration is incorrect, not really sure what. But what we can do is we can actually try to run Windows 7. Hopefully it will work there. If Windows 7 can even start up, because it might take too much of the memory, but hopefully it will work. Now let's see, while Windows 7 is starting up, whether we got the connection from the Windows 10. Okay, so Windows 10 at this IP address has connected. If we type targets, we can see session 0 is connected to the Windows 10. Now let's see, while the Windows 7 is starting up, whether we can enter this session and close the session without closing the connection. So session 0, type who am I, we get the output back, and we press Q, and we type targets again. We still have session right here, and let's say we want to enter it once again. Let's see if we can still execute commands, and we can. So we successfully coded a part of our reverse shell and threaded server where we can just close the connection without actually closing the connection, if that makes any sense. Then we can enter back anytime we want to this session and start executing commands on that PC. Now let's actually do the same on our Windows 7 machine. Activate later, so it doesn't really matter. We don't want to activate Windows right now. What we want to do is we want to import our USB drive in order to paste the reverse shell to the actual, what do you mean, was not successfully installed, computer. For some reason it doesn't want to be there, so let us go right here and plug it in once again. Okay, so for some reason our Windows 7 doesn't even have or can't really find the USB drive, but there is another way we can do this. What we will do, we will open a second terminal. Not really sure why none of these ways works right now, but we will just download it over Apache 2, since our USB drive is creating problems for some reason. Yeah, first of all, we need to unplug it from the Windows 7 machine, and then we can plug it into our Kali Linux. And right now, we want to navigate to the media root Kali Live and move the reverse shell.exe to var www.html. Right now, if I go to my Windows 7, go to my Internet Explorer, I will download the reverse shell from there. Now I can close this terminal, don't really need it. We are still waiting for the second connection right here. We go to the IP address of my actual Kali Linux, so 192.168.1.9. Here is the reverse shell, so I copy it, I save it to the desktop. Okay, save, and then I can run the actual file. So press here run. It will say the unknown publisher, just click here run, and it should run the reverse shell. As you can see, currently there are not any errors, so that was a problem with my USB drive. Right now everything works well, and soon enough, in just a few seconds, we should be getting a second connection to our threaded server. As we can see, we already have one, and here is the second one from the different IP address. So we can see this one is 192.168.1.6, and this one is 192.168.1.5. If I just type here targets, you can see currently we have two sessions connected. One of them is my Windows 10 PC, and one of them is my Windows 7 PC. If you want to enter Windows 10, for example, we already saw session 0, who am I? You can then quit the session and then go to the session 1, type who am I as well, and you will get a different output since we connected to different PC. And then you can go back and forth as long as you want. You have two PCs connected, waiting for your actual commands. So our threaded server works. All we need to do is fix it up a little bit, add some different functions to it, and it will be good to go. So hope you enjoyed this tutorial, and I hope I see you in the next one where we will continue coding. Bye! Hello everybody, and welcome back to this tutorial. And in the previous video we saw how we can connect multiple PCs and multiple targets to our threaded server. We saw that it worked with two targets. We were able to manage two connections at a time. We were able to switch between those two sessions without closing the actual session and actually running the commands as we need on a target as we need. Right now, there is a little bit of a problem in our program, as there really isn't a proper way, or we didn't code it yet, a proper way to close the program or the center itself. So what we want to do is, first of all, we need to use the flag that we coded in the server function. So let me just show you. If I zoom this in and go to my Python programs, reverse, delete the compilation builds, ls once again, and if I nano my threaded.py, you can see right here that, let me just go down here, we coded the stop threads to break right after we actually set it to be equal to true. As you can see at the beginning of the program, we set it to be equal to false. Now we need to use this actual variable that we set in order to properly close this thread. So we can do that in our outer while true loop. So this is our session part right here, which is coded. Now we need to add another statement right here. So for example, else if command, and then the first, or just the entire command. We don't need to use the first letters. The entire command, if it is equal to exit, so this will close the program. And how we can do that? Well, first of all, we have, let's imagine we have a bunch of connections and socket objects connected to us. So we need to close each of those targets or each of those socket objects before actually closing the program. How we can do that is we can iterate over this targets list, which is containing the socket objects from the targets, and we can close them one by one. So for target in targets, so for some variable target, don't confuse this target with an actual target that we parse to the session itself. So for target in targets, what we need to do is simply just target.close. And this will close all of the socket objects with certain connections. And after that, we need to close our own socket object that we coded right here. So here it is. We need to close it right after closing all of this. And then, after we do all of that, we can select our stop threads variable to be equal to true. What this will do is then this will be set to equal to true. Our while true loop in server function will go from the beginning to the end, then it will run onto this line. It will check whether stop threads is true. Right now, this statement will be fulfilled, and then it will break out of this server, closing this function. Now make sure that this line right here is critical for this function s.setTimeout1, because if you don't have a timeout, this part right here, which is the accepting part, will try to accept forever, and our server code will actually be stuck on this line, and it will never go to this line right here. Therefore, it will not be able to close the program properly. It will be stuck on this accepting the connection and waiting for someone to connect, and then it will never reach this line. But if you set the set timeout to be equal to 1 second, for example, it will try to connect or to accept for 1 second. If nobody connects, it will just go right here. It will skip this, it will pass, it will go check this, and then once again 1 second, and so on and so on. So we set the timeout there. We set the stop threads to be equal to true now. And all we want to do right now is join the thread of our server. So t1.join, join it to the main program, and then we can break out of our while true loop, which will close our program. So simple as that. Let me just check this out right here, whether we coded everything we need. Now also, one more thing is, let's say we want to close a connection with just a single actual session. So you can see right here that we no longer have the actual Q command to be specified as closing the session, and we are not really able to close one session at a time. But that is something that we want to implement. So let's go in our shell part right here with the function that will communicate with a single session at a time. We want to type here else if command equals to exit. Now don't confuse this exit with the exit that we just coded right here. This exit is the exit that corresponds to the server part or the center part, command and control center part of the while true loop. And this exit function right here is the exit command that corresponds to the while true loop of our shell function, or of our function that will communicate with a single session at a time. So what we want to do is simply just close the actual socket object for that target, and we want to remove it from the list. So targets.remove, and we want to remove the target. We also want to remove this target from the IPs. So IPs.remove IP. And then we can break out of this loop for our shell. So let's make sure we got this correct. If we specify exit in a certain shell, for example, we communicate with Windows 10 and we no longer want to be connected to the Windows 10, we just type exit, it will close the socket object, it will remove the socket object from the targets list, it will remove the IP address from the targets list, from the IPs list, and then it will go back to our while true loop of our center. So basically, if you specify exit, you will not be able to connect back to Windows 10 as long as they don't run the shell once again or restart their PC. And if you specify Q, you will be able to actually communicate with other sessions without closing the current session. So it might sound a little bit complicated, but you will get used to it. It's really not that hard of a program, so don't worry. What I wanted to do right here, let us just check out whether we coded all of this correctly. Now there is a part that we need to code in the reverse shell as well, since if you remember, we don't really have any command called exit in the reverse shell. So let us go right here. Let me just go right here, reverse shell.py. We need to nano it, so nano reverse shell.py. And right here, we go to our part in the while true loop. And here, if command or else if command equals to exit, what we want to do is simply just close our socket object. Let me just check it out here. How did we name it? Where is the connection function? Here it is. So sock.close, we want to close it. and we want to break out of this program. So simple as that. I believe this should work. Let us save this right here. Or no, we don't really need to do it. We have it right here. So sock.close is already specified there. Let us remove it from here. All we want to do is just break out of this loop. So we don't need to close the socket object right here. Let's save this. And now we need to compile it once again. So wine, root.wine, drive C, Python 27, py or scripts, PyInstaller, no console, one file, and then the reverse shell.py. Okay, so the USB drive is already plugged in. I will use USB drive to actually deliver it to the actual Windows machine. So it is all okay. So I forgot to close the previous reverse shell. Let us close it with Task Manager, delete it from here. I also didn't close it with the Windows 7, but it doesn't really matter. Yeah, it doesn't even matter. We will just name it differently. Okay, so let us go right here. The compilation hasn't finished yet. Okay, so here it is. I will go to my this directory and I will rename my reverse shell to shell.exe. Now, you don't have to do this. I'm doing this because my Windows 7 machine, so I don't bother to actually close the reverse shell from Task Manager there. So I will just name it differently, and then I will move my shell or copy my shell to the var www.html, which is my Apache 2, and copy the shell to the actual USB drive, which is media, root, and then Kali Live. And then what I can do is I can delete all of these compiling directories, and I can start my threaded.py. Then I can unplug my USB drive, so I can actually get it to my Windows 10 machine. Here is my shell.exe. I run it. Everything seems to work well enough. I go to my Windows 7 machine. I go to my Internet Explorer, refresh the page. Here is the shell.exe. I download the shell.exe for my Windows 7, so click on it. Save on desktop. And we can actually run it as well. Click run. Since we downloaded it from the internet, it prompts us with an actual warning, which is usual for every exe file you actually get or download from the internet. We can see our Windows 10 machine has connected. Now we're waiting for our Windows 7 machine, and then we will actually test out whether our program or whether our connection can be established and closed at the same time. So we connected back the Windows 7 as well. If you just type here targets and enter session with Windows 10, who am I? Works. Let us press Q to not close the session, but to actually go in, make session go in background. So, and now session 1, who am I? Also works. So now if I want to go to session, let's close the session with the actual Windows 7 PC. So ipconfig should be 192.168.1.6. This is our Windows 7. And if you just type here exit and type targets once again, you can see that I no longer have here the actual session 1 with my Windows 7 PC. And if I want to enter my session with the actual Windows 10 PC, I can still do that and execute commands as much as I like to. You can run screenshot if you want to. You can run any other commands that we used from the previous sections where we coded our reverse shell. And if I want to close the session with the Windows 10 as well, I just type here exit. And if I just type targets once again, you can see we no longer have any targets right here. But right now what we want to do is also exit the center itself. So we want to close the program. And if I just type here exit, you can see the program closes properly as well. So we coded everything successfully. We can close sessions, we can manage sessions, we can switch between sessions. We can also properly close our center program. We can actually do anything we want with our targets, accept multiple connections. all we need to do is code a very useful function, which is rather similar to some functions we already have, and I will show you in the next video. But this function will allow us to actually run a command and send it to every target that is connected to us. Now imagine you have 200 PCs connected to you. You don't want to go to each session for each PC and run certain commands one at a time. You want to have some function that will send that command to every PC, and then they will execute that command. That is the basics behind running, for example, the DDoS attack. You send to everyone a command to run a certain SYNFloodr or pinging program or anything that you upload to them, and then they run that at the same time, and that's how they can crash web servers and other hosts. So we will see how we can do that in the next video. Hope you enjoyed this one, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we will code a function for our threaded server, which will allow us to send just one line of a command, which will go to every PC that is connected to us, and then they will execute that command. So let us see how we can do that. If I nano my threaded.py, we will use the function reliable send, but we will copy it, we will do just some simple modification to it, and it also needs to be outside of the actual shell function. So just paste it right here. Let's tab it properly, so let's delete all these empty spaces. Tab it once, same with this line. Tab it once, same with this line, and this line doesn't have to be tabbed at all. Now this function, since I said it has to be renamed differently, so we will name it sendAll, or send to all, we can do something like that. And it won't take an argument only of data, it will take two arguments. One of them will be the target, or if you want to call it the socket object for that specified target, and the other one will be the data, or if you want to specify it as a command that we're going to send to that target. Now all we want to do right now is actually go down here to our while loop, and we need to code what happens once we actually call the send to all function. So right here, else if command, and then the first 7 letters equal to, for example, send all. Now make sure that this is how our function will look like, or our command. So send all, for example, send all ping 192.168.1.1. which is, for example, sending all targets on my local area network to ping my router, and then they would ping my router. This is why we're using first 7 letters to equal to send all. And then we will strip that send all, and we will use just the remaining of the actual command. So we'll set a variable x, or let's not call it x, it might be confusing, so let's call it length underscore of underscore targets equals length, and then in brackets targets. What this function right here will do is it will check how many elements are there in our targets function, or basically how many socket objects are there in that list. Basically that means that we're counting how many PCs are connected to us. Then we can print that just to check it out if it works. So print length. Okay, so let me flip these 2 letters. So length, or actually, you know what? We don't really need to print this. There is not really a point. What there is a point is we need to set up a counter, which we can call just I. So counter I equals 0. And then we need to try to send to our targets and accept in any other case where it might actually fail. So let's code the actual accept first. We will just print to the server exclamation mark fail to send command to all targets. So we can do something like this, but in the try we need to actually code something like this. So while our counter I is smaller than the length underscore of underscore targets, so as long as it is smaller number than the length of targets, that means we need to continue sending. So first of all, we need to get the target number. So let's call that variable target or tar number, and then that tar number will be a socket object for that specific counter number, which we can specify with equals targets and then in square brackets I. That's how we are selecting an element. For example, if I is equal to, and then tar number will be equal to the socket object of the targets list element under ID 2. Then we can actually print the tar number so we can see to who are we sending. So print tar number, and then we call our function that we coded, so send to all, and it takes an input of tar number. Let me just go right here. And this might be confusing to you right now. We want to send the entire actual command. So I will explain why we are sending the entire command and not the stripped command from the send all word. We actually want to send the command to the targets with the send all string attached to it, and I will show you just in a second why, as soon as I actually increase my counter, so we need to increase it by 1 each time. Okay, so this is it. We save this, hopefully this is all good, and now we need to go to our actual reverse shell to finish the part of code there as well. Since, as I said, we are sending it with the send all string, so we need to see what happens in our reverse shell once it receives a command with a send all string. So in order for us to not actually confuse the shell with anything else, we need to run that command that we get with the send all as a certain sub-process, so that it doesn't actually crash our connection and that we can actually even later enter our session and start executing some normal commands that we want. Now let me show you. If I go right here, we can code it right here. So else if command equals to the send all, or not the command, we want the first 7 letters of the command equals to send all. And let's close the actual double quotes right here. We want to sub-process and open a process. We want to open a command from the 8th letter till the end, which will be just the command that we sent, such as ping 192.168.1.1, and then shell equals true, and then we close the brackets, and this is basically it. Then it will open it in a different sub-process, and then it will go back and wait for the next command, which we can execute as soon as we join that session once again, or as soon as we actually send another send all command. So let's save this. Let's compile it. Hopefully everything will work good enough. Not Python. Okay, so PyInstaller. Okay, so we need to go to scripts first, then PyInstaller. No console. One file, and then reverse shell.py. So let's copy it right here, waiting for it to compile. Then I can go to my USB drive, plug it in for my Windows 10. Let me see if my Windows 7 is up. It is. I will go to my Apache 2 right away. So 192.168.1.9. USB drive plugged in. Now we are waiting for this to finish compiling. It should be over soon enough. So here it is. And all I want to do is just transfer my reverse shell. Let me copy it, since I'm copying it to 2 different actual folders. One of them is the USB folder, and one of them is my var www.html, or the Apache 2 folder. Then I can just simply start my threaded server, waiting for targets to connect. I can unplug this. I can refresh this page and get the reverse shell.exe, save it on my desktop. Oops. Let's first go with the Windows 7, save it on my desktop and run it. This is ran. Now right here, I need to open it as well right here. So reverse shell, open it right here and wait for these 2 PCs to connect back to us. Then we will test the send all command by actually running a simple command making directory, so mkdir test, we will just run that command and see if both of these machines create a test directory right here on their desktops. Then you can just perform and check also with the actual Wireshark if you ping a certain machine. If you, for example, ping 192.168.1.9, which is my Kali Linux machine, and we open up a Wireshark there, we can see whether we get pinged by both of these machines, so we can test that as well. But right now, if we just type here targets, we have session 0 and session 1. If I go send all, and then mkdir test, it says it prints out the socket objects to which it sent the actual command to, so 2 sessions, which is actually true since we have 2 sessions connected. Right now, we can see on our Windows 10 machine, we have the test, and right here, for some reason, we don't really have a test on our actual Windows 10 machine. Not really sure why is that. So let's try with another command. Send all mkdir lowercase test. Nothing really happens. Now, let me check something out right here. Okay, so I tested everything, and basically the problem was because I used the compilation of reverse shell before we actually coded the send all function. For some reason, I don't know why I got the older version on Windows 7. That's why it didn't want to create the actual folder on our Windows 7 machine. But right now I compiled the reverse shell once again without changing anything at all, and send both of those reverse shells to the actual Windows 10 PC and Windows 7 PC. So let me show you what I mean by that. We will just start off everything from the beginning, and by everything I mean running the server and running the reverse shell on both targets. So once again, I didn't change anything, so you can run the reverse shell if you compiled it correctly previously, or if you compile the newest version of reverse shell. And now we wait for it to connect, and then we will try to create test files on both of these targets with one command. So we can see my Windows 10 has connected. We're waiting for the Windows 7 right now, and here it is. Targets, we get the session 1 or session 0, who am I? This is Windows 10, I believe. And session 1, this is Windows 7. And right now, if we just type send all, and then actually mkdir test, we send that. We go to our Windows 10 machine, or Windows 7, pardon me. You can see there is a test folder right here right now. And also on my Windows 10 machine, there is a test folder. So if, for example, you had 100 PCs connected to you, with this single command, you would create a folder on all of those PCs. Now, if you want to actually try it with Wireshark as well, you can just open up your Wireshark in Kali Linux. Wireshark, and then we can actually try to ping our Kali Linux machine from both of these IPs and see if we will get packets from both Windows 7 and Windows 10 machine. So let's wait for this to open up. Here it is. We need to go on our interface in order to listen the packets, which is ETH0. Double click on your interface, and now basically you need to filter out, so we don't get all of these packets. We want to filter out for the ICMP packets. Now everything is a little bit slow because I'm actually running 3 machines at a time, Kali Linux, Windows 7 and my Windows 10 machine. So let's actually just wait for this to unbug so we can actually use it. Okay, so here it is. Delete one I, so ICMP, press this blue arrow right here. And now we filter only the ICMP packets. So right now, if I go once again, if I go once again to my actual terminal running the connections, and I type send all ping 192.168.1.9 and press enter right here, in a few seconds you can see that we are receiving packets from both of these IP addresses. we are getting the packets from 192.168.1.5 and also from 192.168.1.6. These are just our Windows 7 and Windows 10 machine pinging us because we send them the command to ping us. Now imagine sending this to 1000 PCs. Even this ping command could present a little bit of problem to our connection if we actually tried to ping a certain target with multiple PCs. Now what you can do with this is you can upload a DDoS tool or something like that, a synthloader, so you can compile a synthloader to exe. We called it synthloader before in this course, and then you can upload to every target the synthloader and with one command run it on every single target. Simply just with one command, with just send all start synthloader.exe on every single target will start flooding the actual connection on the specified target. So hope you enjoyed this tutorial and this section. With this, we actually finished the actual threaded server. But before we actually close up this section, I want to show you one thing that we want to quit without saving, okay? That you might have missed, or not have missed, that I missed. So you need to add it right here. So go to your threaded, and you need to add the count variable to be equal to 0 right here. So count equals to 0. And the reason is because we only copy the shell function, and the count variable is used in our screenshot function right here in order to perform multiple screenshots. So we need to increase something right here. And in order to increase it, we need to have it specified in our code. Also, one more thing you need to add is down here in the outer while loop. If you specify a command that doesn't really exist, as you can see, we only have else if statements, and in the else statement we will just print else print exclamation mark command doesn't exist. Simple as that. So our program doesn't crash when you mistype target command or session command or something like that. It just prints command doesn't exist. So if you want to, you can add multiple other functions to this server if you'd like. Basically whatever comes to your mind you can add to it, and that would be about it for this threaded server. Hope you enjoyed it, and I hope I see you in the next section where we will continue coding. Bye! Hello everybody, and welcome to the next section in our Python ethical hacking course. Now in the previous section what we did is we managed to code our command and control center, which can actually take multiple connections and navigate through those sessions as we please. But right now what we will focus on is a little bit of network attacks and website attacks, such as stealing Wi-Fi passwords, such as, for example, brute forcing any website with a login page, such as brute forcing Gmail, basically discovering hidden directories, subdomains, spidering certain websites, and so on and so on. Since most of those actually belong to the website penetration testing section, we'll start off with a simple Wi-Fi password steal that you can upload to any actual Windows PC and get any passwords from that certain Windows PC for any Wi-Fi that they connected to. Now how we can do that is basically if you open up your command prompt, there is a certain actual command that you can run for discovering the actual Wi-Fi passwords saved on that specific target. So if you just type here netsh VLAN show profile, if you have a wireless adapter, what this will do is it will print out all the profiles or all the Wi-Fi hotspots that you connected to previously. As you can see, since this is my home PC, I really only have one of those. Now these two are not even real actual Wi-Fi hotspots. These are just some of the evil twin hotspots I created before. Doesn't even matter. The real one is this one, and this is my home wireless network. In order to actually get the key from that, or key or password or however you want to call it, from that specific Wi-Fi network, you need to type the command netsh VLAN show profile, then space, and you need to specify the network name of that specific actual wireless network. So this, in my case, you can specify any you want in your target machine or in your personal home machine, as I do right now. But if you don't have a wireless on your main PC, this will not work. Of course, this command will not actually get any output. you need to have a wireless adapter in order for this to work. So the next thing would be key equals clear. What this does is basically this command says that we want to get the password printed out in clear. And as you can see, let me just clear and run it once again so you can see it a little bit better. And as you can see here, the information for the wireless hotspot that I chose. This is its name. And if you go down here, you can find the security settings such as authentication, which is WPA to personal, cipher is TKIP, present is a security key, which basically means that we have a security key or a password, and the key content is the actual password itself, which is for my wireless, this one. So that is how you can find an actual wireless password if you have access to someone's computer. But let's see how we can automate this process with an actual Python program. So let us close this. What we will need for this actual program is two things. Well, first of all, I got the first one, which is the actual regex pattern for discovering only the key or getting only the key from this output of the entire command. And the next one, you will need an email address where you can send the output to. Now, you don't have to send it to an email, you can just write it to a file, save it on some PC, or you can even implement this in your actual backdoor that we coded. So for example, if someone in our backdoor as a user runs get wireless key, then you write a simple function that will give back the actual key in clear and send back to us. But for now, all we want to do is just code a simple program that will send it to an email. So right here we go to the Python programs. We can just make email in this non-specific directory. So Wi-Fi steel.py. We start off with our regular line, which is user bin Python. And there are three things we want to import. One of them is our normal subprocess library, which we will use in order to execute the actual commands in our command prompt terminal. The next one is smtplib. And we also need RE, which is basically regex, which allows us to specify a pattern for the output of the command, which will only strip out the password itself. So basically what we want is the actual name of the actual wireless and then the password for that wireless. So we can do that simply with using these three libraries. Now you don't need to import it like this. You can import it one beneath another, but it doesn't even matter. So what we want to do right now is actually specify the actual command. So you can just type here command equals, and then the same command that is specified in our command prompt. Now that command goes netsh vlan show profile. This is the actual beginning of the command that we want to send, and also the first command that we want to send. Now we will be sending this two times. First of all, or the first time, we will only send this part right here, which will give us an output of all the available wireless hotspots that were previously connected to with our wireless adapter. And then from that output of that command, what we will do is we will strip out all the actual networks and profiles and send it back to our actual email. So in order to do that, if you just check out right here, if you open up command prompt once again and type this command, you will see what the output is. So netsh vlan show profile. Oops, profile. netsh. For some reason, it won't find any VLAN profile. Let me just see if I specified everything correctly. Okay, so I'll just plug in and unplug my wireless adapter. And right now, if we just run it once again, oh, it says the following command was not found. Okay, so I actually mistyped something, or didn't mistype, I just forgot netsh vlan show profile. Okay, so here it is. Not really sure what the difference between this and this is, but okay, so I was missing an I, doesn't even matter. What we want to get is this part right here. So we want to get the actual name of the actual fields right here, so we can use it in a second command that we specify netsh vlan show profile and then the name and then key equals clear. So in order to be able to execute this command, we need to get the name of these networks. And for each of those names, we want to get the password. So we need to strip out the names, and we will do that with regex, but right after we actually get the networks with the output of this command. So what we will do, we will use subprocess library, so subprocess.check_output. We will run the command and shell equals true. And what this networks variable right here will have is it will have the output of this command, which is just all those profiles with the name of the actual wireless hotspots. And now we want to create an actual list which will contain all of those names. So network_lists equals basically you need to use the regex library right now. I believe we used it before in order to create some pattern for something before. I can't really remember what lecture that was, but we want to use a simple function find all, which will find everything in a specific variable, which we will separate by commas. So just type here networks is our variable, and it will find it by specifying this pattern between the single or double quotes. And this is the pattern that we need. So question mark, 2 dots, profile, then backslash, and then S star, and then basically 2 dots, backslash, pardon me, where is my backslash? Okay, so here it is, and then S, close the actual, the bracket, right bracket, and here I forgot to open the actual left bracket, so just like this. And then afterwards, we need to open bracket once again, type dot, then this star sign, and then close the bracket. Now, if you want to, you can actually just go, not really sure what the website is called, but you can go and just type Python regex, and there is a website that you can just simply paste the output of your command and experiment with the actual regex until you get the output that you desire. So you can do that, just let's type Python regex. Let's wait for this to actually load. And I believe it will be some of the first websites we will see in just a second. Regular explosion operation. Let's go with the first one. Import, okay, but this is just the actual. Let us go and find where we can actually test it. Wait, here it is, Python regular expression editor. So, okay, so a quick way to test your regular expressions. So, right here, right here, you will specify the output of the actual command. So let's actually find this on my Windows 10 machine, Python regex. We go and find it wherever it is. Well, let me just check out what the actual name of this website is. So pytex.org. So let's just go pytex. Hopefully it will find it. Here it is. And right here we can paste the output of this actual command. So let's copy it, Control C, paste it right here. And right now, if you just go right here, let me just close this, we don't need it. And you run this string right here. Let me just lower this so you can see everything. Okay, just like this. And in the regular expression, you type the specified string that we specified right here. Then we want to get the 2 dots, profile. Let me just switch this to English keyboard so I can actually get everything as before. Backslash S, then star sign, then the 2 dots, then backslash S once again, then closed parentheses, open parentheses once again, dot, and then star, and then close parentheses once again. And here you can see what the actual output or matches are, which are just the names of the actual profiles. And you can see that this will be our list containing these 3 elements right here, and we will send the output for those 3 elements, or for those 3 elements, to the actual email that we specify. So let us go back to our Python. We specify the regex pattern correctly, and all we have to do right now is iterate. So we will just type here output equals and then the empty string, and for the actual network, in a network list underscore list, so for each network or for each wireless hotspot in this list, what we want to do is first of all run the command to be equal to netsh, not capital N, so netsh plan show profile, then space, make sure to add space right here. So we want to concat this network right now, and then plus, and then open double quotes, space, key equals clear. And this is the command that we want to execute next. So we will just do the one network result will be equal to subprocess dot check underscore output. And let me just go open and close this. And we want to check the output of the command right here. Or if it is easier for you, let's call this command 2 and let's call this command 1. And here we want to check the output of the command 1. And here we're checking the output of the command 2, comma, and then the actual shell equals true as we usually specify right here. And then we want to concat that to the actual final output. So let's call this final output so you can understand everything better. Final underscore output plus equals 1 underscore network underscore result. Okay, and all we have to do right now is either you can choose to write this to a file if you want to save it on the target PC for some reason, or you can actually send this to an email. So in order to send it to an email, it is rather simple. There are just a few lines that we need to code. We need to create first of all server. So server will be smtplib.smtp. We will use Google Email Services, so smtp.gmail.com. Pardon me, Gmail, and then at the port, we want to select the port 587. We want to start the TLS encryption, so server.start TLS, open and close brackets, as this is an actual function from the SMTP library. And then you want to log into your email. So server.login. In the brackets, here you will specify the email, and here you will specify the password. So basically, once you specify the email and the password, which I will do later on, so I don't actually show the email and the actual password, then you want to send this email to yourself. So server.sendMail is the function, and then in these brackets right here, you need to specify the actual email, the email from who are you sending, the email to who are you sending, and also the message itself. So in our case, we are sending the final output, then we are sending from my own email to my own email. So I will just specify here my email to my underscore email, as well as here. Now this is not something that you need to type right here. These are variables that we can actually paste to this function, which I will do later on. And then basically the next thing, or the third thing, is the message itself, which is final underscore output in my case. Okay, so basically afterwards, all you have to do is quit this server and you will finish successfully this program. So let's save it. Or if you want to add it and test it right here, after you compile it, you can just set the my email variable to be equal to raw underscore input, and then you can just input the email itself. So enter email to send to, which is really no point to do that because this is something that you will run on target PC. You don't want to prompt the target anything, but for the test purposes, you can just leave this, and then this my email will be replaced in these functions right here, and then it will send the actual email. You also need the password, since we specified right here the password. So this would be a password to the email that you're sending to, so raw underscore input enter email to send to, and then you would save this, compile it, enter the email, and then you will receive the email. So I will test this in just a second. But first of all, I will delete these two lines as we don't need it. I will replace the my email and this my email, or all three my emails, with the actual real email, and the password with the actual real password, and then I will get to record once again in order to show you how it works. Okay, so right now all we have to do is actually compile this, but before we compile, we need to make sure that the actual smtplib library and re library are installed in Wine PyInstaller. Now, I'm not really sure if they are default libraries. Most likely they are, but let us just check just in case. So root.wine, Python or drive C, Python 27, python.exe, -m pip install smtplib. Let's see if we have this installed or do we need to install it. We will also check for the regex library, but I believe regex comes pre-installed for sure, but we will check it just in case so we don't compile it twice. And then we will compile the Wi-Fi still and run it on our Windows 10 machine. What we should get to on our email is the actual password for the wireless hotspot that I have right here at home. So smtplib is installed, re is probably installed as well, and then we can compile the actual program. Okay, so it is already satisfied. Let us compile the Wi-Fi still.py. So wine, root, wine, drive C, Python 27, scripts, then Python PyInstaller, pardon me, one file, no console, and Wi-Fi still.py. Let's let this compile while we plug in our USB drive. Okay, our USB drive is plugged in. Let's wait for this to finish. It has finished. Go to the disk directory, move Wi-Fi still.exe to media root Kali live. Then we can unplug our USB drive, go on our Windows 10 machine. We can paste it on our actual desktop and we can run this file. And for some reason, this has failed to execute. Let us see why. Oops. Well, the reason why this doesn't work is probably something because of my Windows 10. Let's try to run it once again. Okay, if we go right here, we didn't really receive anything. It's a little bit weird, but okay, it doesn't even matter. We can try to run it. I wonder what happens if we actually try to run it in the Kali Linux, even though we don't really have an actual netsh VLAN show profile return non-zero exit status. So that is good, because if you just type your netsh VLAN show profile, it will say command not found, because it is only on Windows, so that's why it doesn't work on Linux. But let me just check something out. Why it didn't work on our Windows machine is because of my adapter, probably, because it sometimes wants to connect and sometimes it doesn't want to connect, and this command right here probably couldn't retrieve the actual VLAN show profile, which will show the entire profiles of the actual wireless itself. So what we will try in the next video. Now I'm pretty sure that this will work on any other PC probably. If it doesn't, we will in the next video code the different version anyway, which will just save this to a file. Then you can, as I said before, implement this to an actual backdoor and read from that file and send the actual output to your server. So I hope I see you in the next video, and take care. Bye. Hello everybody, and welcome to the last tutorial of the Wi-Fi program. Now in the previous tutorial we saw that we actually get fail to execute error. Now that is something regarding my PC, I believe, since I don't have any other target to actually scan for. Make sure that if you get the same fail to execute error, make sure that you post somewhere, either in the question section or anywhere, that you get the same error so we can actually get and fix this. Now, I couldn't seem to find any error right here. I believe everything is good for now on. Now, I just want to show you before we continue to the next programs, I just want to show you how actually you can write this to a file instead of sending it over the email. So simply we just leave everything the same as before. We have our command 1, which is the netsh LAN show profile. Everything is the same. We check the output of that command. Then we find all the network names in that output. Then we iterate over those network names and we run the network LAN show profile, then plus the name of the network key equals clear, which will give us the password in clear text. Once we do that, we just add that to the final output, and right now all we want to do is actually open a file, so we can call it file equals open, then we can open and close brackets, call the file anything you want. In my case, I will just call it Wi-Fi passwords.txt, and we want to open it for the writing. So we open the file and all we have to do is file.write final underscore output, and we close the actual file at the end. And what this will do is, if you, for example, have a Wi-Fi steal.txt on this desktop directory, it will create an actual file right here, which will then store all the passwords from the target host machine wireless adapter. So it might be suspicious if you just compile this and send to someone. First of all, you will not be able to get the passwords back. So the best use of this program is to actually use it inside the backdoor that we created before. So that is something that you will have to figure out yourself. Of course, if you have some problems, make sure to post it and I will help you out with that. All you have to do is basically just import these commands, and when, for example, the server sends a command get passwords, then you perform all of this, you save to a file, then you read from that file, then you send all of the data that you read from it, and then you delete the file so it doesn't leave any trace behind. So simple as that. Once again, if you have any problems, feel free to ask, and let us continue into the next lecture where we will code our next program. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, and right now we're going to code a brute forcer for the email, or Gmail should I say. What we will do is we'll code a simple program which will import only one library, which in our case it will be the SMTP library, and we will try to specify the email and the password to brute force, or pardon me, the password list. Now you can also use the email list if you want to, but right now all we will do is just brute force over the password. So it will be rather simple. It is a different brute forcer than, for example, brute forcing any login page online. It is a little bit different. That's why we will code it first. And then in the next tutorials, we will continue over the brute forcers for some typical, for example, Metasploit login pages, some online login pages of different websites, and so on and so on. I will show you in the next tutorials how you can actually adapt your brute forcer to any login page you want. But for now on, let us start with the Gmail brute forcer. So let's first of all make directory brute forcers. Go to that directory and nano gmail.py. Oops, gmail.py. We add the user share, or pardon me, user bin Python at the beginning of our code, and let's import smtp lib. Now, first of all, if you want to, we can even use this to be an actual Python 3. So let's import from colored, or from term color, import colored. Now let me just see if I go and run my Python 3 from term color, import colored works, and import smtp lib also works. So we should be good to go. Let us nano back our gmail.py and let us continue coding. First of all, what we will do is we'll create a simple SMTP server. So let's just call it SMTP server. Simple as that. We will do the same thing that we basically did for our actual Wi-Fi stealer, which was basically just give it the Gmail servers and the port of 587, so smtp lib smtp is the method we want to use, and there between the double quotes specify smtp.gmail.com, and after it you need to specify comma and over port 587. Once you do that, we want to just type here smtp server.ehlo, which is a method from the SMTP server library, and we want to start the SMTP server encryption over TLS. So SMTP server.start TLS, also open and close bracket, and this is our setting up of our SMTP server. What we will use instead of these functions is also the login function, and we will try and accept with a rule that will give us back the SMTP authentication error, from which we can actually find out whether we logged in successfully or we didn't. But before we do that, let us actually specify the password list and the actual username list, or username as an email. So we will have a variable called user, which we will use input for the actual user of this program to input the actual email. And we're using input and not raw_input because we are using Python 3 at the moment. Then in between the brackets we can specify something like this, or with a star. The plus sign will be once we actually find the password. So enter target's email address. Then we close the double quotes, we close the bracket. Oops, we already have the brackets closed. And now we want to actually specify the path to a file. So passwd file equals input. We will prompt the user to actually paste the input path to that password file. So enter the path to the password file. There we will specify the path or just the name of the file itself in case it is in the same directory, and all we want to do is open that file for reading. So passwd file equals open underscore file, or we can actually just, maybe you will confuse it if we name it the same. What we will do is we will do something like this. So we'll just name it file equals passwd file. Then we open it up for reading, of course. Close the double quotes, close the brackets, and now we want to type here for each password. So, oops, in this file, so in file, what we want to do is we will try to perform the SMTP server.login function. It is an inbuilt function in the SMTP library, so all we have to do is just use it, and we will use it in the try and except rule. So try, what we will try is SMTP server, SMTP server, and then dot login, and in here we will specify the user and the actual password. Now make sure that if you have a password list, you need to perform the password equals password dot strip, and what we want to do is we want to strip this from the new line character, which will be \n, and then we enter the triangle of login. In case this does work, we will just print colored, and here plus, so plus password found, and then %s, since we are going to parse a string to this from the password, and then comma, and we need to specify the color, which will be green in this case. We close one bracket, we close second bracket, and then we actually break out of this loop. The next thing we want to do is in the except rule, we want to use except smtp lib dot smtp authentication, error, then 2 dots. In case we get this error, all we want to do is just print wrong password, since we didn't manage to actually connect to the target. So just print right here, colored, with the minus in square brackets, wrong password, and then we can add the password just like this. So comma once again, and then red, so we want to print this in red, and close two brackets. Now let us see if we save this, how does this work? So Python 3 gmail.py. SMTP-lib has no attribute SMPT, of course, because we actually mistyped the actual error. So SMTP, or where was the actual error? Let me just check it out. Okay. SMTP. Where did we use the SMPT? TP-lib, SMTP. I can't seem to find where we actually used it. Okay, so here it is. SMPT, it should be SMTP. First goes T, then P. Let's save this. Run it once again. Enter target's email address. Oops, before we actually run this, we forgot to actually create the password list. So let us nano password or pass list, let's call it like that, .txt. Here we will have hello world, password 1234, password 535432, doesn't even matter, 12345678. Then we can have, for example, the real password, which is test 1234 and then exclamation mark, which is the actual fake password that I put for this email for the actual demonstration purposes. Then afterwards we can add another more. So for example, volcano, football, and doesn't even matter, so on and so on. Now of course you would use a real password list and not this one. And right now let us run this. Enter target's email address, which is Windows 32, then the W, and then this @gmail.com. Enter the path to the password file. Now right here you would specify a full path to the password file if it is not in the same directory. Since it is for us, we just specify the name of the file, so passlist.txt. We can see wrong password, and it finds out the password and it prints it out. It says password found, test 1234, exclamation mark, in actual green. So our Gmail brute forcer works really well. We can brute force passwords to the email accounts with this, even though you shouldn't do it without any permission. I need to repeat it once again. And what we will do in the next videos, we will code some of the brute forcers for the actual login pages online. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And what we did in the previous tutorial is we saw an example of a program that can brute force a Gmail. Right now what we want to do is create a simple program that will be able to brute force any website we want. What we will do is we will code a program that will take the actual data that we will deliver to the page itself in a dictionary. Now that data will be something that you will need to change through every website that you try to brute force, but those are only just one-line changes, so nothing really to worry about. We will do the same approach as before, so if we see a string that will actually indicate that we failed to log into our page, we will pass to the next password, and if we don't get that string, what we will do is we will print the username and password, and we will print found username and found password. Now, in order to test this, since you can't really brute force with a lot of passwords real websites, we need our own website or our own login page that we can test this on. So what you want to do is start up your Metasploitable. So here is mine. I will just start it up right here. And what Metasploitable has is it comes with the damn vulnerable web application where it actually asks you to log in before you can use it. What we will try to do is we will try to simply just brute force that login application. Since we already know the real credentials for that, and since that is not a real website, we can actually test our brute forcer on that. So open up your Metasploitable, open up your terminal, let us navigate through our directory. Let me just enlarge this one time. So here it is. Cd Python programs, and we want to go to the brute forces currently. So we have our gmail.py, we have our passlist.txt. Right now what we want to do is nano brute forcer, however you want to call it, .py. Okay, so right here, let us type hash and exclamation mark and then user/bin/python, and we'll just stop right here in order to log into our Metasploitable right here. So msfadmin, and msfadmin is the username and password as before. And what you want to do is, first of all, check the actual IP address of your Metasploitable and navigate to that IP address on your Firefox or Google Chrome. So right here I have Metasploitable 192.168.1.5, and you should see this page once you open it up. You will have these 5 links, and the link that you want to click on is the DVWA. It will lead you to this page, as you can see, username and password, and there we have the default hint, or basically we have a hint down here which says default username is admin with password. Now of course let's pretend that we don't really see this. Now let us try to log in with some random credentials. So 123, 123, 123, 123. And we can see that we didn't manage to log in with our fake credentials, but we did get a string which says login failed. So this is a key string that we will search in our HTTP response from the Metasploitable in order to check out whether we managed to guess the username and the password. So let us go right here. We started our actual program, but before we actually continue with it, let us create a simple actual password list which we will use, which needs to have our own list, right? Which needs to have our own password. As you can see, the correct password for this website is the password, and the username is admin. So let us nano password list.py. Hello 1234 password, or let's not put password that soon. Let us use admin root or password 123 password, and then we will use this password right here, which is the correct password. Now of course, once again, if you don't want to use this password list right here, you can just navigate to, I believe it is home, or let me just locate word lists. Locate word lists. Let me see where the actual, okay, so the directory to the word lists is user share. So cd user share word lists. If you just type here ls, you will have multiple word lists. Most of them are for different programs such as dnsmap.txt, deerbuster, deerb, metasploit. In the metasploit directory, you can of course find some of the useful Metasploit framework password lists for different types of the attacks. And the most known actual password list will be this rockyou.txt password list. It contains around 14 million passwords, and it is mostly used to hack websites like this. Now this is of course once again not a real website, so it really doesn't matter which password list we use, but in a real life attack you would want to use a password list similar to this, since this password list was created from gathering passwords from hacked accounts. So let us go back to our root Python programs, brute forcers, and first of all, let me just nano my password.py, okay. Wait, why did I call it password.py? It should be .txt, so txt, yes, save under different name. And what is the name of our program? Okay, so it is brute forcer. Let us start up our program one more time. And right now, we need to import 2 libraries in order to perform this. Now, first library would be the requests library, which we will need in order to actually send and receive the actual HTTP response and HTTP request. Now, before we do this, let us actually imagine and see what we need to do in order to be able to code this. So let's navigate to the page that we want to brute force, and this step is the same for actual every page that you encounter, whether it is a page on Metasploit framework, or pardon me, on Metasploitable, or any real-life page that has this similar login, username, and password. So let us refresh so we get the real page right here. And all you want to do in order to actually be able to understand what we're going to do is go to the open page source, it will open up the HTML code right here. And what we are searching for is the form. Now the form is something that we fill in right here, such as the username and password. And in the form, there should be 3 variables, at least. One of them will be username, one of them will be password, and the third one will be this button that we have to click in order to actually log in to that page. Now we will have to click this button through our code, and we will also have to specify this button right here in order to be able to perform the entire action. Since if we only fill these 2 fields and we don't do anything with this button, nothing will work. So in order to do that, it is most likely going to be in the body. So just go on these arrows and press them down. You can see right here, form action login.php method post. Now, since this is the only post method right here, we can for sure say that it is actually correspondent to this actual username and password. So click arrow on this right here and on the field sets. There, you should have some similar field sets as to the name of the actual fields in the web page itself. As you can see, label for username, it even selects it right here. So we are going through this part right here. And what we are interested in is the name of the username. So we can see the type is text, the class login input, size 20, but the name is something that we are interested in and something that we are going to specify in our code. Same with the password. As you can see right here, we have the password field. The label for the pass is password, and we are interested once again in the name. So we can see the name is actually password. Now in the actual button, in order to find it, here it is, p-class submit. Now we are interested in the class and in the name itself. We can see that the button is, once we click it, its name is login. And it also specifies right here that the name of the button is login, the type is submit, and the value is also login. So those are all the things that we will have to specify in our code in order to be able to actually log into this page. So let us do that right now. Import requests. The next thing we want to do is specify the URL that we are actually going to brute force. So the URL would be the actual URL of this page right here. So you can copy it if you are running this from the actual Kali Linux Firefox, or you can just type it like me. I will just lower this and type the URL. We will store it in, for example, a variable called page_URL equals, and then between the double quotes, we need to specify the full URL. So in order to specify the full URL, you need to specify first HTTP. Since this is an HTTP page, as we can see, it is not safe. It is not HTTPS. We need to press the 2 dots, // and then the IP address, which in my case is 192.168.1.5. Now, if this was a real page, you would not specify the IP address, you would specify the actual name of the page itself. Then afterwards, we need to type / right here and navigate to the DVWA directory and then / once again. And the file that we want to actually interact with is login.php. The next thing you want to do is prompt the user of this program for the actual username, and then we will iterate over passwords in order to be able to guess it. So username equals raw_input, and let us prompt the user. First of all, let me enlarge this, and let us prompt the user for the actual username. So enter username for specified page. And right here, we can close the double quotes, close the actual bracket. And what we will do is in the next video, or not in the next video, right now, what we are going to do is open the file for reading. And in the next video, we are going to code a function that will actually crack the password itself. So for now on, we only specify the URL and the username. Right now, what we want to do is we want to open this file that we made. So password list.txt, I believe. Let us remove the password list.py. We don't need it. That was a mistake. And let us navigate to our program and open it. So with open password list.txt, and then we want to open it for reading, of course. We want to open it as password, since this is our list of the passwords, we want to actually crack for each password. We want to try it with our username. So brute forcing, we can call our function like that, or just brute force, and we will parse two arguments to this function, which one of them will be username and the other one will be URL. So these are two things that we are passing, pardon me, page underscore URL. So make sure to specify the same name. And then we want to actually print, if this doesn't work, print, or we will actually print that in the next video. For now on, let us just leave it like this. And we are going to code this function in the next video. Now, don't worry, it is not that long, so we will be able to finish it pretty soon. Hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our brute forcer. And in the previous video, all we did was specify the page URL, which needs to be correct in order for this to work, and we also prompted the user for the actual username. We also implemented a brute force function, or we didn't implement it, we only called it, and right now we want to implement that function for our program. So let us go up here, we can implement it right here, def brute force, the actual things that we parse is the username and the URL. So make sure to add the two dots. And what we want to do right now is only iterate over these passwords in our list. So for password, in the passwords file that we opened, so for password in passwords, first of all, if you notice right here, we want to strip the password of anything that might present us a problem. So right here, for example, this new line, then /r, and anything basically that could present the problem. So we'll just use the function strip on our passwords. In order to do that, basically we did it a bunch of times, so nothing really there to explain. We will just redo the password variable to be equal to password.strip. So next thing we want to do is we can just print right here the passwords that we are currently trying. So right now we can just print right here, trying to brute force with password, and then we want to add the password itself. So we will just add space and then plus, and we will concat the string of the password itself. Now the next thing is the most important thing for this program is to actually create a dictionary. So we can just call it data underscore dictionary. So you can call it anything you want. And dictionary is basically referred to with these curly brackets right here. So it is not the same for the list, or it is not the same for the normal brackets. This is how we can create a dictionary. Now what dictionary will take is the key and the value, and I will just show you once again, as we saw in the previous video, we are interested in these usernames and passwords, or basically name fields, for our input fields on the page itself. We are also interested in the name for the actual submit button, which is this login button right here. So we need to parse all of that to our actual brute forcer, or our actual dictionary. So let us do that right here. I'll just lower it so we can see both of these screens. We can see the HTML code, and we can also see the Kali Linux. So right here, first of all, let us parse the actual usernames, since that is what comes first. We know that the name field of the username field is just same username, so just specify right here username. And in order to divide the key and the value, you need to specify two dots right here and parse the actual next value. So username is the actual field with the name username. Simple as that. Now, let me just explain what this actually does right here. It will search for the field under the name username, which is this field right here, and it will paste to that field this variable username that we created at the beginning of our program right here. We also parsed it to our function, so it will just switch it right here. The same we need to do for the password as well. As we can see, the name for the password field is just password, so make sure to first of all separate by comma, then in between double quotes, once again password, and then two dots, and the actual variable that we are parsing, which is the password variable. And the last thing we need to specify is the actual button itself. Now, the actual thing that we are interested in is the class and the name of the button itself. The name is the first thing that we specify right here, which is login, under the double quotes, then 2 dots. And we can see that the button is type submit and class submit. So we want to specify also between the double quotes submit. Since this is not an actual variable that we specified in our program, we need to parse both of these values in the actual double quotes. So once you do that, basically most of our job is already done. All we need to do is forward this dictionary to the actual page itself. In order to do that, we need to perform a post request, which the requests library will help us do. So go next line. And what we want to do is create a response. And the response will equal this response variable. We catch the actual requests.post. And this post actual function right here will, for our case, take 2 inputs or 2 arguments to this function. One of them will be the URL where we are posting, which in our case is the just URL or the page URL, however you want to call it, right here. So to this URL, we want to paste data, and the data is equal to our dictionary. So data underscore dictionary. Now, it is simple to understand. Basically, we are trying to connect to this page and parsing this data where it needs to parse it. It is simple as that. The Python basically does most of the things for us. All we have to do is specify these 2 lines, and these 2 lines are something that will change for every page you actually brute force. Or not really these 2, actually only this line is something that you want to change if you want to brute force a different page. Everything else can be the same. Of course, you need to also change the link itself, but that is common sense. So what we want to do right now is check for the actual response once the username and password is incorrect. So you can see once we tried in the previous video, we get this login failed string printed to the screen. Now we will use that string in order to be able to actually realize once we got the password right and once we got the password wrong. So in order to do that, we can just type here if, and then the string of login failed. Now make sure to specify the same letters, otherwise this will not work. So it has to be the same. The best thing to do is to copy and paste it. And then if login failed is in the response variable .content, now this actual response variable will take an actual element of the content and it will check whether this string right here is in this content of our response. We sent a post request and we are checking back the response. If it is there, all we want to do is pass to the next password. If it isn't there, that means that we actually got the password correct and that we managed to log in. So we want to proceed to print right here with a plus username, and we can do something like this plus the actual username variable that is currently in this part of iteration. And we also want to do with the password itself, password plus password variable. And we can just exit the program. Once we get the username and the password, there is no really need to continue brute forcing. So let us try out our program. Hopefully it will work right now. And if we chmod it in order to be able to run it, and we run our brute forcer, enter username for specified page. Now we can actually try with a wrong username first of all, since let us specify root to be, and we can see right here trying to brute force with password hello, trying to brute force with this, nothing really worked since we used the wrong username. But let us use a real username, which will be the username admin, and we can see once it reaches the password in our list, it prints out username admin, password admin, and it also quits the program. Now let me just check why do we get one last time trying to brute force with passwords. So let us fix that. Nano brute forcer.py. Okay, I think I know what the problem is. In our password list.txt, we actually have an empty line, I believe. So let us try it once again with a wrong password. Now this is not really something important. It is rather just for it to look better. As we can see, we managed to get rid of it. And also what we want to add to our brute forcer is, in case it doesn't really find the actual password in this list, we just want to print at the end of this program. Let us open square brackets, 2 exclamation marks. Password is not in this list. And we can just print that. Let us see how that will work. Root. And we can see everything works perfectly. Once we specify the actual list and the wrong username, we don't get the password. And once we specify the actual real username, we get password as the correct password for that website. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we are going to code a program that will be able to discover some directories on the target web page. So for example, once again, we are going to test this on our Metasploitable. We will need a file which is going to contain some directories that are possible to be found on some web page. So we can use any file in our actual Kali Linux. Since this is actually just a test, we don't really need a real file. So let us see in word lists whether there is anything similar to that. So if we go to dir buster or dir, but let me just check right here, cat common.txt, and we can use some of these actual lists in order to be able to discover some additional directories on our target PC. So first of all, what I want to do is copy this common.txt. So copy it to our root/python programs /brute forcer. Even though this is not really a brute forcer, we will just put it in that directory. Doesn't even matter. We are basically brute forcing directories. It is something similar. So let us go to that directory. Go to brute forcers. And let us nano our directories.py. This program, as I said, will go discover additional directories on target PC, or pardon me, not on target PC, on target website. And how we'll do that? Well, first of all, we will open the file with our common.txt file with our directories, possible directories. Then we will add a slash to our link to the web page, and then we will add those additional directories after the slash itself. Then we will perform a GET request, and we will see whether we get an error while performing GET request, or if we don't. If we do get an error, that means that web page doesn't really exist. And if we don't get an error, that means that web page exists. So let us start off with the user bin Python, our usual line, and of course we will need to import requests library. So right now, first of all, the most common thing to do right now is first to actually prompt the users for the target URL. So we can just use something like this, target_URL equals raw_input. And in between the double quotes, we will specify, let's do something like this, enter target URL. So we can do something like that. And afterwards, we need to open our file containing the directories. So file equals, let's just call it file equals open. And let me just, I believe it was common.txt. If it is not, we will just check it out later on and we'll switch it if it isn't that name. We want to open it for the actual reading, but not in that double quotes. We want to open different double quotes and then read. And right now, we want to go for each line in this list. As usual, we want to perform the GET request. So for line in this word list, we call it file, doesn't even matter. So for line in file, which is our common.txt, we first of all want to add the word. So word will equal line.strip. Now you could have also just left here line equals line.strip, but it doesn't really matter. Let us just use word. since it is more prettier than actual line. And all we want to do is add to our URL this word. And how we can do that is we can do something like this. Full underscore URL will be equal to the target URL, which is the URL that our user of this actual program will specify. We need to add the string of the slash, since if you go to any web page right here, you will see that the different directories have slashes. So we also want to add one in order to specify the directory, and we need to add the actual word right after it. Then what we will do is we will actually create a response. So response variable will equal, and we will make an actual function, which will be a request function to the specified URL, so to the target underscore URL. Or pardon me, we specify the full URL, so we are no longer parsing the actual target URL. We need to specify the full URL right now. And this function is something that we will code in the next video. So hope you enjoyed this short tutorial, and we will continue with this directories.py in the next tutorial. Bye. Hello everybody, and welcome back to this tutorial, and let us finish up our directories.py program. So what we did for now on is we asked the target to specify, or the user to specify the URL. We opened our command.txt file containing additional directories, and for now on we only performed the creation of the full URL to test on. Right now we need to code this test function, or request function, pardon me. So we can just put it right here. Request, it will take an input of the URL, and what this request function will do is it will basically try to connect to that specific URL. So it will try to actually requests.get, so we will perform a get request onto this URL specified in the actual function itself. But before we parse the URL, we need to also add the HTTP. So I will just show you right here. Just specify it like this. HTTP, // and then close double quotes, and then plus the URL. Now the reason behind this is basically, for example, if user just copies this part right here, which doesn't contain HTTP, it will not be able to actually connect to that web server. So what we need to do is either the user of this program needs to specify in the raw input function the full URL with the HTTP // and //, and or if they specify just this link right here, we need to add the HTTP ourselves to that code. So we will try this, and we will accept if we get the error, so requests, and we will use the connection error. So if connection error appears, that means we weren't able to connect, which means that directory doesn't exist on the specified target. So exceptions dot connection error. And we will just pass in that case. We don't want to do anything else. And from this function, we actually want to return this, because we actually specified that the variable right here equals to this function from the specified URL. So we want to return the result or the response to the actual response function. And if this response function has something, so if response, then we want to print discover directory with the actual word that we specified right here. Now, why are we typing right here if response? Well, basically, if this doesn't work, this part right here, it will go to the accept and it will pass, which means nothing will be returned from this function to the actual response. So response will be actually containing nothing. So if response has something, then we print this. That's why we specify it like this. So print plus right here, and then discovered directory at this link, and then we can close the double quotes and plus the actual full underscore URL, which will be the URL containing the specified URL and also the added word. So right now let us test out this program. This is basically the entire program. So save this, close it right here. Let us chmod it. So chmod directories.py, and we want to run the directories.py. enter target URL. So since we have specified in the program to already have the HTTP, right now all we want to add is 192.168.1.5 and then slash, and let's see what we can use. We can use basically, for example, this part right here, which is mutilde. I believe that is how you pronounce it, not really sure. So mutilde, is that how you even actually type it? Let us check out. Okay, so we are missing a Y, not a Y, an I. So let us go right here. And that should be the URL. So let us press enter right here. Discover directory, this link. So we are discovering some additional directories. You can see classes, credits, documentation, footer, header, images, includes, installation, and a bunch of others as well. So these are all the directories that actually exist. If we want to try out, we can just simply use these images. And let us go right here and just type images and let's see where it leads us. And you can see it leads us on a specific directory containing different images on the Metasploit framework or on the Metasploitable machine. So we can also check something out right here. We can see the robots.txt, so we can just go right there and check if that one exists. Robots.txt, press enter, and you can see right here that the robots.txt file exists on our Metasploitable. So our program works well. We managed to code it to discover different directories. So let us just try on a different target before we actually quit. So let us go to, for example, let's not go right here. We can go to dvwa. So let us try with that one, directories.py, 192.168.1.5, dvwa. Press here enter, and we can see we already discovered one directory and two more. So it works for that directory as well. Any website you actually specify right here will find other directories that might actually be interesting to you, such as, for example, these passwords right here. So we will check that out in just a second. We can see there is a passwords directory on our Metasploitable. And we can go right here in order to check it out. It is in the previous scan, so let us go right here and add passwords. Accounts.txt file is something that we found, and you can see we actually managed to find something interesting on our Metasploitable. You have some Adrian, some password, and some different strings right here. Some different accounts also containing different usernames and different passwords. So that would be about it for our directories.py. Hope you enjoyed it, and I hope I see you in the next tutorial where we will continue coding. Bye! Hello everybody, and welcome back to this section. And in the previous video, we saw how we can actually create a program and use it in order to discover some hidden directories that we might find interesting. We saw on our Metasploitable a directory called passwords.txt, where we actually managed to find some of the passwords. Now, of course, that directory is purposely made in order for you to test programs like this and find it. On the real websites, it is not likely that you will encounter something so significant to the attacker as a password list, but you never know. Also, you might find some valuable information, such as some versions of software running there, some additional files, some Tomcat files, PHP files, and basically anything that could be useful for your future attacks. Now, since we saw how we can actually create a directory brute forcer or directory finder, however you want to call it, let us see what we need to do in order to be able to do the same with the subdomains. Now let us nano our brute forcer, or let us copy our directories.py into subdomains.py. Now right here we should have both of these programs which will be the same, so let us right now, let me just close this. Oops. Let me nano subdomains.py. And right here we have our program which we coded in the previous video, which is basically the same as the actual directories.py. So what we have to do right now is change just a few things in order to get this to be a simple subdomains finder. So actually there is only one thing that we need to change, I believe. It is this part right here. So you can see that when we search for a directory, we search for something like this. So we find a website, let's say it is google.com. Then we add a slash, and then we brute force any directory, admin, password, and so on. But right now, what we're going to do is we're going to use google.com, for example, and we're searching for a subdomain, which can be, for example, a country. So, for example, us.google.com or something like that. So what a subdomain is this prefix to the actual website right here. It helps us discover some different pages on the website that we maybe weren't able to discover without this. So let us see what we need to do in order to change that. We will not change the request function right here, as it is returning the URL that we parse to that function, so nothing really here we should actually change. We accept the connection error, which means that we cannot connect to the specified subdomain, which is good. We've prompted the target for the actual URL, which is also something that we won't change. The file to open, and this is something that you can change if you want to. I will just leave it on the common.txt. Or you can actually do something like this. So file underscore name, and you can just do something like this right here. So file underscore name equals raw underscore input, and you can prompt the actual user for the file that they want to use to brute force. So enter file to use, and just close the brackets right here. And then we parse the actual file into this function right here. So let me just go down here and let me see what else we need to change. Now this is something that you don't really need to import if you don't want to, but just in case, let us make this program mostly user friendly so we can continue with the other stuff now. We will not change anything right here. The full URL is the most important thing we have to change. So first of all, the target URL should go after the actual subdomain. So we will just add everything we need before the target URL. So what we're going to do is we're going to type here word, which is our line, just stripped from everything that might actually present a problem. So for example, if we had a line which is passwords in our actual file, and it had a new line character, we would get something like this, which really doesn't exist. Whoops, google.com. What we want to do is we want to actually navigate this to the same line. So that's why we strip everything from the unnecessary things. So right here, we use a word plus, then we will add a string, and in between these double quotes, we will just specify a dot, which will actually represent the subdomain itself. Then to this dot, we will add our target URL, and we will perform the actual response or the request function and returning the actual response to the response variable. We check whether that response is none or if it is actually received. If it is received, we will print not discovered directory, we will print subdomain or discovered subdomain at this link, and then we will print the full URL. So let us see how this will work. First of all, let me just run our Metasploitable. So we can actually use it in order to test this on something. Now this is something that you can actually test on the other websites as well. It's nothing really dangerous to do. You are just discovering different subdomains for that specified website. It's not like you're brute forcing a username and password. This is something that can help you actually enumerate and find out more different pages for that specific website. Now, of course, if you are running a brute force attack on the username and login credentials, you are not allowed to use this on any other website unless it's actually in basically normal terms, such as, for example, sending 3 or 4 passwords just to check whether your program exists, whether your program works well. If you run this with a password list of 10,000 passwords, then that is something that you can consider illegal, so you shouldn't really do that. Let us see whether our Metasploitable opened. Okay, I have config. The IP address 192.168.1.5. Let me just find my actual arrow from the mouse. Okay, so had a little bit of problem finding my mouse there. Let me just do this once again. and tab this down. Okay, so let us try to run our program, subdomains.py, enter target URL, 192. Yeah, we actually need to specify only the IP address, since you remember we actually added the HTTP in the code itself, so 192.168.1.5. And then the file to use will be the same command.txt, doesn't really matter. This is only just for us to actually test the program itself. Now, if it discovers any subdomain, that is good. If it doesn't discover, doesn't really matter. What matters is that our program works. We don't get any error. We actually try to perform the request on these certain pages. It's just that currently we cannot really seem to find any on the actual 192.168.1.5, which is our Metasploitable. It could be also that we are using a wrong password list or not password the subdomains list. Now, what you want to do when you're running these types of attacks or enumeration attacks, if however you want to call it, you want to find the actual directory. You want to find an actual list that contains something that could possibly be a subdomain or a directory. There is not really a point in running this attack with a password list such as the rocky.txt, which is mainly focused on the actual account passwords. You want to actually have a real password list for these types of attacks. So for example, there is a subdomain news, org, something like that. You want to have all of those in your list once you run this. So let me just check out. This is not really finding anything, so let us just quit it right now. Okay. Let me get the passlist.txt. Yeah, okay, this is nothing really interesting for us. Let's go to user share word lists. Perhaps we can actually find something right here that could be rather useful to us. Let me go to Dirbuster. Okay, nothing really here for us, I believe. Yeah, nothing here for us. cd to dirb ls. Let us see right here whether we have something interesting. Extensions command.txt. Let me see what that is. Okay, so these are just extensions for some of the files, nothing really interesting as well. Let's cd to others. cd to ones. We're basically just trying to find something that could be a good actual list for this type of attack. So let us just locate subdomain and let's see if we find anything. Link some subdomains.txt. Okay, so something in Metasploit framework. So user share Metasploit framework data word lists, and here we should have some subdomain word list. Let me just find where it is. We saw it in the locate function, so let's just grab ls and then grab subdomain. And here is our list. So let us cat the actual list just to see what it has. Well, okay. Oh, it's a link subdomains.txt and nothing really useful for us there as well. So subdomain. Let me see whether there is something else instead of this actual list that we have right here. Yeah, okay, so there really isn't. Maybe even there is, it's just not called like this. It doesn't even matter. Basically, you can use any password list you want, whether it is made for the subdomains or not. For now on, we will just skip to the next tutorial. There's no really point in actually continuing to find a password list. What matters is that our program works and you can use it for your own needs. So hope you enjoyed this tutorial and I hope I see you in the next one. Bye. Hello everybody and welcome back to this section, and right now what we're going to do is I'm going to show you how you can use requests library in order to change some of your headers in your actual HTTP request. So for example, we know that when we send the HTTP request, we actually send a few different things such as the actual IP address, the user agent, the encoding, the data, everything you send within that request. And some of those things or different fields that you're sending with the HTTP request also send your information, such as, for example, the user agent. Now, the user agent sends the information about you, your browser, your PC, basically, and it sends it back to the server, and then the server can actually see from where, or not from where, or basically from what you are sending your request. So, for example, let me just show you. If we open up our Burp Suite, I'm not really sure if we can see it there, but we can definitely try to do something like that to actually intercept our request and see what are the things that we actually send to the server once we perform an HTTP request. So right here, okay, I accept, doesn't even matter. Burp Suite is basically an actual program that comes in the Kali Linux, and with which you can actually intercept the HTTP requests and HTTP replies. Now, the Burp Suite actually has to have a certificate in your Firefox, so make sure to do that before actually trying to intercept the requests with this tool. There are a bunch of other tutorials on YouTube on how to do that, so that's not really something that we will cover. All you want to do after you configure it with your Firefox is turn the intercept off in order so you can actually load the pages themselves. Because if your intercept is on in this tool, that means it will just skip, or not skip, it will just pause at every packet you try to send and receive, and it will not load the page until you forward that packet manually. So right here, let us go, for example, to our 192.168.1.5, which is our Metasploitable. Let me just go right here before we actually do any of that, since in preferences, I need to set our Burp Suite. Okay, never mind. In this tool, it is not set. We will just not use Burp Suite at this moment. So what we want to do right now is actually open up our Python interpreter. There really isn't a point to use a program at the moment. And first of all, we want to import the requests library, which will allow us to send the actual requests themselves, just as in the previous videos. And the first thing you want to do is actually navigate to this website right here. Let me just go right here, open up my Firefox, and there is a website called httpbin.org/headers. Not really sure if it still exists, but we can try to do it. So, httpbin.org/headers. And this website, what this website will basically do is it will show you how your request looks like. So you can see right here, you can either check the headers themselves like this, the request and the response header, the raw data, and you can also check it in the JSON format if you like. Now, you can see the requests header has some different fields, as I said, such as encoding, host, user agent, and this user agent field basically sends the information about us. As you can see, Mozilla Firefox, Linux x86, this is all information about our Kali Linux machine that is going to the server with our request headers. If you want to, for example, change just this field and send to the server as if you're connecting from some different device or something, anything you basically want to specify, you can do that with the Python library. So let us go right here. First of all, close this, import requests. And what you want to do is use a variable, or not a variable, in this case it will be a dictionary, because we want to specify dictionary the same as in our brute forcer. We want to call the dictionary my headers. So this will be our header fields, which will contain the key and the value of different fields. So first of all, we will specify the field between the quotes. So the field name is user-agent. So that is the field name that we actually want to change. And the reason why we're changing this is because this is the only actual field that sends our information. Now, in order to specify or to separate the key from the value, we just type here 2 dots. And then again, between the quotes, we specify the actual value we want to add to this field right here. So the value that we want to add will be basically anything you want. So for example, let's pretend that we are iPhone 6. So just type here iPhone 6, press enter, and we created a dictionary that has a value of iPhone 6 in the field user agent. All we have to do right now is actually create a response. So we can call it R equals requests.get. And then between the request.get, first of all, we need to specify what web page we want to actually get the response from. So we can just specify the HTTP and the 2 dots and then 2 slashes, and then http bin.org/headers. So if you just press here enter, this is just going to actually get the page itself, and you can see right now if we just print, for example, r.url, it will print you the URL that we try to actually search. If you print r.txt or text, it will actually send the output of that page itself. So you can see right now that currently our actual header or request headers look like this. So we have the accept coding, host, and the user agent is set right now to be Python requests with this version, which means that the server will know that we actually perform these requests with Python program. Now, for example, you want to change that. You do not want to do that with the actual Python program. You want to make sure that the server doesn't know how we perform this request. So you can do that with R2 equals, this is our second request that we are actually going to send. So R2 equals requests.get. In between the actual single quotes, we can specify the same link. So HTTP, then 2 dots / http bin.org/headers. And afterwards, we're also in the brackets now separate it with the comma and specify the headers that you want to send. So headers equal my headers, which is a dictionary that we created at the beginning of our program. Press here enter. This will take time to actually send the request and get the response back. And if you print the r2.url, it will print the same URL as before. But right now, if you print r2.text, you can see that currently our headers are different. We actually have the user agent field specified as iPhone 6. This is our request that we performed, and now this server will actually receive this data right here, and there would be no other way for them to actually find out how we send this. Now, of course, user agent iPhone 6 is never specified like this. They would know that someone has actually changed this, because this is not something that you really see, especially if you can do something like this. So let us find my headers. You can just type here iPhone 12 and basically perform the actual same request right here. And if I print r2.text, they would think that the actual request came from the iPhone 12, which didn't even come out yet. Now, maybe in future, if you watch this, there is an iPhone 12, but currently there really isn't. So this is something that you can actually change to anything you want. For example, let's set my headers variable. Let's also set a different field. So the field can be something like this. Let us see whether this will work. So comma, then we specify host, 2 dots, and for example, google.com. Let's see whether this right now will work. If we try to search for the same website, print r2.text, and you can see that right now it appears as if the host is google.com, even though we search for this website right here. Which can be a little bit strange, but that is something that Python library or Python request library allows us to do. Now, you don't need to use this website. Just this website is useful to practice this because it actually shows you your requests. If you, for example, wanted to load the actual Metasploitable website or Metasploitable web page, which is on our IP address of 192.168.1.5, you can do that with R3 equals requests.get, or let us just change this to R3 because we don't want to type everything once again, and we can just print here r3.text. And you can see right here, let me just check it out. Okay, yeah, we didn't really change the actual website that we are searching for. So delete this up to the 2 slashes and then 192.168.1.5. press here enter, it will perform its GET request. It will take just a few seconds, and after it finishes, we will just print the r3.text to see what we get from there. Now, of course, in that actual field, you will not be getting these headers anymore. You will be getting the actual contents of the page. So r3.text is actually the contents of the page itself that you use to load. Now, the reason why we are here getting printed the actual headers is because the actual contents of this page that we try to load are our headers. It is used to test this program, or not this program, basically any program that actually interferes with the headers themselves. So for some reason, this is taking a little bit of time. Let us see why is that. Now we can actually just try to search for a different website. Or let us actually go to our Python program. So Python programs, brute forcers, nano, iPhone 6.py. So we can just call it anything we want. User bin Python. Let us just import requests real quick. Requests. And then what we want to do is create my headers once again. We will set that to be equal to our iPhone. So open and close these weird brackets, not really sure how to call them. User-agent, two dots, iPhone 6. Okay. Then we perform the actual GET request. So requests.get. We want to get, for example, this web page right here. Doesn't even matter. You can just test this on any web page you want. Just make sure to add the HTTP and then two dots and two slashes, because otherwise it will not work, and parse the actual headers that you changed into this request, GET request. And then afterwards we can print the r.text. So let us close this, chmod the actual iPhone 6.py, and let us run this. We run our iPhone 6.py, and we can see we print different contents to our web page. Now this content is basically an HTML code of the page that you actually load once you search for that actual website. So this is the HTML code. You don't really print the requests anywhere, but you can see that we were able to connect, even specifying that we are coming from the iPhone 6 and not from the Kali Linux machine over Firefox, or in this case over Python 2, because if we actually perform the request from here, it would say that the user agent was Python 2. So you can see this actual page is huge, so let us just clear this. Now you can just change it to anything you really want. It doesn't have to be iPhone 2. You can just type here Windows 10, but you get the actual point. This is something that allows you to change your headers and therefore even be a little bit more anonymous if you want to while performing some different tasks. So that would be about it for this tutorial. Hope you enjoyed this little demonstration, and I hope I see you in the next lecture. Bye. Hello everybody and welcome back, and let us start off by coding our base or digest authentication brute forcer. Now if you're coming from my actual ethical hacking course, you already saw how we can actually brute force a base authentication. Now we will expand that program into digest authentication as well. Now digest authentication is not something that you encounter most of the time, but we can still use it in order to see how you can implement different types of actual authentication into your program. And also you can actually, even after this program is finished, add some other authentications as well. Basic is basically as it says, it is the basic authentication. It is something that you actually encounter while, for example, logging into my router. So let me just show you. If you just go right here to Firefox and try to search the IP address of my router, it will basically prompt you for the actual username and password. So let me just show you. Right here, it prompts this window. Then I log in with username and password, and these credentials will actually be delivered over the basic authentication. So let us see how we can actually brute force this. So let me just, as you can see, since I didn't type anything, it says protected object, server is protected. So never mind. Let us go to our base to our brute forces directory, and nano base or digest auth.py. Start off with the usual line, user bin Python, and I will import here everything that we will actually need for this actual program. So we can import requests right away, since we know that we are going to use this, as this is our main library in this section. We want to also import the threading library. So from threading, import thread, so we can actually use it with a little less letters in this syntax. We will also need this threading library because we all need to manage different threads that will actually brute force the actual basic authentication. So that's why we are using this library. We will use sys in order to specify the actual arguments for the program itself. We will import time in order to pause our programs if we need to. We will import the getopt library in order to actually parse our options that we are going to use in our program. And also, we want to import something new, which is from requests.auth import http digest auth. So let me just see before I actually import this. Let me see whether we can actually import it in the Python tool. So from requests.auth import http digest auth. So you can see everything works well. It's already in the Python tool, as it is a part of the actual requests library, so nothing really there to worry about. So let us just exit there. Just wanted to make sure before actually starting this program. So base or okay, so this is our program. So what we are going to do with this program is let us start off with a start function. So let us just type here def start. This function will take a different arguments, and those arguments will be the actual arguments that we specify in our command. Now the command is something that we will run from our terminal, so we want to actually make sure that we also parse those arguments such as URL, such as number of threads, username, and so on, to this actual function. So in order to do that, let's just use argv, which are our arguments. Let's add the 2 dots so we don't get the error. And first thing that we are going to do is we're going to call a function called banner. Now, this banner function is nothing really important. It will just be a simple banner for our program. We can code it right here, just so our program can look a little bit prettier. So print, and we can just do something like this. So 3 open quotes, base or digest brute force auth, doesn't even matter. You can just type here anything you want basically, and make sure to close these 3 single quotes. And this is something that will actually get printed once we start our program. So the user knows what they are running. Just as I said before, nothing really too important. What is important is as soon as the program starts, before we actually do anything, we want to check out whether the user of this program specified the correct number of arguments. For example, if we want to use 3 arguments for this program, such as URL, the number of threads, and the username, let's say, for example, a user specifies only 2 of those, we will not be able to run our program. Therefore, we need to perform the check even before we begin doing anything else. So in order to do that, we can just use simple if statement. So if length, then open brackets, if length of sys.argv, which is just the arguments from our command, is lesser than 5. Now, the reason why we are using 5 is because we are going to have 5 different arguments. First one will be the URL, the second one will be the actual username, the third one will be the file from where we are going to use the password list, so the to brute force. The fourth one will be the method that we are going to use. So you can see that we have base or digest brute force authentication. We need to make sure that we know which method are we using, and we also want to have a the option, which is going to be an option for the thread. So those are 5. So if length is, if the arguments are lesser than 5, we want to print a function that we are going to call later, or let's not print it. You can print a function, you can call a function, which we'll call just usage. This function will actually print how you can use the program, but we currently don't really need it. For now on, if it if the user specifies less amount of actual needed arguments, we'll just quit the program right after printing the usage of this program. If that is not the case, we will try to perform the getOpt of those actual different fields or arguments that the user specified. So accept, we will try, and we will accept the getOpt error. So getOpt.getOpt error, and we'll just print in that case error on arguments. We can print it like this, so 2 exclamation marks indicating an error, add a space right here, and close the double quotes. And of course, after that, we want to also quit the program once again. If it does work, we will just use the opts and arguments as 2 different variables, which will store the actual getOpt.getOpt, which is a function from the getOpt library that we imported from these different arguments. And right here, what we need to actually specify are 2 different things. First of all is the arguments themselves, so argv. As you can see, we parse them to this start function right here. And the second thing that we need to specify between the double quotes is the actual letters for these specific arguments. So this is something that you can actually pick for yourself. But for now on, what we will use is for the username, we will use U. For the URL, we will use W. Or pardon me, you do not actually need to separate it with the comma, you separate it with the 2 dots. So U, W. For the actual file containing our passwords, we will specify simply F as a file. For the method, we will use M, and for the threads, we will use T. So simple as that. Okay, so let us continue with our program. Right now, what we are going to do is we are going to use for each option and argument in this opts actual variable that we created right here. So we will iterate over this. What we want to do is check out if, for example, option equals to -u, then we will actually set the user variable to be equal to argument. So the argument will be something coming after the -u, so that is something that we will store in the username. So since that will actually be a username itself. Else if the option equals to -w, this is a URL, so we will just type here URL equals arg. Now we need to do the same for each option, so else if opt equals -f, we need to type here dictionary equals argument. Next thing, else if opt equals to the -m. What we want to type right here is that the method equals argument. And the last one, else if opt equals -t, we will print right here threads equal arg. So these are all our options covered. Basically what we are going to continue in the next lecture is basically running this program. We're going to have a function that is going to launch our threads on these different passwords from the file. We also need to open that file and read from it. So that is something that we'll do in the next lecture. We just started off our program for now on, which is more than enough for the first lecture. And we will continue coding in the next tutorial. So hope you enjoyed it, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial, or if you want, to our second tutorial of our base or digest authentication brute forcer. So what we did for now on is we only specified a few different arguments that we're going to parse to this actual program in order to separate a few different things that we will need in order to run this. So right now, the next thing we want to do after specifying the arguments is try to open the file that the user has specified as a password list or as a dictionary. So we can do that with simply try and accept rule. So what we are going to try is, as usual, try to open that file. So f equals open, we can call it just like that. What we are opening is this variable right here. Since you remember, the actual argument containing the name or the path to the file is set to be in this variable right here. So we are opening that path. Dictionary. We are opening it, of course, for the reading, since we want to read from it. And then what we are going to do is we'll just set the passwords to be equal to f.readlines, which is a function that we can use to read lines from this file. In other case, we'll just print the error, so you can just print it like this. File doesn't exist. And we can just type, please check the path. Or please check if the path is correct. You can just print something like that, doesn't even matter. What matters is that we actually close the program right after this, since there is no point in continuing, since that actual program does, that actual file doesn't exist. The next thing we want to actually do is make a function which we'll call launcher threads, and which we will actually call after this. So we want to call it right here, launcher underscore threads. And what that function will take as an input are all 5 arguments from our actual program. So what it will take passwords. Now make sure that you not actually specify the dictionary, as we already took care of that part right here. We basically opened it and we read lines, stored it in passwords variable or list, however you want to call it. And then we are going to parse passwords to our function, no longer dictionary. So the next thing we want to parse to this is the threads. We can parse the method, or let's go with the user first, then the URL, and then the method. So basically we are parsing our 5 arguments. All we are left to do right now is to actually code the function itself. So let us code it right here, def launcher underscore threads. It needs to take the same input, so passwords, th for threads, username for username, URL, and method. These are 4 arguments that this function will take. Now what this function will do is it will actually manage the threads for our program. So we will need to create a list that is going to kind of take a track of these actual threads, whether if, for example, the number of threads is smaller than the threads we specified, we will need to run a different thread. If it is not, we will have to close threads, and so on and so on. Now, how we are going to specify this? Well, first of all, we're going to create a global variable, I, which we are going to use not only in this function, but also in other functions as well. The reason for that is because it is a global variable, we will need it. So let us just type here global I. And this I is not really a variable, it's going to be a list rather. So right here, and this list will actually have our threads. So in order to start off, let us append I.append 0, and you will see just in a second why. And what we want to do next is while the length of our passwords, which is the passwords that we specified or that we got from our dictionary, while it exists, so while we are not hitting the end of the file, if hit equals to 1, and before you say right now, well, what is hit? Well, hit is a variable that we are going to code at the beginning of our program, and we will set its value right at the beginning. So we can go just up here. We will call it global hit, and we will set it to be equal to 1. Now, what this variable basically does is if you code it right here, if hit equals to 1, that means that we need to actually continue running our program. And then if we find a password for our actual website or basic authentication, however you want to call it, we will set this hit variable to be equal to 0, and therefore this part of program, which is a while true loop, or pardon me, not while true, while length loop, is going to stop executing. Then that's what we want, because this is the part of our program that's actually running the threads. This is basically some kind of a flag for this actual function right here. What we're going to try right here is if I, and then the first element of our list, is smaller than th, and you can see that we appended to our actual I the 0, so the first element will be 0. So if the first element is smaller than th, we want to create password variable to be equal to passwords.pop, pop0. Let me just show you what I'm doing right here. And then our I, the first element, will be equal the current first element, which is in our case at the first iteration 0. Let me just find where 0 is. Okay, so here it is. And then we will just add 1, which means that we are going to start one thread right now. So we want to add the number 1 to the actual list in order to keep the track of these threads right here. So, and then we create the thread, as I said. So thread equals request underscore performer, which is a function that we will call in just a second. This is basically a function that will brute force the basic authentication. So this is actually the main function itself. We will code it in the next video. For now on, let us just call the thread itself. This function will take an input from the password, username, URL, and method. Now make sure to call it the same as you called it right here when you actually parsed those different arguments right here. And all we want to do is start that thread. What this will do is it will start the thread, and it will, now this list right here will contain 1, which will mean one thread is started, and then it will continue just going through this loop while there is still passwords remaining in this current list. We will just accept this. So if we keyboard interrupt it, there is really no other way that we can actually interrupt this instead, and that it actually closes well. We will just print interrupted, and we will close the actual program. So simple as that, interrupted, and we will sys.exit the program. Make sure that after this, once you actually finish this part right here, you want to join the thread. So thread.join, open and close brackets, and that would be actually everything for this function right here. This is how we are going to manage the threads. Now, once again, let me just remind you that this hit variable is just a flag that we are going to set in our request performer function that we're going to code in the next video to be equal to 0. Once we actually hit a password or find a password, however you want to say it, then this function right here, launcher threads, can actually stop executing. So that will be about it for this tutorial. We will call this function in the next tutorial, and I hope I see you there. Bye. Hello everybody, and welcome back. And before we actually continue with this program, I just want to correct myself, because in the previous video I just watched the ending of the video and I was referring to this request performer as an actual function. It is not a function, it is an actual class that we're going to create right now, which will have a function in it that is going to run the brute forcing itself. So I didn't actually explain myself really well in the previous video. Once again, it is a class, not a function. So let us continue coding it. These are just the self arguments that the actual class will take and that the run function will actually use in order to perform the brute forcing. Now you will see just in a second what I'm talking about. Let us go up here and we can code it right here, for example. So let us name it the same. So class request underscore performer. And make sure that this actual class right here doesn't take an input of these fields right here. These are just the variables or the arguments that we are going to pass to the init function in the class request performer. What this request performer will take as an input is the thread itself. So let me just show you right here. Thread request underscore performer. And basically, first thing you need to code in every actual class is the init function, which will take, where you will actually define your different variables. So def underscore underscore init underscore underscore. It will take an argument of self, which is a usual for the classes in Python, name, user, URL, and method. Let me just check if those are the 4 that we specified right here. Username, password, URL, method. Yeah, those are the exact 4 that we specified. And what we want to do right now is actually define these variables or self variables with the actual variables themselves. But before we do that, we need to create a thread object in it with the actual self in the bracket specified. So init and then self. And then afterwards we can proceed to the self.password equals name.split. Let me just go right here to actually split it by the new line character and take the first element of that, which will be the password itself. As you can see, the name is the actual password, so we don't need to call it name, we can just call it password. Or pass, doesn't really matter. Okay, let's call it pass WD because pass is already defined actual function in the Python itself. So we'll just use this pass WD dot split. We'll take the first element, which is going to be the password itself. Self.username will be equal to the user specified. Self.url can be equal to the URL itself. So self.url equals URL. The method will also be equal to the method, and we can print which password are we currently trying. So we can just do something like this, self.password, and we can add the actual another dash right here. This is just going to print the current password that we are going to try. And now we are doing the main part of the program itself, which is the run function. Now this run function, as I said before, is going to check for the actual methods, and if the method is basic, it will perform the basic request for the basic authentication, and if the method is digest or specified as digest, will perform the HTTP digest authentication with the request library. Now it is rather simple, so don't really worry. It is nothing really to worry about. Def run. Every function in the class has to take a self object, so we can actually parse these different variables to the function in the class. We will right here use the global hit variable, which we coded at the beginning of the program itself, which is currently set to 1. And right now what we're going to do is, first of all, we will check whether it is still set to 1. So if hit or our flag is set to be equal to 1, we'll try to actually take the method itself, whether it is a basic or the digest authentication. So what we will try is we will do something like this. So if self.method equals to basic, we are going to do our equals requests.get. And what we are going to specify in these brackets right here is the URL, of course, since we need to actually type here which URL are we going to visit and get the response from. And we need to specify the authentication, which will take the arguments of the username and the password. So self.url, not comma, self.url, and then comma, auth will be the authentication, then open and close another brackets, and here specify the username and the password. So self.username, comma, self.password. So right here, this is all set to go. Let me just double check everything. So we specify the URL, we specify username and password, and then we can proceed. Else if self.method is equal to the digest method, then we want to actually perform our equals requests.get on the same URL. But this time the actual authentication will be equal to HTTP digest auth. So we're using this type of authentication, which also takes two different arguments, which is just the username, so self.username, and the password itself. Password. Make sure to close another bracket at the end of this statement. And what we are going to do is we are going to check right now for the actual status code of the page that we actually load afterwards. Now what this means, if we get a status code of 200, that means that we found the password. What we will do is we will set the hit variable or flag to be equal to 0, and that will close our program. We will print the password, of course, before we actually close the program. And in case the status code is not equal to 200, and basically, as I said before, the status code 200 means that we successfully loaded the page. So if the status code is not equal to 200, we will continue to the next password, and we will actually remove the thread from our counter, which is in the launcher threads function right here. And our counter is basically this I list right here, which is containing different threads. Or not containing, it's actually keeping track of those threads. We'll just remove one from this list right here, so we can actually keep a good track of it. And let us see how we can actually implement all of that. So first of all, as I said, let's go right here. We want to check for the status code. Now we made a request or the R variable to contain the response from this request. So if r.status_code, which is an actual thing that we can check with the request library, equals to 200, we can set the hit to be equal to 0. And we can print then. So print like this, password found, and then dash, and then the double quotes plus self.password, which will print the current password that got the status code of 200. And after we print it, we can close the actual program with sys.exit. Any other case, which will be the case that we get any other status code, we will just print not valid password, 2 dots, space, and then we'll add plus self.password. And make sure to not quit it right here. You want to, before we actually continue to the next password, we want to remove the thread from the actual counter, which we can do with this statement right here, -1. Which will just remove the actual, which will just perform the subtraction from our actual list, or the first element of our list, removing the thread itself. Now make sure that before we actually close this program and wrap it up, that we actually run the except rule as well. So we try this, and if that doesn't work for some reason, we will accept any error, so accept exception E. We can print that error to see what that error is about. So this is basically the main part of our program. What we will do in the next video is we will just actually define this usage function. Let me just see, where did we put it? I believe it is somewhere right here. We check for the arguments. Okay, so here it is. We will actually define this usage function, which we still don't have. It is just printing some string statements, how to use this program, and so on and so on. And then I will show you how fast this program can actually brute force. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial. And let us now finally code our usage function, which will just print to the user how they need to use this program, which will take the arguments, or the function itself will not take the arguments, but it will print the arguments, and it will print what each letter of the specified arguments right here that we set up right here means, because user cannot really see this code. So we want to make sure that they actually know what they are doing before running this program. So we can code the usage function right below the banner. So def usage, open double quotes, open and close brackets, and then the 2 dots. And we'll just print something like this. So print usage 2 dots. In the next line, we can actually, first of all, use the, let me just check right here, the W, which is for the URL. So we can just use that one first. We can tab it, slash or dash W, 2 dots will be equal to the URL. And then, for example, we can just specify in the brackets, HTTP / randomwebsite.com. Now, of course, you need to actually specify a slash for the actual, or it's not really that important. Just make sure that they know how to specify a website, since if you remember in the previous videos, we specified the HTTP by ourselves, and right now we didn't do that, so we need to specify to the user that they need to add the HTTP tag as well. But before I close these double quotes, let me add the bracket right here. And the next thing that we want to actually print to the user would be the username. So -u, I believe, is the username. Simple as that. Nothing really too much to explain right here. It is the username that the user would specify. Then the next thing is the number of threads. So -3. T, I believe, is the number of threads. Yeah, it is minus T, so threads. Afterwards, we can print the file that the user needs to specify in order to brute force, which is the file containing the actual password, so dictionary file. Let's type it like this. And the last thing that we need to print is the method that the user will use, so minus m, 2 dots, and then the method. In brackets, we can specify basic or digest. So simple as that. And the last part will be a simple usage or a simple example of this program, of using this program. So example, we can call it like this. So base or digest auth.py minus w http some double slash random website.com, then minus u admin minus t 5 for the 5 threads, and minus f, we can just type passwords.txt. So this is a simple example of actually of a command that will run this program. So we print that to the user as well. And right now, if I'm not mistaken, this is everything we need to specify for our program. And right now we can see how it will run. We can see how fast it will actually brute force the password. We'll just use some random list, it doesn't even matter. We just want to see how fast it goes, whether these threads help us, and whether we actually printed everything as we should. So let me save this. chmod +x base or digest authentication. Now let us just first of all just start by running the actual program. So let me just see right here, print this file doesn't exist to check if the path is correct. And here we have an actual bracket right here, which we don't need. So let us just nano the base or digest. Let me just find where that is. Here it is. First of all, we don't need this bracket, and we don't need this bracket right here. So that is first error. Let us see if we have anything else. You can see nothing really gets printed out, which is weird. Let us just type here hello. Not really sure why the usage is not being printed out. Let me check something first. If length of the sys arguments is equal, we will call usage. Okay, so why didn't you call usage then? Oh yeah, of course. This is like a huge mistake, or not a huge mistake, it's just something that we should actually have noticed, that we didn't even call anything in our program. Of course, nothing will be ran since we didn't call the function itself. So we will use if name equals to main. We will run our start function, we will try to run it, so start. And make sure to specify that it should actually run from the second element of our list of arguments and then till the end. So close the square brackets, close the normal brackets, and we will just, let me just see right here, we don't need here a square bracket, so here is a normal bracket, here is a square bracket, okay, and we will accept keyboard interrupt, and we will print interrupted. So just like that, and right now we actually call the function itself, and we can see we get the actual banner, which we will fix right now. So this has to be tabbed just like this. So let us say right now, and once again, once we run it, we get the banner, and afterwards we get the usage since we didn't specify any actual argument right here. So let us see how we can specify the argument. So base or digest authentication, then -w, and we will specify, for example, my router for the actual basic authentication, so 192.168.1.1, which is the IP address of my router, minus uadmin, and minus t, number of threads will be 5, and we forgot right here to specify the method itself, so nano base or digest authentication. And right here, -m method. Simple as that. Oops. Okay, so -w http //192.168.1.1 -u for the actual username, -t for the number of threads, -f for the actual file list or dictionary, so we'll just use the common.txt since it is in this actual directory, and -n we can just type here basic. Please check if the path is correct. File doesn't exist. Let us see why the file doesn't exist. It should exist. So what we do afterwards, file equals open dictionary for reading. Okay. Let me just find, okay, so opt -f, dictionary equals arg, then f equals open dictionary for reading. Weird, not really sure why it won't work. Or maybe it has to do something with the method itself, not really quite sure. Let's try something like this. If I just set the method at the beginning to be equal to basic, and I run it without this, base or digest authentication. What was my command? Let me just double check everything. So file common.txt. Let us go back to our program. So something is wrong, not really sure what, but we will manage to fix it, I believe. So -u, -m, -t. Okay, so why doesn't the file exist? Let us see. We just type here ls, common.txt is there. Let's try with a different password list. Maybe that password list doesn't exist. What if we specify the entire path? So /root /python program /brute forcer, and then the passlist.txt. For some reason it doesn't want to work even then. File doesn't exist. It's really weird because that is the actual part of the program that I believe works really well. F equals open dictionary. Oh, okay, so here is the error. We are missing a letter right here. Not here, dictionary. That was the actual problem. So right now, if we run this, if we run it without the full path, what do you mean? Let me just check everything right now. Maybe I named it once again. Dictionary. Is this the same word? It is. So dictionary. Let's just try to change the order for some reason. Maybe that could be presenting the problem. Then threads 5, then m basic. And then we run this. Object has no attribute password. Okay, so we got a different type of error. That is actually good. Let us see. Okay, so the error is right here. We are having an extra R right here. So let us try right now. passwd. Then what is the name if it is not passwd? Oh, so it's password. Password. Okay. Too many errors, but that is something that you will encounter a lot. Not hello world, not valid. Okay, so we got our program to work, finally. Not valid password, not valid password, not valid password. Let us just right now try to actually use a password list that is a little bit longer, which is common.txt. And my username is not even admin, so it doesn't even matter. We can just go and you can see it actually brute force really, really fast. For an online brute forcer, this is actually really good. We can see that it works. We don't get any errors anymore. We had to deal with a few errors, but we managed to fix it, so everything is good. And our program finally works. So that would be about it for our basic or digest authentication brute forcer. We're going to continue coding in the next lecture, and I hope I see you there, and take care. Bye.